Hey guys, welcome to the first video on OpenCV tutorial for beginners using Python. In this video, I'm going to give you a brief introduction about OpenCV. But first of all, let's see what is computer vision, because OpenCV is an open source computer vision library. So computer vision is the way of teaching intelligence to machines and making them see things just like humans. So what happens when a human sees an image? He will be able to recognize the faces which are there inside the images. So in its simplest form, computer vision is what allows computers to see and process visual data just like humans. Computer vision involves analyzing images to produce useful information. So to give you some examples, a self-driving car, it can detect the lanes using computer vision. Or you might have wondered how Facebook detects images when you upload the images of you with your friends. It becomes possible by Facebook's face and image recognition technology. So now let's see what is OpenCV. So OpenCV, which stands for Open Source Computer Vision, is a library of programming functions mainly aimed at real-time computer vision. It is originally developed by Intel, and then it was later supported by a developer called Velo Garage, and now it is supported and maintained by ITCs. Now OpenCV is available on Mac, Windows and various Linux operating systems. So we can say that OpenCV is a cross-platform library. Now you can work on OpenCV using C, C++ or Python, and we will be using Python to learn OpenCV. Now OpenCV is an open source and free library which is licensed under BSD license. And it's said that it is very easy to use and install. That we will see when we will install OpenCV on various operating systems. Now because OpenCV primarily deals with computer vision, that means dealing with mainly images or videos, so I wanted to show you how a digital image is seen by a computer. So digital images are typically stored in the form of matrix. Now if you have heard about PPI or pixel per inch, which refers display resolution, that means how many individual pixels are displayed in 1 inch of digital image. So when a computer sees a picture, it sees it in the form of pixel matrix. Now there are two types of digital images. One are called grayscale images and other are called colored images. So in grayscale images, each pixel represents the intensity of only one shade. That means how bright or dark the pixel is. In other words, it is said that it has only one channel. So on the right hand side you can see a grayscale image, and on the left hand side you can see a colored image. So in colored images we have three channels, that is RGB, which stands for red, green, blue. So grayscale images have one channel and colored images have three channels. Your standard digital camera have three channels, that means red, green, blue channels. So we will learn more about images and how we can process images using OpenCV in the later videos. Now there is one more thing which I want to show you is NumPy. So we are going to learn OpenCV using Python. So when you will install OpenCV library for Python on your operating system, NumPy will be automatically installed with this library. So first of all, what is NumPy? So NumPy is a highly optimized library for numerical operations. Now as I told you, digital images are 2D arrays of pixels, and NumPy library is a general purpose array processing package library. So it provides a high performance multi-dimensional array object and tools for working with these arrays, which makes the processing of images easier. Now all the OpenCV array structures are converted to and converted from NumPy arrays. And in addition, you can use more convenient indexing system rather than using for loops. So when you want to learn OpenCV using Python, you need to have some knowledge about NumPy also. So if you have some knowledge of NumPy library, it's good, but don't worry, I will teach you step by step so you will not miss anything. So that was a brief introduction about computer vision and OpenCV. In the next video, I'm going to show you how you can install Python OpenCV library, and then we will see how we can work with this OpenCV library. So that's it for this video. I will see you in the next video. Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video, I'm going to show you how you can install OpenCV for Python on your Windows operating system. So obviously you need to install Python on your Windows operating system in order to install OpenCV for Python. So first of all, I'm going to show you how you can install Python on your Windows operating system, and then we will see how to install OpenCV using Python. Now, if you have already installed Python on your Windows operating system, you can skip about 5 minutes of this video and go directly to the point where I am going to show you how you can install OpenCV for Python. So let's get started. So first of all, open your favorite browser on your Windows 10 operating system and then search for Python. And the first link which will appear here will be from python.org. So we are going to click on that link. And once this python.org website is open, you just need to scroll down a little until you see this downloads section. And you can see at the time of making this video, Python 3.7.0 is the latest version of Python available. So we are going to click on this link which says Python 3.7.0, and you will be redirected to this page which says Python 3.7.0. And now I'm going to scroll down until I see the files here, and you will see there are various kinds of installer available here. We are going to install the Python using the executable installer. So we are going to choose this option which says Windows x86 -64 executable installer, and now I will wait for this executable to be downloaded. And once this executable is downloaded, you just need to click on this exe file, and I'm going to minimize the browser here. So you can see Python's 3.7.0 setup window has been started, and on the first window you will see two options here. One is install now and other is customize installation. So what we are going to choose is this option which says customize installation, because when you choose this install now option, Python will be installed at this path which I don't want to use. You can see it's a long path which I don't want to remember. So I will use this option which says customize installation, and I will also check this option which says add Python 3.7 to path. So now let's click on customize installation, and next you will see this optional feature window, and you can see there are some optional feature which this Python installer will install. For example, documentation, pip it will install, which is a Python package manager, idle IDE, Python test suite, and other feature it's going to install. So I'm going to leave everything as default, and then I'm going to click next. And now this next window will open which says advanced option. Here I'm going to check this option which says install for all users, and I'm going to leave other check boxes as checked. And then you will see this section here which says customize install location. So I want to install Python on my C directory. So what I'm going to do is I'm going to open the Windows Explorer, and I'm going to go to the C directory here. And once the C directory is open, I'm going to right click here and I'm going to create a new directory, and I'm going to name this directory as Python, and then I'm going to press enter. And this path I'm going to give here in the customize install location. So I'm going to just give this path which says C:/Python and then \Python 37. 3.7 here means that we are going to install 3.7 version of Python. So now Python will be installed at this location on my computer. And then I'm going to click on the install button here. And then you will see the installation will start and it will be finished in a few seconds. So just wait for the installation to complete. And after some time, I can see this message which says setup was successful. So I'm going to click on this close button, which is going to close this installer. So now in order to check whether Python is installed on our Windows operating system or not, we are going to search for Python here, and you will see a few options here. One is this Python 3.7 terminal. Other is idle IDE. So first of all, we are going to click on this option which says Python 3.7 64-bit, which is going to open this kind of terminal. So this is a Python terminal, and here we can, for example, print something. So I'm going to just write print, and in the parentheses and in between the double quotes, I can just write hello world and then press enter, which is going to in return print hello world. That means Python 3.7 terminal is working. So I'm going to close this terminal now. And once again, I'm going to search for Python here. And this time I'm going to select this option which says idle. Okay, so just select this option which says idle, and in the parentheses Python 3.7 64-bit. So this idle is an IDE which comes with Python installation. At the time of installation, we have chosen this option to install idle. That's why we can see this option here. And also this is an interactive shell. So you can once again write print, and inside the parentheses, you can just write, for example, once again, hello world, and then press enter, and it's going to give you this kind of output here. So now Python interactive shell is working and idle IDE is also working. So I'm going to close this idle IDE, and now I want to check whether Python is working using my command prompt or not. So I'm going to right click on this Windows button, and then I'm going to click on command prompt, and here I'm going to first of all write Python and then press enter. And you can see this Python option is working now even on your command prompt, right? So here also you can just write print, and inside the parentheses you can just print hello world and then press enter, and it prints hello world in return. Now once Python is installed on your Windows 10 operating system, we are going to install OpenCV using pip. Now pip is automatically installed on your Windows operating system with the Python installation. So you don't need to separately install pip on your Windows operating system. It comes automatically with your Python installation. So to verify this, first of all, I'm going to check the Python version. So you can just give this command Python -- version, and then you can check the pip version. So you can just give this command pip -- version. So just give this command, and it's going to give you the version of pip which is installed on your Windows operating system. So to install OpenCV using pip, you just need to give this command pip install OpenCV - Python, and I'm going to press enter. So you can see OpenCV related packages are downloading now. So now OpenCV Python package is installed using pip on my Windows operating system. Now you will observe one more thing here, and that is NumPy package will be automatically installed with your OpenCV Python package. So now once OpenCV Python package is installed, we can verify it by just opening our Python shell. So I'm going to just give a Python command to open the Python shell. And then here I'm going to just write import cv2. Okay. So once you give this command, it should not give you any error. And if this import gives you error, that means OpenCV is not correctly installed on your operating system. Now after importing, you can just check the version of OpenCV which you have installed using cv2 dot underscore underscore version underscore underscore, and then press enter, and it's going to give you the version of OpenCV which is installed on your operating system. And in our case, this is 4.0.0 at the time of making this video. Now you can check the same by writing your code inside a Python file also. So here I have opened my Visual Studio Code editor and I have already created sample.py file, and here also I'm going to import the CV2 package first of all, and then I'm going to print the version of CV2 using this print statement. So I'm going to just write CV2 dot underscore underscore version underscore underscore and then save this script. And to open the terminal inside Visual Studio Code, you can just press Ctrl Shift P and then type toggle integrated terminal. So just type toggle integrated terminal and then click on this first option which says toggle integrated terminal. This is going to open the terminal inside your Visual Studio Code editor. So here you can run your Python script using the Python command. So Python and then name of the script, which is sample.py in my case, and then press enter. And it's also going to give you the version of OpenCV which is installed on your operating system. So this is how you can install OpenCV for Python on your Windows operating system. I hope you have enjoyed this video and I will see you in the next video. Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In the last video, we have seen how we can install OpenCV for Python. Now from this video, we will actually start writing some code. Now moving forward, I will be using PyCharm IDE to demonstrate how OpenCV works, but you are free to use any IDE or any other editor in order to use OpenCV. Now on PyCharm IDE, you need to install OpenCV little bit differently. So if you are using OpenCV, you just need to create a project inside OpenCV, and then you just need to click on File and then go to the settings. Now once this settings window opens, you just need to go to the project and then it'll say after colon your project name. So my project name is OpenCV examples. That's why it's written here OpenCV examples. So project colon your project name. So just click on this section and then click on project interpreter. And on the right hand side, you will see all the packages which comes pre-installed when you create a project inside PyCharm IDE. Now we want OpenCV Python package. So to install OpenCV Python package on PyCharm, you just need to click on this plus button here, and then you just need to type OpenCV -Python. Now the first result you can see here is OpenCV -Python, and the version which is available right now is 4.0.0.21, which is the latest version. So to install this package for your PyCharm IDE, you just need to click on install package button, and then after some time you will see this message which says package OpenCV -Python installed successfully in the green bar. That means OpenCV package is installed successfully. So you can close this window, and now you will be able to see OpenCV -Python is added to your packages, and also NumPy is added to your packages which comes with your OpenCV Python package. So I'm going to just click OK, and now you will be able to import this CV2 package in your Python script. Now in this video, I'm going to show you how you can read images and write images using CV2 package. Now let me show you where you can find some sample images for your project. So you can open the browser and then go to this URL github.com/OpenCV. So just go to this URL, and then under this OpenCV project in GitHub, you will be able to see these repositories. You just need to choose this repository which says OpenCV, and then you can scroll down, and all the images you will find inside the samples folder. So I'm going to go inside the sample folder, and then inside the sample folder you just need to go inside the data folder. So here you will find many sample images and videos and other files which you can use in your project for the learning purpose. So you can use these images in order to develop your example. So what I generally do is I just go to this repository, which is under the URL github.com/opencv/opencv, and then I either download the zip file of this project or clone this GitHub repository on my operating system. And once you clone or download this repository, it will look like this. So it will be downloaded as this folder, which is OpenCV-master. And once again, you can go to the samples folder here, and inside the samples folder you can go to the data folder, and you will find all those images which I have shown you on the GitHub repository. Now to start with, we will be using this image, which is lena.jpg. So I'm going to just copy this image for now, and then I'm going to go to my PyCharm IDE, and then I'm going to just paste this image inside my project. So this JPG image will be directly available inside my project folder. Now let's see how we can read images using the CV2 module. So you just need to use CV2, and there is a method called IMRead which enables you to read the images. So the first argument which you need to give here is the image name. So I'm going to give the image name, which is lena.jpg. And the second argument here is a flag. So there are three flags you can give here. You can either give 0 or 1 or -1 flag here. So this second argument is a flag which specifies the way images should be read. So let me show you all the flags here. So the first flag is cv2.imread_color, or you can give the integer value of it, which is 1. And whenever you give this flag as the second argument of IMRead function, it's going to load the colored image. If you give this flag, which is cv2.imread_grayscale, or if you give this integer value, which is 0, it's going to load your image in grayscale mode. And the third flag is IMRead_unchanged, or the value -1, which is going to load your image as it is, including the alpha channel. So for now, we are going to just give here 0 flag, which means we want to load our image in grayscale. So now let's run the code and let's see what happens until this point. So you can see our code runs fine without giving any error. Now let me give any random name here as the file name, and once again run this code, and once again you will see that there is no exception which is thrown here. So even if you give the wrong file path or file name here, this function is not going to give you any error. Now in case of wrong path or wrong file name, let's say I'm going to just assign this value to a new variable, which is img, and let's print the value of this img using the print method, and then let me run the code once again. And you can see whenever you will give the wrong file name here or wrong path here, as a result of this method you will get none. So you can check the value of image, and if it is equal to none, then you know that you have done something wrong, or you have given some wrong file name or wrong path here. Let's give the correct file name. So I'm going to give the correct file name and then run the code once again. And now this time you will see it's going to give you a matrix, which means that it has read all the pixels from this image and then assigned it to our img variable, and the result you can see in the form of this matrix. So until now we have just read the image. Now we want to display our image. So in order to display our image, what we can do is we can use a cv2.imShow method. So just write imShow here, which is going to show your image. So the first argument here will be the name of your window in which your image will open. So you can give any name here. For example, I'm going to give image name here to my window, and then the second argument is the image variable which you have read using the imRead method. So I'm going to just pass img variable, which is this variable here. So now will it show the image? Let's check. So I'm going to run the code once again, and you can see the image is shown for a millisecond and then it disappears. So now we need to add something which will wait for the image to disappear. So I'm going to add one more method here, which is cv2.waitKey. So this cv2.waitKey is the keyboard binding function, and the argument which it takes is the number of milliseconds for which you want to show your image window. So let's give 5000 value here, which means we want to show the image for 5 seconds. And at last, what we are going to do is, after we have done seeing our image, we will destroy the window which we have created. So you can just give this method cv2 destroy all windows. So destroy all windows simply destroys all the windows which we have created. There is one more method which is destroy window, and this method you can use to destroy a particular window, which we will see little bit later, but for now we will just use this method which says destroy all windows. So now let's run our code and let's see what happens. So now this time you can see our image is loaded for 5 seconds and our image is loaded in grayscale mode. Now if you give here 0 as the argument of waitKey method, then let's see what happens. So I'm going to run my code, and now you will observe that your window will not disappear after 5 seconds or any number of seconds. It's going to wait for the closing of this window, which we can close from this close button. And you can see it's loaded in the grayscale mode. I'm going to close this window, and here as an argument of imRead image, the second argument I want to give here right now is 1, which means the colored image. And let's run the code, and you can see this image is loaded in the colored mode now. Let's also check the -1 argument, which is unchanged. So it's going to just load the image as it is with alpha channels. So let me just close this image once again. So now we have understood how we can read an image using imRead function. So let's see how we can write an image to a file using a function called imWrite. So we are going to just use cv2 once again, and then there is a method called imWrite, which you can use to write an image in the form of a file. So the first argument here will be the image name, whatever you want to give here. So here, let's say we want to give the name to our image as lena_copy.png. So the image will be saved as the file name lena_copy.png file, and the second argument which it takes is the image you want to save. So let's save the same image which we have read using the imRead function inside this img variable and pass it as the second variable here. And let's run the code and let's see what happens. So our image is loaded using this imShow function, and now when I close this window here, you will observe one more file will be created here. So let me just close this window, And now you can see as soon as I close this window, this method is called, and after this I am right method will be called. And when this method is called, this image is created with the name lena_copy.png. We can also open this image and you can see it has the same image which we have seen in the case of lena.jpg. So let me close these two images. So now we have understood how we can read the images and write the images using IamRead function and IamWrite function. So let's make our code little bit better. And what we want to do here now is, let's say if somebody presses an escape key, then only we want to destroy all the windows without saving it into a new file. Otherwise, if somebody presses the S key, then we are going to save this file with the new name, let's say lena_copy.png file. So I'm going to just capture the output of my wait key. So just create a new variable, let's say k. So now when we press any key, this key will be captured in this variable. Now, as you know, every key has its own value. So we are going to just use if condition, and we are going to just check whether the value of k is equal to 27, which means that we have pressed the escape key. And if somebody have pressed the escape key, we are going to simply destroy all the windows. Otherwise, let's give the second condition, which is L if k is equal to ord, and this is a built-in function and it takes one argument, which is the key name which we want to press. So let's say somebody presses the S key, and if somebody presses the S key, we just want to save the image which we have read using the IamRead function to a second image which we call lena_copy.png, and then we will simply destroy all the windows which we have created using IamShow method. So let's run the code and let's see what happens. So I'm going to run the code. So this image is loaded, and as soon as I press escape button, you can see this image disappears. That means this condition is met and this method is called, and all the windows will be destroyed without saving the image. Let's delete this image and let's see what will happen when we press the save key. So let me just delete this image, and now let's run the code once again, and this time I'm going to press the S key, and once again you can see the windows are destroyed, but this image is created once again using this function. That means this time this condition is fulfilled and this image is created, and after that all the windows are destroyed. So this code is working fine for me, but in the documentation it's also written that if you are using a 64-bit machine, it's better to use this notation with your wait key method, which is wait key and this mask here. And then once again when we run our code, it works as it is. But in case if it doesn't work, you can try using this mask here. So this is how you can read and write images using OpenCV. I hope you have enjoyed this video, and I will see you in the next video. Hey guys, welcome to this course on Python programming for beginners. So why learn Python? Because using Python, you can build almost anything. Python can be used for web development, game development, computer vision, robotics, graphical user interface development, and also Python is the #1 language of choice for machine learning, data science, and artificial intelligence. So the goal of this course is to provide you the working knowledge of Python programming. We will start with the basics, starting from the installation of Python on your operating system, and then we will learn all the basic concepts in Python programming like variables, data types, operators, control statements, loops, strings, functions, and also Python collections like lists, tuples, sets, and dictionaries. Then we will move to the object-oriented programming concepts in Python. So in this section, we will start with what is object-oriented programming, what are classes and objects, and then we will cover the concepts like encapsulation, inheritance, polymorphism, abstraction, and access specifiers. Also, we will see some advanced object-oriented programming topics like abstract classes and compositions. Next, we will see how we can handle exceptions using Python programming. Then we will move towards some advanced topics like Python iterators, generators, decorators, and also we will cover some functional programming concepts using Python. I will also cover how you can debug your Python code, and also we will see how to use pip, which is a Python package management system, to install and manage your software packages written in Python. Now, if you want to see the whole list of topics which will be covered in this video course, then you can see the description of this video and you will be able to see all the topics which will be covered in this video. So by the end of this course, you will be able to apply whatever you have learned in this course in your own projects or for applying for a Python programming job. So what are you waiting for? Let's get started. In this video, I'm going to give you a brief introduction about Python. So let's get started. So first of all, what is Python? So Python is a high-level dynamically typed programming language. Python supports multiple programming paradigms including object-oriented, imperative, functional, and procedural styles. Now, Python is an interpreted language. So what do we mean by interpreted? To understand this, we need to understand the difference between the compiled languages and the interpreted languages. So some languages like C, C++, Java are all translated by running the source code through a tool called compiler. This compilation of source code results in a very efficient bytecode that can be executed any number of times. Now, interpreted languages like Python, in contrast, must be parsed, interpreted, and executed each time the program is run, thereby greatly adding the cost of running the program. So, a compiled language takes the entire program as a single input and converts it into machine code or byte code, which is stored in a file called a binary file. On the other hand, interpreted languages like Python takes the single instruction as single input and execute that instruction. Now, compiled languages run faster because compilation is done before the execution. On the other hand, interpreted programs run slower because compilation and execution takes place simultaneously. In case of Python, even though it's an interpreted language, but it's really fast. Now, Python supports dynamic data types. And to understand this, we need to understand the difference between statically typed programming languages and dynamically typed programming languages. So, at statically typed programming languages do the type checking at the compiled time as opposed to the real time, and dynamically typed programming languages do type checking at runtime as opposed to compile time. So let's say you declare a variable x is equal to 9 in Python. Python will do its type checking at runtime, whether it's an integer or a string or a double value. All will be done at the runtime. Now, Python is independent from platforms. That means it's a cross-platform programming language. That means you can run your Python code on Windows, Linux, Mac, or on any other Unix operating system. Now, Python focuses on faster development time. So Python code has a very natural style to it, which makes it easy to read and understand thanks to the lack of semicolons and braces. So we don't use semicolons or braces in Python. That means faster development time, especially when you are doing some prototyping work. Python is a highly readable language and has a clean visual layout. So if a developer writes a very efficient Python program, it's like reading English language. Now Python have high level internal object data types and have automatic memory management, and at last Python is free and open source. That means you don't need to pay anything to start learning Python. Now let's talk about some history about Python. So Python was conceived in late 1980s and its implementation began in December 1989 by a developer called Guido van Rossum in Netherlands as a successor of a programming language called ABC. Now Guido van Rossum worked at Google from 2005 to December 2012, where he spent half of his time in the development of Python programming language. And nowadays Van Rossum is working in a company called Dropbox. And from where this Python name come from? Rossum chose the name Python since he was a big fan of Monty Python's Flying Circus. So Python was first publicly released in February 1991, and python.org, which is the official website of Python, was released in the time period between 1996 and 1997. In the year 2001, Python Software Foundation was created and Van Rossum remained the principal author of Python. His continuing central role in Python development is reflected in the title given to him by Python community, which is Benevolent Director of Life. Now, what is a Benevolent Director of Life? This is a title given to small number of open source software development leaders, typically the project founders, who retain the final say in the dispute or arguments within the community. So why learn Python? Because Python is fun to use scripting language. And as I said, Python is a multi-paradigm programming language which supports object-oriented, imperative, functional programming and procedural styles. That means it's highly recommended for the educational purpose. So majority of educational institutes use Python as the first language which they teach to their students. And why it's the first choice of educational institutes? Because it's very easy to learn and it runs on any platform. Now Python is very powerful, scalable and easy to maintain programming language which enables high productivity, and it has lots and lots of inbuilt libraries which a developer can use. Python is also used as a glue language which acts as an interactive front end for the languages like C and C++. So when you develop in Python, it reduces the development time, it reduces the code length, it is easy to learn and use as a developer. It is easy to understand codes, it is easy to do team projects in Python, and it's really easy to extend to other languages if you are using Python. So where can you use Python? So because Python is a general purpose programming language, it is used in many web development frameworks. For example, Django and Flask recently became very popular for web development. Now Python is also widely used in scientific computing, data mining and machine learning, and continued growth and demand for machine learning developers may be driving the popularity of Python. Now as I said, Python is used as a scripting language. That means if you are doing prototyping, it's really efficient to use Python. Python is also used in the development of graphical user interfaces, embedded applications, gaming and DevOps tools. And at last, as I said, because Python is really easy to learn, it's used for educational purposes as the first programming language for teaching programming. Now the question arises, which version of Python should you learn? Python 3 or Python 2? So I would recommend Python 3 since it's more modern and it is a more popular option at this point of time. So I will be teaching this course in Python 3. So this was a brief introduction about Python. From the next video, I'm going to show you how to install Python and how to use Python as a programming language. In this video, I'm going to show you how to install Python 3 on your Windows 10 operating system. So let's get started. So first of all, open your favorite browser on your Windows 10 operating system and then search for Python. And the first link which will appear here will be from python.org. So we are going to click on that link. And once this python.org website is open, you just need to scroll down a little until you see this downloads section. And you can see at the time of making this video, Python 3.7.0 is the latest version of Python available. So we are going to click on this link which says Python 3.7.0 and you will be redirected to this page which says Python 3.7.0. And now I'm going to scroll down until I see the files here, and you will see there are various kinds of installer available here. We are going to install the Python using the executable installer. So we are going to choose this option which says Windows x86-64 executable installer, and now I will wait for this executable to be downloaded. And once this executable is downloaded, you just need to click on this exe file, and I'm going to minimize the browser here. So you can see Python's 3.7.0 setup window has been started, and on the first window you will see two options here. One is install now and other is customize installation. So what we are going to choose is this option which says customize installation, because when you choose this install now option, Python will be installed at this path which I don't want to use. You can see it's a long path which I don't want to remember. So I will use this option which says customize installation, and I will also check this option which says add Python 3.7 to path. So now let's click on customize installation, and next you will see this optional feature window, and you can see there are some optional feature which this Python installer will install. For example, documentation, pip it will install, which is a Python package manager, idle IDE, Python test suite, and other feature it's going to install. So I'm going to leave everything as default, and then I'm going to click next. And now this next window will open which says advanced option. Here I'm going to check this option which says install for all users, and I'm going to leave other check boxes as checked. And then you will see this section here which says customize install location. So I want to install Python on my C directory. So what I'm going to do is I'm going to open the Windows Explorer, and I'm going to go to the C directory here. And once the C directory is open, I'm going to right click here and I'm going to create a new directory, and I'm going to name this directory as Python, and then I'm going to press enter. And this path I'm going to give here in the customize install location. So I'm going to just give this path which says C:/Python and then \Python 3.7. 3.7 here means that we are going to install 3.7 version of Python. So now Python will be installed at this location on my computer, and then I'm going to click on the install button here, and then you will see the installation will start and it will be finished in a few seconds. So just wait for the installation to complete, and after some time I can see this message which says setup was successful. So I'm going to click on this close button which is going to close this installer. So now in order to check whether Python is installed on our Windows operating system or not, we are going to search for Python here, and you will see few options here. One is this Python 3.7 terminal, other is idle IDE. So first of all, we are going to click on this option which says Python 3.7 64-bit, which is going to open this kind of terminal. So this is a Python terminal, and here we can for example print something. So I'm going to just write print, and in the parentheses and in between the double quotes I can just write hello world, and then press enter, which is going to in return print hello world. That means Python 3.7 terminal is working. So I'm going to close this terminal now, and once again I'm going to search for Python here, and this time I'm going to select this option which says idle. Okay, so just select this option which says idle, and in the parentheses Python 3.7 64-bit. So this idle is an IDE which comes with Python installation. At the time of installation we have chosen this option to install idle. That's why we can see this option here. And also this is an interactive shell, so you can once again write print, and inside the parentheses you can just write, for example, once again hello world. and then press enter, and it's going to give you this kind of output here. So now Python interactive shell is working and idle IDE is also working. So I'm going to close this idle IDE, and now I want to check whether Python is working using my command prompt or not. So I'm going to right click on this Windows button, and then I'm going to click on command prompt, and here I'm going to first of all write Python and then press enter. And you can see this Python option is working now even on your command prompt, right? So here also you can just write print, and inside the parentheses you can just print hello world, and then press enter, and it prints hello world in return. So now we have successfully installed Python on our Windows 10 operating system. In this video I'm going to show you how to use mathematical operators and how to do basic math in Python. So first of all, we will open the idle IDE. So just search for Python once again. I have shown you this method in the last video also. So just search for the Python once again. And in the last video, I have shown you how to install Python. And with the Python installation, this idle is also installed, right? So we are going to open this idle IDE. Now some of you who are familiar with Python and have some experience with Python may think that why am I using this Python idle IDE? Because there are many better IDEs and editors available for the development of Python. So don't worry, I'm going to show you everything how to install other IDEs which are preferred in the development of Python step by step. But for now, we will start with this idle IDE. So the first thing which I want to do here is I want to increase the font size first of all in the idle IDE, because this may be not visible to some of you. You can change the font size by just changing this number, and I'm going to change it to, for example, 18 and bold. So we will be able to see our fonts in a better way. So now everything is set. So let's get started with the programming. So let's start with the basic math operations. So let's say I want to add something. So I can just write number plus, which is an operator, and the other number, and then press enter, and you will get the result of this expression. Now let's try the subtraction. So let's say I want to subtract 60 minus 50, and then press enter, and it gives the result. Let's do the negative subtraction. So I'm going to just write 60 plus 50 and then press enter, and it's going to return me the negative value. Now let's do the division. So for example, I want to divide 50 by 3. I'm going to press enter, and you can see it gives me a float value or a decimal value. And if you are familiar with other languages like Java or C++, this may appear a little bit strange to you, because when you do the same operation in Java or C++ with this division operator, you will get the different answer, which is 16 and not these decimal float value. So if you want to just get an integer value and not the decimal value out of the division, then you can write this expression, which is 50 /3, okay, and then press enter, and now you get 16, which is a whole number or an integer. This type of division is also called the floor division, in which you get the whole number as the answer and the decimal value is truncated out of your answer. So if you want to get the exact value out of the division in decimal values also, then you can use this expression, which is single / operator. And if you want to do the floor division, then use these two / symbols. Now it's also possible to divide two decimal values. So decimal values in Python and most of the other languages are called the float values. So here instead of 50, I can just write 50.0 divided by 3.0, which is also valid. Or I can write 50.0 divided by 10, and then press enter, which gives me 5.0. And when I write the integer, which is 50 divided by 10, it will also give me this value, which is 5.0. Now let's try some multiplication. So if you want to do multiplication in Python, you use a number and then this asterisk symbol and then second number and then press enter, and this is going to multiply these two numbers. So this is the multiplication operator, which we can use to multiply two numbers. Now this is what we are doing here is, for example, multiplying two numbers or dividing two numbers or addition of two numbers or subtraction of two numbers. In Python it's called expression. Okay, so 50 multiplied by 10 is an expression, and I have already told you that these symbols for multiplication or division are called operators. Now the number on which you are doing these mathematical operations are called operands. So 50 here is an operand, 10 here is an operand, or 3 here is operand, and 50 here is operand. Now here 50 and 10 are also called literals because they are constant values. So what we have learned till now, this is an expression, this is an expression, or 50 divided by 3 is an expression. The number on which you operate on are called operands, and these symbols which you can use to multiply, divide, add or subtract are called operators, and these numbers are also called literals when they are constants. Now let's try some modulo operations. So for example, I'm going to just write 10 modulus 3 here. What it's going to give us is the remainder of the division of these two values. So 3 multiplied by 3 is 9, which leaves the remainder 1, and that's the result we are getting. Okay, let's try it once again. So for example, I will divide 21 divided by 5. It will give me the answer 4.2, but when I do 21 modulo 5 and then press enter, it's going to give me the remainder of the division of two values. Now there is another interesting operator which is called exponent operator, which you can use for the exponent values. So for example, I want to get the result of 2 to the power 5. How can I do it? So I can just write 2 and then double asterisk and then 5, which means 2 to the power 5, and then when I press enter, it's going to give me 32. Or I can just write 10 and then I can just write double asterisk and then for example 10 once again and then press enter. It's going to give me the result of 10 to the power 10. Now it's also possible to do these mathematical operations on more than one number. So for example, I can write 5 plus 5 plus 6 plus 9, and it will give me the result of the addition of these four numbers. And it's also possible to use different type of operator in one expression. So I can write 5 plus 9 minus 6 multiplied by 10, for example, and it's going to give me the result of this expression. Now there is one question which may arise here is, for example, once again I'm going to do 5 plus 9 minus 6 multiplied by 10 and divided by 20 and press enter here. It's going to give me this value, but how this value is calculated? What operation is executed first? Is the multiplication is done first, or is the division done first, or the addition took place first, or the subtraction took place first? So I have this table, and here you can see the precedence of these operators. So in this table, highest precedence is at top and lowest is at bottom. That means parentheses have the highest priority, and then the exponents have the priority, and then the multiplication and division operators have the same priority here, and at last the subtraction and addition have the same priority. But whenever you use these operators which are in the same box in a same expression, then whatever operator you use on the left have the highest priority, and whatever operator you use on the right have the lower priority. So in this table, parentheses have the highest priority and the addition and the subtraction have the lowest priority. And for example, if you use multiplication and division in the same expression, then the priority is decided which operator is appearing on the left. So if the operator is appearing on the left, it has the highest priority than the operator which are on the right side. So let's take an example of that. So for example, so first the addition of these two numbers will happen, and then the division of these two numbers will happen because parentheses have the highest priority. And then the result of these two numbers will be multiplied by 6 because multiplication have the highest priority out of these two operators, which are minus and multiply. So multiplication operator have the highest priority. And at the end, the subtraction of the result will take place. So let's press enter and let's see what's the result. So the result here is 11. And how we get this result here? So 5 plus 9 is 14, and the division of these two numbers is 1 by 2. So 6 will be divided by 2, which is 3, and then at last 3 will be subtracted from this result, which is 14, which will give you 11. Once again, for example, you use 60 multiplied by 20 divided by 30 and then press enter, it will give you 40. But in which order this calculation will happen? First of all, this multiplication will take place because in the table we have seen that multiplication operator and division operator have the same priority, and that's why the priority will be decided from left to right. Now if you want to learn the order of precedence between the operators, then you can use this keyword, which is PEMDAS. P stands for parentheses, E stands for exponents, M stands for multiplication, D stands for division, A stands for addition, and S stands for subtraction. Okay, so you can either remember this name, which is PEMDAS, or you can use this sentence which I have written here. So please excuse my dear Aunt Sally, and you need to remember the first letter of each word here. And the first letter of every word, for example, P here stands for parentheses, E here stands for exponent, M and D here stands for multiplication and division, A and S here stands for addition and subtraction. So for remembering, you can either use this sentence or you can remember this keyword. In this video, we will talk about Python variables and types. So first of all, what is a variable? So according to Wikipedia, in computer programming, a variable is a storage location paired with an associated symbolic name, also known as variable name or identifier, which contains some known or unknown quantity of information referred to as value. Now in simple words, a variable is a named place in the memory where a programmer can store data and later retrieve this data using the variable name. Now the programmer gets to choose the name of this variable which is declared, and programmer can change the content of this variable in the later statements. So let's see how we can define a variable in Python. So you can define a variable using any name. For example, you can give my int as a name, and then using an assignment operator, which is this equal to symbol, you can assign some value to this variable, for example 9, and when I press enter, this value 9 is assigned to this variable, which is my int. And now on, I can just get the value of this variable using the variable name. So when I write my int and then press enter, it gives me the value which is assigned to this variable. Now, as I told you in the first introduction video of this course, that Python is completely object oriented and it's not statically typed. So you do not need to declare the variables before using them, or you do not need to declare the type of the variable. And further, every variable in Python is an object. So if you have learned some other languages like C, C++, Java, or other statically typed languages, you may have observed that before writing the variable name, they give the type of the variable. For example, in other languages, for defining integer, they have to first define the data type of that variable, and then they define the variable name, and then they assign any value to it. But in Python, you don't need to define this data type here. And whenever you define a variable, you need to assign some value to it so that Python will be able to understand the type of data you want to store in this variable. So this type of notation, when I press enter here, it's going to give me error which says invalid syntax, because this type of variable declaration is not allowed in Python. Now there are some rules which you need to follow in order to declare a variable in Python. And these rules are: a variable must start with a letter or underscore. Okay, so you cannot start the variable name with a number or some unknown symbol. The second rule is a variable must consist of letters, numbers, and underscores and no other special symbol. And the third rule is variables are case sensitive. So let me show you the demo of all the rules which are related to declaration of variables in Python. So let's say we have defined this variable myInt. I cannot get the value of myInt when I write, for example, my with capital letter and then int here. And it's going to give me an error because variables in Python are case sensitive. So this variable name is different from this variable name. Now, as I told you, you can define a variable starting with the letter. It's totally valid. So let's define this variable. Age is equal to 10, which is valid. You can also define a variable with the combination of letters and numbers, and it's also totally valid. But a variable name cannot start with a number. So when you write something like this and assign some value to it, it's going to give you an error which is a syntax error. So a variable name cannot start with a number. A variable name can start with underscore and it's totally valid. But apart from underscore, when you use some special character, for example, hash age is equal to 10, it's not valid. So whenever you try to get the value of age, it's not going to give you the value which is stored inside this variable. Also, you cannot use any other special symbol between the variable names. So for example, I can write age.22 here is equal to 22, which is not a valid syntax because we have used this dot symbol in between the variable declaration. So these are some of the ground rule in order to declare a variable in Python. Now, apart from that, there are some reserved words in Python which also you cannot use in order to declare a variable. For example, these are some of the words which you cannot use in order to declare a variable. For example, and, del, for, is, raise, you cannot use to declare a variable. So let's say I'm going to go to idle once again and I declare a variable called for is equal to 10. It's not valid. It says it's a invalid syntax because for is a reserved word in Python. So now we have learned some rule about declaring the variables. So let's declare some variables in Python. So first of all, I'm going to declare an integer variable which takes an integer, and then I'm going to declare a float variable which takes a decimal value. And then I can also declare in Python a complex value. For example, my complex is equal to 1j, and then press enter, and it's also totally valid, where j in this value is the imaginary part of this complex number. Now you can also use e to indicate the power of something. So for example, I declare a variable my num, and you can write this notation like this. So 10 to the power 10, it's totally valid. Okay, and when you try to access this value of my num, it's going to give you the value of 10 to the power 10. You can also write the capital E here. So when I write my num is equal to 10 capital E 10, and then press enter, and I try to access the value which is stored in this variable, you can see it gives me the same result. Now in order to declare a string variable, for example my string, I can use double quotations. For example, I want to write some name here. It's totally valid, so I'm going to just get the value which I stored inside this my string variable, and it gives me this name Max. I can also use single quotation in order to assign string to the variable. So I will use now single quotation, and this time I just change the name to Tom. It's also totally valid. So when I write my string once again, it gives me the value Tom. Now you may have noticed one more thing here is reassignment of the variable is possible. So first I have assigned the value Max to this variable my string, and then I have reassigned some other value Tom to the same variable my string. So reassignment is possible. So for example, let's say what I'm going to do is I'm going to take my float variable, and then what I'm going to do is I want to assign in this variable the value which is stored in my int variable. So I'm going to just write my int here and then press enter, and let's see what is the value inside my float now. And you can see it gives us the value 10. But you may ask that we have declared this variable name as my float, so we are expecting the float value inside this my float variable name, but it's giving me the value 10. So in order to convert an integer value into a float value, you can use typecasting. So I can just write my float here is equal to, then you write a keyword float here, and then inside the parentheses you can write the name of the variable which is my int. And then when I access the value of my float here, it's going to give me 10.0, which is a float value. So in order to convert integers into float, you can use this keyword float here. Now if you want to convert a float value into an integer, you can just write, for example, my int is equal to int, and then inside the parentheses you can write the variable name, for example my float here, and then press enter, and then I can see the value which is stored inside this my int variable, and it's an integer. Now let me show you one last thing, which is to find out the type of any variable. So you use a keyword called type, and in the parentheses you use the variable name, for example my int, and then press enter, and it will give me the type of the value which is stored inside this variable. So you can see integer is stored inside this variable my int. Once again, type and then parentheses, and now I want to know the type which is stored in the my float variable, and you can see it will give me float as an answer. So we know that in my float variable, float value is stored. Once again, we will see what value is stored in this my num, which is an exponent value, right? So I'm going to just write type, and then I'm going to just write my num now, and then press enter, and it gives me a float value. And at last I want to see what type is stored in this my string variable. So I can just write my string here and then press enter, and you can see the value which we get here is str, which stands for string. That means in my string value is stored. Now it's totally possible to use the operators with variables. So I want to add the value stored in my int plus my float here, and this will give me 20 because my int have the value 10 and my float have the value 10.10, so the result is 20.0 here. So this is how you can use variables and types in Python. In this video, we will see how to use print function in order to print output on the console in various different ways. And I'm also going to show you how to take user input using Python. So we have already seen that in Python, we can use this print function in order to print something. And we have already printed hello world at the time of installation, right? And when I press enter, it's going to print hello world on the console. Now, some of you might wonder, what is this print? So print is our inbuilt function in Python. So Python has a number of inbuilt functions and print is one of them. So here print is a function, and then inside the parenthesis, what you give here is called a parameter or an argument. Okay, so hello world is an argument, which is a string argument, right? So let's try to give in this print an integer argument. Let's say I just provide 25 here, and it will print this number once again. Let's say I'm going to write print, and then I want to execute some expression 50 multiplied by 60, and then press enter. Print function is also able to do this. Now let's say I want to output some more complex formatted string. So let's say I want to print on the console 50 multiplied by 10 is equal to 60. How can I do this? So let's see how we can do it. So I can write print here, and then inside these double quotes, you can write your string, for example, 50 multiplied by 10, and then in print function you can give multiple arguments using this comma separator. So here I can just write 50 multiplied by 10, and let me put equals symbol here inside this string, and then press enter, and now it prints 50 multiplied by 10 equals 500. And you can also provide more than one argument to this print function. So for example, I can just write hello here, and then in the second argument I will just provide the space between hello and world, and in the third argument I will just say world here. And this print function will concatenate all these string values and give you the output in this format. Now let's say you want to also provide this value here, which is 50 and 10. Instead of string, you want to provide some value which you take from a variable. So for example, you declare a variable x is equal to 50 here, and then y is equal to 10, and you want to use these two variables instead of this static string. So how you can achieve this? You can achieve this in various different ways. So let me show you the first way. So I can write print, and then in the double quotes, this is your string. So whenever you use this double quotes, and whenever you write something in between this double quotes, it becomes a string. So after this string, I will provide a dot here and wait for some seconds. And as soon as you do this, you will be able to see various different hints here which are provided. So these are all the inbuilt methods which you can use with the string. So you can use find method, you can use format method. So for now, we are going to use this format method with strings. So you can just click on this format method. So let's say I will provide x as the first argument, y as the second argument, and I want to see the output of x multiplied by y in the third argument. Now how you can print the value of x, y, and the multiplication of x, y using this blank string? So it turns out that you can use these curly brackets inside this string, and you can give some index here. So index starts from 0. So this index is index 0, and then I'm going to provide space and then this asterisk symbol to provide this kind of format. So we want to achieve this format here, right? So just write 0 in the curly bracket, space, asterisk, and once again curly bracket, and this time we are going to provide the index 1, and the result will be transferred to index 2. Why? Because here the index starts from 0, so x will be transferred to the index 0, y will be transferred to the index 1, and the multiplication of x and y will be transferred to index 2 here. So let me press enter here, and you can see it prints the string which we desire. Now once again I'm going to write this print function, and once again I'm going to give this parenthesis, and you can see the hint here. So I want to use this SEP keyword now inside the string. So how can I use this? So I will just close this parenthesis, and once again I want to print hello world. So I will just write hello, and then I'm going to provide the comma, and inside the double quotes I'm going to just write world here, and then in the last argument you can provide this keyword SEP is equal to, and inside the double quotes you can provide some separator to separate the hello from world. So I want to just give this string to separate hello from world, and now I'm going to press enter, and you can see this string is separating the keyword hello from the world. Now in Python you can also use C style string formatting to create a new formatted string. So let me show you how we can do it. So I'm going to declare a variable called name, and I'm going to assign some value to it, for example max here, and then press enter. And now I'm going to just write print function, and in the parentheses I want to just greet this name, so I can just write double quotes hello here. And then if you are familiar with C style string formatting, then you may know this modulo S symbol, which is used to print strings, right? And then after this double quote you just need to provide once again this modulo symbol, and then you need to provide the variable name which you want to replace instead of this modulo S. So in our case we want to replace this modulo S by name variable, and I'm going to press enter, and you can see it prints hello max. Now let's say I also have the age of this person. So the age is, let's say, 22, and once again I'm going to use this print function, and inside the parentheses I want to say hello to the name including the age. So I can just write hello and then modulo S here, and then I'm going to print the age of this person. I can just write RU modulo D, which is used to print the integer values, and then I'm going to just write years old, and after the double quotes I can just write modulo. And this time I cannot simply provide this name argument like this. I must provide the name in the form of a tuple. And what is a tuple? A tuple is a fixed sized list. And we are going to see in the future videos how to use tuples. But for now, just remember that a tuple is a fixed size list. Okay. So inside these parentheses, once again, I can provide first of all the name, and then as a second value in the tuple I can provide the age variable. And now I'm going to press enter, and now you can see it prints hello max, are you 22 years old. So this is how also you can use these C styled string formatting in Python. I want to give you one more example of float here. So I can just write for example this person's marks. So I'm going to just write marks is equal to, and let's say I want to provide these marks in the floating point. So I can give this modulo F here, and then after this modulo I can just give the marks, so 92.5, and then press enter, and you can see it prints the marks. Now one more little thing which we can do here is we can limit the number of decimal values which we want to see after this point. So we can write the same printf function and same argument, and in order to limit the number of digits after the decimal, you just need to write after f dot and some number, for example 2. Oops, I don't want to see this output. I wanted to see the output after the decimal value. So once again, I think this point should be before f. So I just need to write dot and 2 before f, I think, and then press enter, and now it limits the number of digits after this decimal point. Now the last thing I want to show here is how you can allow the user to provide some input. So for example, I will declare a variable called value, and then I can use equals, and then I'm going to use an inbuilt function which is called input. So input is also an inbuilt function which allows you to take user input. So here I can just write as the first argument, and then I will provide this colon here, and that's it. You just need to press enter here, and now you can see this terminal is asking us the same question which we have written here. So let's say I just provide 50 here and then press enter. Then what's going to happen is this 50 is going to be assigned to this variable which is value. So now when you just use this value variable, you can see this 50 is assigned to this value variable. You will also see that this 50 is a string and not a number, right? Because it's enclosed in single quotes. So how you can assign 50 to this value using the user input? So what we can do here is, once again, I'm going to use this value variable, and what we can do here is we can typecast the output of input. So you can just write int, and then here inside the parenthesis you can just write, and now when I press enter and provide 50 and then press enter and see the value, now it's an integer, right? So you can typecast the output of this input function which provides us the string, and this int method is going to convert this string into an integer and then give us the result. Instead of this int, you can also use a float keyword here. So let me show you this example also. So I'm going to just copy this and paste it here, and instead of using the int, I'm going to just write float here, okay, and then press enter, and I'm going to provide this time 100 here and then press enter, and then I'm going to just print the value of the value variable, and now it prints the answer in floating points. So this is how you can use print function to print the output on the console, and input function to take the input from the user. In this video, we will discuss about built-in functions and modules in Python. So the Python interpreter has a number of built-in functions, modules and type that are always available. That means you can use them at any time. And we have already used some of the built-in functions in Python. So first of all, we have used the print built-in function. We have already used the input built-in function. We have already used the int, which is used to typecast a float or a string into an integer, right? We have already used a built-in function called float, which is used to convert an integer to a float value or a string to a float value. Now Python has a list of these inbuilt functions, and you can find this list by going to the python.org website and then clicking on the docs section, and you can choose the version you have installed. So we have installed the latest version, which is 3.7.0, and you can even choose your language, which are available here. Now when you click on this link which says library references, you will be able to see this page which says Python standard library, and then when you scroll down here, you will be able to see the introduction about Python, and the second section here is about built-in functions. So I'm going to click on this built-in function link, and here you will be able to see all the built-in functions in Python. So this is the list of all the built-in functions which you can use in Python. And if you want to know more about these functions, for example, I want to know what this max function does, I can click on this function, and then you can get the help about this function. So what this function does and how it can be used in Python. All the information is given here. Now let's go to the terminal and let's see how we can use some of these built-in functions. So first of all, how you can list out all these built-in functions and types in Python. There is a built-in function to list out all the built-in functions and types, which is dir and then double underscore, and then you write built ins and then once again double underscore and then close the parenthesis and then press enter, and it's going to give you the list of all the built-ins available in Python. So for example, from this list we have already used this function called float, print, and then we have already used this function int and input also. So let's use some more functions. So in the previous videos I have shown you how to calculate the power of a number. So you use these double asterisks in order to calculate the power of any number, and you can see you get the power of 2 to the power 10. Now Python also have a built-in function called POW. Here you can give as a first argument the number, and as the second argument you can provide the number which you want to use as a power, and when I press enter it gives me the same result. Let's use some other built-in function, for example len. Len you can use to find out the length of any string. So I can write len and inside the parenthesis I can just write any string here, for example hello, and it will give me the length of the string. So this string hello have 5 letters inside it. That's why it's giving me length 5. Now there is a built-in function called help, using which you can get some help about any function. So I can write help here, and inside the parenthesis I can just write the function name. So for example, I want to know what this max function does. So I can just write max here and then press enter. So it gives me the signature of max, so how it's used, and then it will provide me some description about the function, so what it does. So you can see here it returns the biggest item, right? So I can just write max here, and inside the parenthesis I can give the list of items here, for example 1, 2, 8, 9, 4 and 5. And when I press enter, it's going to give me the maximum value out of this list. So you can use this help built-in function in order to know more about all the other built-in functions. Now till now we have talked about the built-in functions which are available in Python. Now let's talk about some of the built-in modules which are available in Python. Now what is a module I'm going to describe in the later videos. But for now, let's see how to import a built-in module in Python and how to use them. So there is a built-in module called math, and to import it, you just use a keyword called import and then the module name, for example math, and press enter, and it's going to import this module into our interpreter. Now you can use this math keyword and then you can write dot and wait for some seconds, and you can see it gives me all the list which are available inside this math module. So let's say I want to find out the square root of any number. I can use a function called sqrt here, and then this gives me the square root of a number. So for example, I want to find out the square root of 100 and then press enter. It gives me the answer 10. Now once again, as I said, you can use a built-in function called help in order to know the signature of this function. So I can just write math.sqrt and then press enter, and it's going to give me some help about this function. So you can see it returns the square root of x, and the signature looks like this. Now if you want to print all the methods and types available inside this built-in module, you can once again use this built-in function dir, and then in the parenthesis write the name of the module. So this time we will write math here and then press enter, and it gives me the list of all the available functions available inside this math module. and you can see all these functions which are available inside this module. So you can just use a cos function from here, pi function from here, radians or tan function from here. So this is how you can use built-in functions and modules in Python. In this video, I'm going to show you how you can write your first Python script in the form of .py file and execute it. But not just by idle, but I'm going to show you various different ways you can execute this Python file which you will create. So let's get started. So first of all, I'm going to show you how you can create your Python file using idle. So first of all, open your idle IDE and just go to file here, and you will be able to see this option here which says new file, and then you will be able to see this kind of window opens, which is a Python file editor. Now first of all, we are going to save this file. So let's save this file. You can save this file at any directory or any path wherever you want. So for this first file, I'm going to name it as hello.py. So .py is the Python extension and hello is the name of our file. So I'm going to save this file first of all, and you can see it's saved at my desired location. So in this file, let's write some Python code. So let's say I want to create a program in which I will ask the user to input 3 numbers, and as the output I want the maximum out of these 3 numbers which is inputted by the user. So how can I do this? So as we have already seen, you can define a variable in Python like this. So I'm going to define a variable x is equal to, and we also know that there is an inbuilt function in Python called input to take the user input, and then in the double quotes, so we are going to ask the user that he needs to enter the first number. So enter first number, and in a similar way I am going to ask the user to enter the second number and the third number. Let me change the variable name here. So instead of x, this variable will be y, and the last variable will be z, and this is the third number and this is the second number. But when I write the input like this may give us some problem. The problem is input function gives us a string, and we need to convert this string into a integer or a float. So let's convert this number into a float value. So you can use another inbuilt function which is float, and then this string will be converted to float. So I'm going to do the same for other 2 numbers. Now in order to get the maximum numbers out of these 3 numbers, we have seen there is an inbuilt function in Python which is called max, and we are going to use this max function. But first of all, we need to print something. So we will just write the max value is, and then we can calculate the maximum value and print it from here. So we can use this comma, and then we can use this inbuilt function which is max, and then we will just pass these 3 values which is x, y and z. So will this program work? Let's see. So first of all, before doing anything, you need to once again save this file. Okay, so right now you can see there is a little asterisk symbol here in front of my file, which means my file is not saved. So you need to first of all save your file, and then you will see this asterisk is gone. That means our file is saved. So let's run our code. So if you want to run this Python file using your idle IDE, you just need to click on the run button here, and then choose the third option which says run module. So I'm going to click on run module, and after some time you will be able to see this output printed on the idle IDE. So it says enter the first number, which we have written in our code. You can see this line is executed first of all. So we will enter some number. I'm going to just write 50 here and then press enter, and then it asks us to provide the second number. So let's say this number is 90, and Now we need to give the third number. So I'm going to just give 101 here and then press enter. And it says the max value is 101, which is correct. But in real world, you will not have this idle IDE installed everywhere. So how can I run my hello.py file? So I'm going to minimize this idle IDE for now. And I'm going to go to the location where I have saved this hello.py file. Okay. So just go to the location where you have saved your hello.py file. And now you just need to double click on this hello.py file. So I'm going to just double click on this hello.py file. And you can see as soon as I double click on hello.py, it opens this program in our terminal. Okay. So once again, I'm going to close this terminal. And I'm going to double click on my hello.py file and it opens our program in our terminal. So once again, I'm going to give three inputs here. Let's say 110, enter, 55, enter, 200 and enter. As soon as you press enter, this window disappears. So why this window disappears? Because after the execution of your program, this terminal immediately closes. So we need to provide something in our program in order to avoid the closing of this terminal. And how we can do this? We can do this using our input method, which is our inbuilt method, right? And here we can just type press any key to exit. So what will happen here is after printing the result, your terminal will wait for the user input, and once the input is given by the user, then only the terminal will exit. So let's test our program once again, but before this, don't forget to save this program. So I'm going to just save my program and then I'm going to open the folder where I have saved this hello.py file. And once again, I'm going to double click on this hello.py and I'm going to give three numbers here. And then I'm going to press enter and it prints 99, which is the maximum out of three numbers. And at last, it asks us to press any key. So I'm going to press any key, for example, Z, and then press enter. And this terminal disappears. So now the question is, how does this Python file is executed without compiling this file? So the answer of this question I have already given in the introduction video. And the answer is Python is an interpreted language and not the compiled language. So what happens in normal languages like Java, C++, C, you have a source code, and this source code you need to compile in order to convert this source code into an executable file. For example, you have a hello.java file. You need to compile this Java file in order to convert it into a hello.class file, which is an executable file. And when you run this hello.class file, hello world or whatever program you have written will be executed. Now in the case of Python, because it's an interpreted file, you just need to create this hello.py file and you just need to run it. You don't need to compile this file. And that is the difference between interpreted languages like Python and the compiled language like Java, C++ or C. Now there is one more way using which you can run your Python file, and that is by using your command prompt. So I'm going to open my command prompt. I'm going to right click on this Windows icon and then I'm going to open this command prompt from here. So make sure that this command prompt is able to understand this Python command. So first of all, type Python on your command prompt and then press enter. And if it shows you this output like Python and the version of Python, then Python is working on your command prompt. So this command prompt is Windows command prompt and not the Python shell which we have installed. So this is our Windows command prompt, right? Now let me make this terminal little bit bigger so we will be able to see what I'm typing. So I'm going to change the font size to, let's say, 24 here. So now we will be able to see what's happening. You can just write quit and then these two parentheses and then press enter, and you will come out of this command prompt. So you need to come out of your command prompt in order to execute your Python file. Now in here, what you need to do is you need to copy the path of your Python file. So I'm going to right click here and then go to the properties, and then in the securities, I'm going to just copy full path of this Python file up to .python. Okay, so I have copied full path of this Python file, and now what I need to do is I need to just write Python here. Okay, so just write Python and then paste the path which you have copied. So I'm going to just paste the path which I have copied and then press enter, and you can see our program is executed. So I'm going to just give quickly 3 numbers, and it gives us the maximum of these 3 numbers. Now I will just type any letter here and then press enter, and I will come out of this terminal. There is one more way of executing your file, and this is you need to just give this command, which is cd and then your directory path. So up to your directory, you just need to copy this path from here. Okay, so you just need to copy this path, and then after cd you just need to give space and then paste this path without your hello.py file. Okay, so I haven't given the hello.py file name here, and now press enter, which will change your directory to your Python directory. So now we are inside our Python directory. From here you can directly give Python and the name of your file, which is hello.py, and then press enter, and once again the program opens. So we can just give 3 inputs here and the result is shown. Once again I'm going to just type any key or any letter here, with for example R, and then press enter, and now I'm out of this program. So this is how you can run your Python script on any terminal. You don't need any IDE or any other special software in order to run your Python script. You can run it on your terminal or directly click on the Python file. Till now we have been using idle IDE in order to develop our Python code. Now the reason behind why I was showing to code in Python using idle in the first few videos, because I wanted that you get familiar first with Python interpreter. So now whenever you want to test some functionality in Python, you don't need to open any IDE or any editor. You can just open your terminal and then test that functionality. Until you wanted to test something, terminal or Python interpreter was okay. But when you want to develop a big project using Python, we need to use some kind of IDE. IDE stands for Integrated Development Environment, in order to develop such kind of projects. So in this video, I'm going to show you how to install PyCharm on your Windows 10 operating system, which is the most popular IDE today used by developers to develop Python code. So let's get started and let's see how we can install PyCharm on our Windows 10 operating system. So open your favorite browser and search for PyCharm, and the first link which will appear here will be from jetbrains.com/PyCharm. So JetBrains is the company behind this IDE, and this company, which is JetBrains, is famous for making very good IDEs. So JetBrains has also created some other IDEs like Android Studio, IntelliJ IDEA, WebStorm, and many other IDEs which are popular between developers nowadays. So we are going to just click on this link. So now we are inside this jetbrains.com website, and here you will be able to see this logo PyCharm, and you will be able to see this download button here. So I'm going to click on this button which says download now, and then you will be redirected to this page, which is for downloading PyCharm. So here you can select your platform, whether you are working on Windows or Mac or Linux. And what we want to download is we want to download the community version of PyCharm. This community version you can see is free and open source, so you can download and install it with no cost. If you want to download the professional version, then you need to pay some money to JetBrains in order to use it. And as soon as you click on download button, this download of PyCharm community version.exe file will start. So I will wait for this file to be downloaded. So now this exe file is downloaded on my Windows operating system. So I'm going to double click on this exe file and I'm going to minimize the browser. And now you can see PyCharm setup wizard has been started. So here you just need to click next. And this is the location where PyCharm will be installed on your system. So it will be installed inside your C directory, then program files, JetBrains, and then there will be a directory created which will be called PyCharm Community Edition, whatever version you have downloaded. So I'm going to click next. Now on this next window, you will see two options. One is to create a shortcut. So we are going to choose this option which says 64-bit launcher. Now the second option here is create associations. And I'm not going to check this checkbox because I don't want that on my computer every .py file to be associated with the PyCharm. So I will leave this unchecked. And the next option here is download and install the JRE x86 by JetBrains. There is no harm in this. So I'm going to check this checkbox and I'm going to click next. And now I'm going to click on the install button. So this is going to start installing PyCharm on my Windows 10 operating system. So I need to wait for some time until this installation is finished. So now the installation of PyCharm Community Edition is finished on my Windows 10 operating system. And you can also see there is a PyCharm shortcut which is created on my desktop. Now I will check this checkbox which will start the PyCharm IDE, and I'm going to click finish, which is going to launch the PyCharm IDE. Now for the first time when PyCharm starts, it will ask you this question, whether you want to import any settings from the previous installation of PyCharm. We don't have any previously installed PyCharm, so we are going to just leave this as default, which says do not import setting, and then click OK. And then you will see this license terms and conditions window. If you agree with all these license terms and conditions, then just click accept. And one more window appears here, which is for data sharing. So I'm going to just say don't send. And now you can see PyCharm IDE has been launched. So for the first time, it will ask you which UI theme you want to use. You want to use the Darkula, which is the dark theme, or the IntelliJ theme, which is the light theme. So I'm going to choose this light theme, which is IntelliJ theme, and then I'm going to just click on next. And on this next window, you will see some featured plugin. So for now, I'm not going to install any of the plugin. I'm going to just say start using PyCharm, which is going to start the PyCharm. So now PyCharm IDE has been started. So let's create a new project here. So I'm going to click on new project, and now we need to give the title of this project, and PyCharm will ask you where you want to save this project. So I'm going to just give the name to my project. So let's name our project as Hello World, and then I'm going to just click on create button, which is going to create our Python project. So now you can see PyCharm IDE has been started. So you can see the first thing you will see here is tip of the day. I'm going to just close this tip of the day, and I'm going to maximize my IDE window. And you can see our project is shown on the left hand side. So let's create a Python file, and we are going to just run some code using this Python file. So we need to just right click on our project and then click on new, and then choose a Python file from here. And now we just need to give the name to our Python file, for example, hello, without any extension. So you don't need to provide any extension, when you choose this option which says Python file, and now click OK. And now you can see on the left hand side that this file is created, which is hello.py. This .py extension is added by PyCharm for us. And now on this editor, for example, let's print hello world once again. So I'm going to just print the hello world. You already know how to print hello world, right? And once you have written your code, you just need to save your code by pressing Ctrl S. And now you can just right click on your file and choose this option which says run hello. So I'm going to just click on this option which says run hello, and you can see this output is printed on this run window. So this is how you can install PyCharm on your Windows 10 operating system. In this video, we will talk about using strings in Python. But before that, I want to show you something, and that is how to comment your code in Python, or how to write a comment in Python. So for example, I have this line of code which is used to print hello world on terminal. Now for some reason I don't want to execute this line of code, then I can convert this statement into a comment. And how do I do this? You can just add an asterisk in front of your code, and this makes your statement a comment. A comment means that now this line of code will not be executed by Python. So let's run our code and let's see what happens. So you can see now it doesn't print hello world because now this is a comment. Now generally we use comments in order to provide some information about some functionality or what we'd want to do with our code. So let me remove this line, and because it's a Python strings video, we can just write after this hash symbol Python strings, right? And this means that this is a comment and this line will not be executed by the Python interpreter. Now there is one more way of giving a comment in Python, which is by writing the double quotes 3 times. And this is also a comment. So when you write, for example, Python strings, this is also a comment. So this will also not be executed by Python interpreter. So what is the difference between this hash comment and the comment with these 3 double quotes? So it turns out that using these double quotes, you can write multiple line comments. So for example, I want to write a multiple line comment. Let's say I want to write Python string tutorial. I can write this multiple line comment using these triple double quotes. So let's get started and let's see how we can use strings in Python. So I'm going to declare a variable, and in this variable I'm going to assign hello world here, right? And to print this hello world, we can just write print, and inside the parentheses we can use this x variable, and when we run the code, it runs. So we already know how to use this kind of string in Python. The second way of creating a string is you can use the single quotes instead of double quotes, and this is also a valid string. So this will also work. So let me just print this also, which is hello world using single quotes, and when I am going to run this, it's going to give me the result. Let me remove this spaces between the print and these parentheses. So let's say you want to add a single quote into this hello world string. So let's say I want to just write hello single quote s hello's world. So this is totally possible in Python. So whenever you surround your string using double quotes, you can just add this single quote without any problem. But when you do the same with this string, this will give you a problem, because now Python thinks that your string starts from here and ends at this place just after hello. And this will be seen as some kind of garbage by Python. So in order to use these single quotes inside the string which uses single quote, you use a escape character. And the escape character in Python is backslash. Okay, so when you add a backslash in front of a character, Python interpreter knows that it's a escape character, so this will be treated as a valid string. So let me just print the result, and you can see it prints the same result now. Now let's say I want to use a double quote in this string which uses double quote already. So I'm going to just give a double quote here, and the same problem arises which we have seen in the string with single quote. So to escape this, you can also use backslash and the problem will be gone. And let's run the program, and it gives us this hello world with double quote. So you can print this double quote using this escape character which is backslash. Now let's say you want to print a string with a backslash itself. So I can add a backslash here, and I want to add a backslash here, and let's save the code and let's run it, and let's see if it runs or not. So it turns out that you can use this kind of notation in Python. Also, when you use double backslashes here and here, let's see what happens. So when we run the code, it will give us the same result, because one backslash is a escape character and other backslash is the part of the string. So it will print the same result. So you can use this for escaping this character, or you can remove this. The result will be same. So now let me edit these two strings, and I'm going to use hello here with the capital H, and I'm also going to assign hello to the y variable with a small h here. Now Python provides us some inbuilt functions which you can use with strings. So this is a string, right? So you can use some methods related to strings on the x and y variable. So let's see what are these methods. So after the x, I can just press dot, and you can see so many suggestions is given to us by PyCharm, and this is called IntelliSense, which is provided by PyCharm to us. And IntelliSense means that whenever you type something, PyCharm will try to suggest you some supporting code for whatever you are typing. So let's use some method which are suggested to us. So I'm going to use this capitalize method. So let's use this capitalize method with the x and y variable, and let's see what happens. So I'm going to run the code, and you can see now the upper string is printed same, but the lower string is printed with a capital H in front of it. So this capitalize method capitalizes the first letter of the string. Now let's see what are some of the other method which we can use. So there is a method called upper, and also there is a method called dot lower. So let me just rewrite this hello in all capitals, and let's run the code now. And you can see in the result, the upper method has converted our string into all upper letters, and the lower method has converted our string into all lower letters. Now in Python, everything is an object. So using these square bracket, you can extract each and every letter based upon their index. So for example, I write index 0 here, and in the y, I'm going to use the same square bracket, and I'm going to write 1 here, which is the index 1, and let me run the code, and it prints the first character of the string because it's at index 0, and here you can see the second character of the string which is at index 1. So always remember, indexes starts from 0, not from 1. Now in Python, you can also get the substring out of a string. So here inside these square brackets, I can just write that I want a substring out of this complete string, first 3 letters of this string. So I can just start from 0, and I can just say I just want to stop at 3. That means we will get, I think, the first 3 characters of the string. Also, let me add some spaces into the second string here. And in Python, there is a method called strip. So I'm going to just use this strip method, and let's run the code first of all, and let's see what happens. So you can see, first of all, this print has printed first three letter of this string. So you can see this notation means that we are telling Python to give a substring starting from 0 until 2, until the index 2. Okay, and we are saying that we want to stop at index 2, that's why we write 3 here. Now if you want to just print HELL, we can write here 0 to 4, and then we can run the code and then we get HELL. If you want to get only ELL, you can write 1 to 4 here, and then it will give you ELL out of this string. And this is how you can strip your string. So strip means the spaces from the start and end will be stripped of this string. Now let me show some other method related to the strings. So first method I want to show here is there is a method called isLower, and then there is a method called isUpper, and then there is a method called dot replace, which is used to replace some character inside the string. So let's say I want to replace capital H by, let's say, J. And the last method I want to show is how to split the string, but that we will see in a moment. So let's run this code, and the first result says false because this string is not lower. When we write all letters in lowercase, then only it will give us true, otherwise this method isLower will give us false. Now let's rerun the code, and now it gives us true because now every letter in this string is lower. Second method gave us true because we were checking whether every letter in this string is capital or not. The next method replace is used to replace the character if it's there in your string, and replace it with this character if this character is found in your string. So this capital H is not present in our string, right? So let's just add this capital H into our string and let's see what's the result. So now the capital H is replaced by capital J here in the result. The next method which you can use with the string is a split method. So you can write y dot split, and this is used to split your string using any character. So I'm going to once again write hello comma world here, and I want to split this string using this character which is comma. So I can just write using single quote these comma, and once I run the code, you can see it gives us an array of two members. One is hello and other is world with a space, right? Because we have splitted our string using this character, that's why the space is here, right? So that's why you can see this space here also in the second element of this array. So there are number of methods which are associated with string which you can use, and for knowing all these methods you just need to write your variable which contains a string and then just write dot, and you will be able to see the suggestions which you can use with the strings. So you can use the title method, for example, or you can use the translate method, or you can use all these methods which are available here. Okay, so just see all these suggestions and see what you can use from these methods. Also, if you don't have any variable in which you have assigned your string, you can directly take your string, for example hello, and then you can just write dot after this hello, and once again you will see all these suggestions because this hello is also a string. Let me show you one last thing which you can use with string very quickly. So you can write print here, and then if you want to print this hello, for example 10 times, how will you do this? So you can just write, for example, x comma x comma x. This is how you can do this. Let's say you want to print this hello 100 times. How you can do this? So there is a trick in Python which you can use, and this is using these asterisks. You can print the string multiple times. So for example, I want to print this hello 10 times. I can just write my string variable name asterisk the number of time I want to iterate this string. So let me run the code, and you can see now this hello is printed 10 times. Let me provide the space here, so there will be a space between the two hellos, right? Let's say I want to print hello 100 times, then I can just write 100 here and then run the code, and it will print this hello 100 times on the terminal. So this is how you can use strings in Python. In this video, we will talk about the Boolean values, comparison operators, and the logical operators in Python. So first of all, what is a Boolean value? So in Python, Boolean values are two constant objects which are true and false. Now for this demonstration, I will be using a Python interpreter, and in PyCharm, you can open the Python interpreter by going down at the bottom, and you will be able to see this option which says Python console. So just click on this Python console option, which is going to open the Python console, and you can move this bar up and down in order to expand your console, right? So let me just clear this console. So we will start from the top. So in order to clear this console, you can right click and then just say clear all, and it's going to clear the console. And let me resize this console up to the top, and let me just minimize this section also. So as I said, Boolean in Python are two constant objects which are true and false. So how you write true and false in Python? You write true with a capital T and press enter. This is a true value. And false you write with a capital false. This is a false value. Now if you write true with small t, this is not recognized by Python. Also, when you write false with small f, this is also not recognized by Python. Now generally we use Boolean values in order to find out the result of some condition. Now let's say you have two numbers and you want to find out which number is greater out of these two numbers. You can use a comparison operator to compare these two numbers, and the result will be shown as a Boolean value. Now the next question arises, what is a comparison operator? So in Python, these are some of the comparison operators you can use. So you can use this double equals to check the equality between two values. You have this not equal operator with this exclamation mark and equals, which you can use to check the non-equality between two values. There is a greater than operator and there is a less than operator, and also there is a greater than equals operator and the less than equals operator. Now examples of each of these operators I have given here. So how to use these operators? As I said, if you have two values, let's say two integers x and y, to compare these two integers whether they are equal or not, you write on the left hand side first variable and on the left hand side second variable, and in between you use the comparison operator. It can be a equal to operator or non-equality operator, or greater than or less than, or greater than equals or less than equals operator. So let's see how we can use these operators in real Python environment. So let's say I want to check whether 10 is greater than 9 or not, and when I press enter, it's going to give me true because 10 is greater than 9. Now once again, let's check if 10 is less than 9 or not, and it will give me a false value, which is also a Boolean result. Also we can check equality between two values. So we can just write 100 is equal to 100 or not, and it will give us true. Once again we can check if 100 is equal to 99, it will give us false. In the same way you can also check for the non-equality. So for non-equality you use this exclamation mark equals and then press enter, it will say true because 100 is not equal to 99. The same operation you can also perform with some variable. So let's say I have a variable called x whose value is 20, and I have a variable called y and I assign 30 to it. And let's say I want to check whether the value in the x is greater than or equal to the value which is there in y, then I can write this kind of a statement, and when I press enter, it's going to give me false because 30 is not greater than or equal to x. So let's assign a value which is 30 into our variable x. And now let's check whether x is less than or equal to y or not. And when I press enter, it's going to give me true because we know that x, which is 30, is not less than y, but it's equal to y, and this condition is true. Now you can also compare two strings using these operators. So let's say I have a string called hello, and I want to check whether the hello value is equal to some other value, for example hello in double quotes or not, and it will return me true. That means whether you write hello in single quote or hello in double quote, both these values are same in Python. Now also we have seen in the last video where we have seen how to use strings, that whenever, for example, I write a string, I can use this dot operator in order to call some functions related to strings. So some of these functions returns a Boolean value. So for example, we can check whether this hello, all letters are in uppercase or not, and once I press enter, it says false. Or I can check whether in this hello all letters are in lowercase or not. This will give me true. Or I can test whether in this hello string all letters are alphabets or not. This is going to give me true because all letters are alphabets. Now if I check whether in this string whether there is a alphanumeric value or not, I can use this method which says is alnum, and this will check whether in my string there is a alphanumeric value or not. Now the next question you may ask is, for example, I want to evaluate two conditions at the same time. Let's say I want to evaluate whether 10 is greater than 9, and I want to evaluate whether 20 is less than 15 or not. So how can I evaluate these two conditions at the same time? So for those type of comparison, we use the logical operators, and there are three logical operators which we can use in Python: an AND operator, an OR operator, and a NOT operator. So this AND operator you can use to evaluate two conditions, and it will return true only if both conditions are true. Okay, so let's say you have two conditions, x condition and y condition. Then if you use this AND operator, then in order to get true out of these two conditions, both conditions have to be true. In the case of OR, it will return true if one of these conditions is true. So whether x is true or y is true, it doesn't matter, but if only one condition is true, this will give us true value. And the NOT operator will return the opposite of what we have. So if some condition returns us true, then when we use NOT operator, then NOT operator will make this false. So let's try all these three operators in Python. So I said I can use an AND operator to check whether this value is true as well as this value is true or not. So when I press enter, it returns us false, because even though the first condition is true, which is 10 is greater than 9, but the second condition is not true. right? So in case of AND, both conditions should be true in order to get the true result. Once again, when I use the same conditions and instead of AND, I use the OR operator, it will return me true because one of these conditions is true, which is 10 is greater than 9, even though the other condition is false. Now let's say we make both conditions true and we use OR, and when we press enter, it's going to still returns us true. So the minimum requirement of OR is there should be at least one condition which evaluates to true. Now let's see how we can use the NOT operator. So I can write NOT and then I can check whether 10 is greater than 9 or not, and when I press enter, it returns us false because we know that 10 is greater than 9 and not makes it false, so it returns us false. Once again, if we check whether 10 is less than 9 or not, it's going to return us true because 10 is not less than 9, and this condition will return false, and not will make it opposite, which is true. So in this way you can use Boolean values, comparison operators and logical operators in Python. In this video we will learn how to use if-else statements in Python. So first of all, what is a if statement? So a if statement is used to execute a statement or a block of code if and only if a condition is fulfilled. So first of all, let's see the syntax of if statement. So let's say I declare a variable called x whose value is 100, and then I'm going to check whether the value in x is equal to 100 or not. So I can use this keyword if, and then if you have seen the last video in which I have shown you how to use comparison operators and logical operators, then you will know that for equality we use a double equal symbol, and then I'm going to just check it against 100. Now after the condition you need to give this colon in order to tell Python that this condition is finished, and you need to press enter, and you will see that there is an indent given to our code, and you can see this cursor is here, which is 4 spaces away from the start or 1 tab away from the start. And here I can just, for example, print the value of x. So I can just say x is equal to, and then after the comma, x. And let me save this code and run this code, and you can see on the run window here x is equal to 100 is printed, because this condition which we are checking using the if statement is true, which means whatever code or statement or block of code you will write under if, it will be printed. Let's say this condition is not fulfilled, so I'm going to just say that x is not equal to 100, which is a false condition, and when I run the code, now it doesn't print anything because this condition is not fulfilled, and that's why this statement is not executed. Now let's talk about the indentation a little bit. So indentation in Python is the way of marking a block of code. So you can see I have given 4 spaces indentation here, so 1 2 3 4, or if you are using PyCharm, when you press enter after an if condition, you will see that automatically this cursor is pointing here, which is 4 spaces away from the starting point. So this means that whatever you write after these 4 spaces or a tab is the part of this if statement. Now if you are familiar with C or C++, this indent acts like a curly bracket in C or C++. So in Python you don't use the curly bracket to define a block of code, you use indentation to define a block of code. So I can write this statement like this also. So I'm going to just say x is equal to, and in the next line I can just give one more print function, and I will print x from the next line. And you can see here also I have given indentation after this starting point, and this means that these two lines are the part of this if statement. So let me change the value of x is equal to 99, and when I run the code, it will print x is equal to, and in the next line it prints 99 using this line of code. So you may ask, what happens when I will write this print function here, and let's say we want to print finish here. Okay, and let me run the code and let's see what happens. So it prints finish. Now let me just change this condition, and I'm going to just say 100 here, and let's see what happens now. So now only finish is printed because this line of code is not the part of if condition. Only statement which you write after 4 spaces will be the part of the if condition, like this line and this line of code. But if you don't give any indentation here, that means that this line of code is not the part of the if statement. Now let's take another scenario, and this time I want to check whether the value of x is a positive value or a negative value. So I will start from here, and I will give one more if statement here, and I will just check whether x is greater than 0 or not, and then give this colon to indicate Python that I have finished this condition. And then if it's greater than 0, then I'm going to print that x is positive. Now if x is not positive, and if it has a negative value, I need to somehow print that x is a negative value. And for this you use a else statement. So here you can write else, and once again you need to give the colon here, and then under this else statement once again you provide 4 spaces or a tab indent, and you can once again write print, and this time we can write x is negative. This means whenever this condition is false, and if and only if this condition is false, then only the else part will be executed. So whatever code or block of code you write under else, that will be executed if and only if the condition here is false. So seeing the value of x, which is 100, which is obviously greater than 0, it's going to print that x is a positive value. Now when I change the value of x is equal to minus 100 here, and once again I execute the code, first of all it prints that x is minus 100 here, because first of all this condition is checked, and obviously minus 100 is not equal to 100. So this condition is true. So these two lines of code are executed because this condition is true. And here, because this condition is false, that's why this statement is not printed, and the execution of code goes to the else condition, and then this line of code will be executed, which is x is negative, and you can see here. And this line of code is independent of both these if statements, and that's why it will be printed always. Now as we have seen from our last video, that we can provide multiple conditions using a logical operators. So we can here also write that if x is not equal to 100, or if the value of x is less than 0, let's write here x is less than 0, then only we want to print this statement. So once again when we run the code, in this case both the conditions are true, that's why this is printed. If we write here that x should be greater than 0, then also this will be executed because one of the condition is true, and because in the case of OR we only need to satisfy one condition out of multiple conditions. In the case of AND, when I write AND here and run the code now, you can see this is not executed because one condition is true here and other is false, and in the case of AND, we need to satisfy both the conditions, and then only these two statements will be executed, or this block of code will be executed. So this is how you can use if-else statements in Python. Now in this video, I'm going to show you how to use else-if statement with if-else statements and how to use nested if statements in Python. So let's get started. So what I'm going to do is I'm going to declare a variable and I'm going to ask the user to enter some name. So I'm going to just write enter a name here. And when the user enters this name, I want to compare this name with some predefined names. So in the last video, we have already seen how to use if statement. So I can just write name is equal to, and I can compare it with some names. So let's compare it with a name called Max here, and I will give this colon here. And once the name matches this name, I'm going to print a name. So I'm going to just write name entered is, and whatever the name provided by the user. So I will just use this name variable here. This we have already seen in the last video. Now in Python, you can also use a else-if statement, and the signature of else-if statement is you can just write else-if here, and then you can provide some other condition which returns Boolean. So I can once again here write if the name matches some other name, for example Leo, and once again I'm going to just print a name entered by the user. And this else-if condition I can use any number of time after the if. Let me match this name to some other different names, for example Roy, and the last name will be Ali. So if the name matches Max, this statement will be executed. If the name matches Leo, this statement will be executed. If the name matches Roy, this statement will be executed. And if the name matches Ali, this statement will be executed. Now, if the name entered by the user does not matches any of these names, then we can use a else statement. So we can just write else here, and we can just print a message here. So the name entered is invalid. So this message will be printed when the name entered by the user does not match any of the name I am checking here. So let's run the code and let's see what happens. So now my code is running, and I'm going to give the name Max here, for example, and then press enter, and it prints this message which says the name entered is Max using this statement. Now once again, when I run the program and this name matches, let's say some other name, Ali, and then when I press enter, it prints the name entered is Ali, which means this statement is executed. And let me run the program once again, and when I give some random string here, it prints the name entered is invalid. Now let's say the name entered by the user is Max, and this condition evaluates to true, then this statement will be executed, and the other conditions which we have given using else-if statement will not be evaluated. So let's say we will write Max here also. So this condition and this condition is same, right? Checking for the same name, and when I run the program and when I write Max here, only one statement is printed, which is this one. So we can see when this condition returns true, only one statement is executed and none of the other conditions are even evaluated. Now the important thing to note here is you cannot start with a else-if statement. You need to start with the if statement. So you need to write a if statement and check the condition first, and then only you will be able to write else-if condition. Now it's possible to use multiple if condition, and then this else-if will become the part of this if condition, and this will be the separate if condition. So when I run the code once again and when I write max here, it's going to print two statements. One is using this and other is using this, because this if condition and this if condition are two different if conditions. And once you use elif, so I'm going to use elif here, then this elif is the part of this if condition. So this is how you can use if statement with elif statement and else statement. Now let's see how to use the nested if statement. So I'm going to declare a variable called x, and the value I will assign to x is 10, and then I'm going to write an if condition, and here I'm going to just evaluate whether x is less than 0, and when x is less than 0, I'm going to just print that x is negative. Else, if the value is not less than 0, so I'm going to just write else, then I'm going to just print x is positive. Now let's say I also want to evaluate if the x value is an even number or an odd number if the x value is positive. So under the else, I can once again write if, and then we can just evaluate this condition that if x modulo 2 is equal to 0, which means that when x modulo 2 returns a 0, that means it's an even number, so we can print x is even. Otherwise, in the else condition, I can just write else x is odd. So in this if condition, I'm checking if the value of x is less than 0 or not, and if this condition is not satisfied, then I'm checking whether x is a even number or x is an odd number. So if you remember, indentation here is very important. So this if condition falls under the else condition, right? So this if condition and this else is the part of the else statement. So because we have provided this 4-space indent here, whatever code you write with this indent is a block of code. And what we are essentially doing here is we are nesting one if else condition inside the other if else condition. You can also reverse this condition checking, and you can also say if x is greater than or equal to 0, then the value of x is positive, otherwise the value of x is negative. And this statement you can write under the if condition also, and this is also a nested if else statement. And let me run this program, and you can see x is a positive value because x is equal to 10, and x is a even value. So once this condition is true, this statement will be printed, and whatever if condition is there inside the parent if statement, that will also be executed. And this condition is checked first of all, and obviously this condition is true in this case when x is equal to 10, because when you do x modulo 2, it's going to give us the remainder 0, and that's why x is a even value, and that's why it's printing x is even here. So it's totally possible to use one if else statement inside the other if else statement, and this type of if else statement are called nested if else statement. In this video, I'm going to show you how to use lists in Python. So first of all, what are lists? So list in Python is a kind of collection which allows us to put many values in a single variable. You can also say that list is an ordered set of values. So let's define a list. So I'm going to just say x is equal to, and you can define a list inside these square brackets, and inside the list you provide some values. So for example, I'm going to provide the values 3, 5, 4, 9, 7, 10. So this is how you can create a list in Python. And when I press enter, it's going to create a list, and when I just use x to get the list, is going to provide me all the values in the list. Now these values which are inside the list are called elements. So 3 is an element, or 5 is an element, or all these values in this list are all called elements. And all these elements are ordered by their index. Now index, as I already said in the previous videos also, always starts from 0. So we can fetch the value which is at index 0 using this square bracket once again with the variable name, and then when I write index 0, it's going to give me the element which is saved at index 0. So looking at this list, 3 is at index 0, 5 is at index 1, 4 is at index 2, and so on. So let's say I want to get the value which is at index 4, 0, 1, 2, 3, 4. So I'm going to just write x square bracket 4, and it is going to give me 7, which is saved at index 4. Now it's not necessary that list must contain all the same data type elements. So for example, I can also declare a variable called y, and in this I can save some name, for example max. I can save integer, let's say 1. I can save a decimal value, let's say 15.5. I can save other list inside this list using these square brackets, for example 3, 2. So one list can contain different type of data types with any number of elements. So when I press enter, and this time I want to get the value which is at index 0, it's going to give me max. And once I want to get the value which is saved at index 3, then it's going to give me this list which I have saved at index 3. Now when you try to access the index which is not there, so I'm going to just write y, and then I'm going to say 100, and this value is not present in this list at this index. So I'm going to press enter, and it's going to give me the error which says list index out of range. Now if you want to get the length of the list, you can use the inbuilt function in Python, which is len, and then your list name. So for example, I want to find out the length of list x. It's going to give me 6. It's going to give me 6 because you can see here this list contains 6 elements. Or I want to get the length of the second list, which is y, and it's going to give us 4 because this list contain 4 elements. Now it's also possible to insert and remove elements from the list. So for example, I'm going to use x, which has 6 elements till now, and I'm going to insert the 7th element. So I can use a method called insert, and you can see this method takes an index and the object name. So I'm going to choose this, and the index at which I want to insert the value is at index 2, and the value I want to insert is some string, for example Tom, and I'm going to press enter, and I'm going to print the values inside the x list. Then you can see now this list has 7 elements, and Tom is inserted at the index 2 because we have inserted this value at the index 2. In a similar way, you can remove something from a list also. So to remove something, you can use your variable name, for example x dot remove, and the value you want to remove. So for example, once again, I want to remove this name which I have inserted at index 2, and once again when I print the value of x, it's going to give me these values. Now let's say the list contains 2 elements which are exactly the same. So I'm going to insert one more element at index 1, and this element will be 3, for example, and now my list contains double 3 here. And if I want to remove this 3, so I'm going to just call this remove function once again, and I will say 3 here and then press enter. You can see only 1 3 is removed from this list. So you can see these 3 are at index 0 and index 1. So this value is removed, which is at index 0, and this will remain in this list. So if a list contains duplicate values, it's going to remove the value from the left, and also remove is going to remove only one object, which is found first in the list. Now if you try to remove the element which is not there in the list, so I'm going to remove something which is not even there in this list, then it's going to give us this error which says that this is a value error and it cannot remove this value from the list. Now there is one more function with the list which is a pop method, and this we can use to remove the values from the last. So you can see our list was previously having 6 elements and 10 was the last element, and when you use this function which is pop, it's going to pop this 10 from the list. And now let's see the content of the list. So now this list contains only 5 elements and the last element is now removed. Once again, when you use this pop method, it's going to remove the 7, and now our list only contains 4 elements. Now let's say you want to delete the whole list. So I'm going to declare a list, and this list will contain a few values, and then I will press enter and you can see the values of list. And now I can use a function called del and then the name of the list, and this function is going to delete this list. So I'm going to just press enter and then once again try to access the values inside this variable, and now it says the name Z is not defined because delete function has deleted this list. Now once again I'm going to create this list Z, and now there is a function called clear which is used to remove all the values from the list. So I'm going to just press enter and then try to access the value of Z, and you can see this list is now empty because we have used the clear function which is used to empty the list. Let me show you a few more functions related to lists. So let's say I can use X, and the values inside X are 3, 5, 4, 9, and I can use a function called sort to sort all these integer values inside the list. And once I press enter now you can see all the values are sorted, and you can see all the values are sorted in ascending order. You can also use this method x dot reverse, and it's going to reverse all the values. So once I use the reverse function and then when I try to get all the values inside the list, you can see all the values are now reversed. There is also a function called append, and here you can append anything to your list. So I want to append 10 to my list, and when I try to access this list, you can see at last this 10 is appended in my list. Also, if you want to copy one list into another, you can use, let's say I'm going to declare a variable called s here, and I want to copy all the values from X list. I can use x dot copy, and this is going to copy all the content of my X list into this new variable called s. So you can see all the values are copied into the variable s. So let me append something into my list once again. So I'm going to append 10 once again, and now my list looks like this. And there is a function called count, using which you can count the number of element which are there in the list. So I want to find how many number of 10 are there in the list. It's going to return me 2. And once again I want to count how many 3s are there in the list. It's going to return me 1. Let's say I want to count how many hundreds are there in my list, and it's going to return 0. So this is how you can use lists in Python. You can also use the list name and then dot and see all the methods which are available related to list here, and you can use these methods which you see here. In this video, we are going to see how to use tuples in Python. So first of all, what are tuples? So tuples are very similar to lists. That is, they are used to store the collection of elements in a single variable, but there is a very important difference between them, and that difference is tuples are immutable. Immutable means once tuples are created, they cannot be changed, or the content in them cannot be changed. So let's see how we can declare a tuple. So I'm going to declare a variable called x, and I'm going to assign some values to it. Now in case of list, we have seen we used the square brackets. In the case of tuples, we use these parentheses in order to store the list of elements. So I can just write 1, 5, 3, 4 and 8 for example, and then press enter, and it's going to create a tuple. Now in order to print the tuple, you can use X and it's going to print this tuple. Now as I said, tuples are similar to lists in some ways, and that means you can call a tuple element by our index in tuple. So all the tuple elements are arranged by their index, and when you want to, for example, get the first element here, you give the index 0 and then press enter, and it's going to give you the value which is saved at index 0. Let's get the value which is saved at index 4, and I'm going to press enter, and you can see it gives 8 which is saved at index 4. Now when I try to give an index which is not there, for example 100, it's going to give us error which says index error, tuple index out of range. Now as I said, tuples are immutable, that is you cannot change the content of a tuple if they are initialized once. So let's try to test this. So I'm going to just assign the value at index 0, which is let's say 2, and I'm going to press enter, and you can see it says type error, tuple object does not support item assignment. That is, you cannot assign any other value to a tuple element if they are once initialized. Now that also means that you cannot use some of the functions which you used with lists in the tuples. For example, you cannot remove any element, you cannot append any element, you cannot change any element. So for example, when I write X here and then press dot, you can see there are few methods which are available with the tuple, and most important is this count method. So let's try to use this count method, and I want to know how many number of 8 which are there in this tuple, and it will give me 1 because 8 is only present once in this tuple. If 8 is present twice in this tuple, here you will see the result 2. Now in order to get the length of the tuple, you can use the inbuilt function which is len, and then the tuple name, and then press enter, and it's going to give you the length of the tuple. Now in the previous video, I have told you that you can save multiple data type values in lists. Let's see if we can do the same with tuples or not. So I'm going to give the parenthesis, I'm going to give the first value as integer, second value as a string, third value as for example the decimal value, and I'm going to press enter, and I'm going to get the value of y, and you can see it's totally possible to save multiple data type values in a tuple. So now I have declared two tuples, one is x and other is y. So let's print x and y once again very quickly, and now what we want to do is we want to use a concatenation operators. So as I said, tuples are immutable, but let me define a third tuple here, and I want to add x tuple and y tuple here, and I want to assign the value to z. Is it possible? Let's check. So I'm going to just once again see the contents in the z variable, and you can see when you use this plus operator or concatenation operator, it's going to join these two tuple and create a new tuple with the combination of the values of both these tuples. Now there is one interesting thing which you can do with a tuple, which is you can declare a variable, and let me define a tuple with only one element, and I'm going to just give hi here, and then after this element I'm going to provide comma here. So this is important, I have provided this comma and I haven't provided the second element in the tuple, and I can use an asterisk here and I can use some value here. So let's say I have provided 5 here, and I'm going to press enter, and then I'm going to see the values inside this a variable, and now you can see hi string is saved 5 times in a variable in the form of a tuple. So you can once again get this value at index 2 for example, and it's going to give you the value which is stored at index 2, which is hi itself. You can also use an inbuilt function called max here to get the maximum value out of a tuple. So max, and I have provided x tuple here, and you will be able to see it will give us the maximum value stored in that tuple. And you can see here 8 is the maximum value which is there inside the tuple. We can also get the minimum value using min function, and it's going to give you the minimum value which is stored inside the tuple. And also you can use our del function to delete a tuple. So let's say I want to delete this tuple which is z here, so I can just write the name of the tuple after del and space and then press enter. And now once again when I try to get the value of z, it's going to give me error which says name z is not defined. So in order to delete the tuple, you can use the del function. So this is how you can use tuples in Python. In this video, we are going to learn how to use sets in Python. So first of all, what are sets? So a set is an unordered collection with no duplicate elements and no indexing. So let's see how we can use sets in Python. So you can declare a variable and then is equal to, and you define the elements in set in a curly bracket. So you can define multiple values here, for example 1, 2, 5, 4, 7, 9. But keep in mind that set cannot have duplicate values. So each value in set must be a unique value. So for example, what happens when we define a set with some duplicate values? So I'm going to just declare this set and press enter here, and this set is created. Now whenever I try to access the values inside this set A, then it's going to give me this set. And you can see the 2, which was a duplicate which we have defined here, is removed from this set. So a set always have unique values, and if you define a set with duplicate values, it's going to remove the duplicate values and only save the unique values in the set. So let's see some of the methods related to sets. And the first method is, as always, len method, and you can find the length of a set using this len method and the name of the set, which returns the length of a set. You can also use add function, so a dot add, to add an element in a set. So I want to add 10, for example, into my set. I can use this and then press enter. And once again, when I try to get the values inside the set A, you can see 10 is added to this set. But this 10 will only be added if it's already not there in the set. If it's already there in the set, nothing will happen. So let's try to add once again 10 to this set, which already have a set. And once again, you will see that nothing happens inside the set because 10 was already there. Now, if you want to add multiple values in a set, you can use a update method. So you can call this method, which is update, and then inside the curly brackets, you need to provide these multiple values. So let's add some values into this set. So I'm going to add 15, 18, 17, let's say, and 14. Okay, and then press enter, and now I will see the values inside the set, and you can see all these values are added to the set. You can also remove the values from the set. So I can use a method called remove, and let's say I want to remove 18 from this set. I can just give the element and then press enter, and once again I will try to access the set, and you can see 18 is removed from this set. Now there is a method called discard also. So let's see how we can use this method. Discard works similar to remove method. So for example, I want to remove this 17 from my set. I can write 17 here and it works fine, right? So when I try to access the value of A, 17 is removed. So what is the difference between a discard method and a remove method? So a remove method, whenever you use a remove method and you try to remove an element which is not there in the set, for example, I will try to remove 100 which is not there in the set, it's going to throw an exception and it says key error 100. Now if you try to do the same thing using a discard method, so I'm going to use a.discard here and try to discard 100 from the set which is not there in the set, it's not going to give me any error. And that's the difference between discard and remove. So remove throws an error when an element is not there, but discard doesn't throw any error. It's not going to do anything if the value is not there in the set. Now there is a pop method also you can use with set. So I can use this pop method and then press enter. And what it's going to do is it's going to remove any random element from your set. So it's not necessary that it's going to remove the element from the left hand side or the right hand side. It will remove any random element from the set. Also, for example, I will declare a set of names, let's say, and if you want to clear the set, you can use a clear method. So I can use this clear method in order to empty this set. So now when I try to access the values inside the set, you can see it's an empty set with no values. If you want to delete a set, you can use a del function and then the name of your set and then press enter. And once you delete it, when you try to access it, it's going to give you an error that name is not defined. Now you can also create a set using a set constructor. So instead of these curly brackets, you can write set and in the double parenthesis. So you need to provide the double parenthesis here in order to create a set using the set constructor. So this is also going to create this set called name, and when I try to access the values inside the set name, you can see it has created this set of names. Also, you can convert a list into a set. So let me define a variable called z, and then I can use a set constructor, and inside these parentheses I can use these square brackets which we use generally with lists, and then you can define your list here and then press enter, and this list will be converted to a set, and you can see the result here. Now similar to the mathematical set operations like union, intersection, difference, symmetric difference, you can also use these mathematical operations related to set on the Python sets also. So let's see how we can use this mathematical set operations on our Python sets. So let me once again define a set. I have already one set which is A, which contains these values, for example, and I will define a set B with some other set of values. So I'm going to define a set with, for example, so that is the content of the set B. Okay, so now I have two sets, and on these two sets I want to perform some set operations which are also used in mathematics. So you can find out the union of two sets using an operator called OR. Okay, so when I write A and this pipe symbol which is called OR B, it's going to give me the union of these two sets. And what is the union? So union of two sets contain all the elements that are there in the set A or in the set B. So OR here is important, right? So I'm going to press enter, and you can see it's going to give me the union of A and B. That means this set contains all the elements that are there in set A or in set B. Also, I can use a method called union instead of this OR operator. So I can use a variable dot union. There is a method called union, and then you can write B here and then press enter, which is going to give you the same answer. Okay, so you can either use this union method or this OR operator. Now let's see how we can find out the intersection between two sets. So in order to find out the intersection, you use A and this operator AND, and then your next set which is B here. So what is an intersection of two sets? So intersection of two sets contains all the elements that are there in both the set, that means set A and set B. Okay, so when I press enter, you can see it gives me two elements inside a set, and these two elements are there both in the A set and the B set. That's why we get only two values, because these two values are there in set A and set B also. Again, you can use a method called intersection. So A intersection and then B, which is going to give me the same answer. So either you can use this method or you can use this operator. Now let's find out the difference between two sets. So what is a difference between two sets? A difference of two sets contains all the elements that are in A but not in B. Okay, so you can find out the difference by this minus operator here. So when you write A minus B, you will be able to get the difference between these two sets, and this result will contain all the elements that are in A but not in B. You can also use B minus A, and then it's going to give you other result, because this time it's going to give you a set which contains all the elements that are there in B and not in A. So difference between set A minus B is totally different from B minus A. And also you can use a difference method. So A, then you can call a difference method B, and it's going to give you the same kind of answer you can see here. And also you can call B dot difference A, and it's going to give you the another answer of B minus A. Now you can also find out the symmetric difference between two sets. And what is the symmetric difference between two sets? A symmetric difference between two sets contains all the elements that are either in set A but not in set B, or they are there in set B but not in set A. So this is the symmetric difference, and you can find out the symmetric difference using this cap symbol and then B. So A cap B, I don't know what is the exact name of this symbol. You can find out by yourself, and when you do this, it's going to give you the symmetric difference between A and B. And whenever you find out the symmetric difference, then when you do, for example, B, this cap symbol A, it's going to give you the same answer, because symmetric difference give you same answer. Whether you give A cap B or B cap A, the answer will be always same. Also you can use a method symmetric difference. So you can use this method called symmetric difference B, and it's going to give you the same kind of result. Now one last thing I want to show here is sets are not indexed or ordered. So whenever you want to find out, for example, A and the value at index 0, it's going to give you an error because there are no indexes in a set and they are not ordered by any index. So sets are unordered collection of values. Now if you want to find out what all other methods you can use with sets, you can create a set and then write the name of your set and then press dot here, and you will be able to see this is the list of all the methods which you can use with the sets. Also, if you want to list out all the methods which you can use with sets, you can use this inbuilt function dir, and then you can provide any set name here, which is your variable name, and then press enter, and once again it's going to print the list of all the method which you can use with the sets. So this is how you can use sets in Python. In this video I'm going to show you how to use dictionaries in Python. So first of all, what are dictionaries? So dictionaries in Python are like associative lists or a map. Now you can think of dictionary as a list of pairs. So let me show you how to define a dictionary. So you can define any variable name, and to define a dictionary, first of all you use these curly brackets, and inside these curly brackets you provide a list of key value pairs. So let's provide the list of key value pairs. So first key is name, and the name is Max. The second key is, for example, age, and the age of Max is, let's say, 14. And we can also write here in which year he was born. So we can just write year, and he was born in 2004, for example. And I'm going to press enter here, and once again I'm going to just access the values inside this dictionary, which is D, and you can see our dictionary is created now. So as I said, dictionary is a list of key value pairs, and all these values which you see here before this colon are called keys. So name is a key here, year is a key here, and age is a key here. And whatever values you see after the colon are called values. So Max is a value, 2004 is a value, and 14 is a value. And you can access the values from a dictionary based upon their keys. So for example, I have this dictionary D. I can use this square bracket, and the key name, for example, I want to get the name value. I can just give the name key here and then press enter, and it's going to return me the associated value related to key name. In the same way, you can use other keys also, for example, age, and I'm going to press enter, and it's going to give me 14, which is the value. So age is a key here and 14 is the value. Now what type of data types you can store in a dictionary? So as key, you can define any data type. So let me define a new dictionary here, and I'm going to give these curly brackets. And as I said, you can define a string value as key. Also, you can define a number as a key, for example, 15:15. Let's try the float values. So I'm going to just write 15:15.1. This is also allowed in dictionary. So you can use string values, you can use integer values, you can use decimal values as key. And also let's try the Boolean values. So you can use the Boolean values also as keys. And you can use a tuple also as a key. So I'm going to just give a tuple 2, 3, and then I'm going to assign a value of 5 to this key. And as values also, you can use string values or decimal values or integer values or a Boolean values or any kind of collection you can use as a value. So I'm going to press enter here. And now to access, let's say we want to access the value for this key, which is this tuple. So I'm going to just enter this tuple inside these square brackets, and it's going to return me 5. Or I can just provide inside the square bracket true here and then press enter, and it's going to return me the value which is associated with it, which is true itself. Or I can just write here 15, and it's going to return me 15 in turn, because 15 is associated with this value, which is also 15. Now what happens when a key is not there and we try to access it? So I'm going to just access 100 from this e-dictionary. It's going to give us error that this key is not present in the dictionary. You can also use the len method to find out the number of items in the dictionary, and you can see it says 5 items are there in the dictionary E, and we can count these items. So this is 1 item, 2 item, 3 item, 4 item, and the 5th item is here. Or in other words, you can also say that len function is going to return you the number of key value pairs which are stored in our dictionary. You can also use, for example, I'm going to use my D dictionary now, and you can also use a method called get, and then you can give the key name here in the parenthesis. So let's say I want to get the value associated with the name key. I can get it like this, and it's going to give me the value associated with the name key. You can also add a new key. So this D dictionary, you can see there are right now 3 key value pairs, and I can add one more key value pair. So to add a key value pair, you need to just write D, and in the square bracket you just need to give the name of the new key. So I'm going to just write surname here, which is the name of the new key in the dictionary D, and then you need to give the value associated with that key. So when I press enter, and once again when I try to access the values inside the dictionary, now you can see that surname is added to your dictionary. Now if you want to remove any key value pair from a list, then you can use d.pop method and then the name of the key which you want to remove. Let's say we want to remove the surname once again, which we have added, and you can just press enter, and now you can just print the values inside D. Now you can see the surname key value pair is removed. You can also use a clear function. So let's see what's there in the E dictionary. So these are the values inside E dictionary. I can use E.clear to clear the values inside the E dictionary. So once again when I try to access E, it will give me the empty dictionary. Also you can delete the dictionary using del function and the name of the dictionary, and when I press enter and when I try to access this dictionary E once again, it's going to say that this name is not defined. You can also update the values in a dictionary. So this is my dictionary and I want to update the name, for example. So I can use the dictionary name and then the key here, for example name, and the new name I want to associate with this key is, let's say, a new name here. And when I try to access this dictionary once again, you can see the name is changed. You can also use a method called update to update this key value pair. So once again I want to change the key value pair, which is name. So I can give this curly bracket and then give the key value pair which I want to change. So name, and the new name will be Max once again. And once again when I try to access the dictionary, it will give me this dictionary, and you can see the name is updated now. Now there is a function in dictionary called keys, which is used to list out all the keys of that dictionary. So you can see it will list out all the keys of the particular dictionary. There is also a function called values, which will list out all the values of that dictionary. If you want to list out all the key value pairs, you can use the function called items here, and it will give you the key value pair list. Now the last function I want to show here is, let me list out the content of the dictionary first of all. So there is one more function which you can use here which is pop item, and you don't need to give any argument with this pop item. When you press enter, it's going to remove the last key value pair which you have added or updated. So here we have updated this name key value pair, that's why this is removed. And now when you try to see the content of the dictionary, this name key value pair is removed. So this is how you can use dictionaries in Python. In this video we will talk about the slice function in Python, and also we will talk about how to use negative numbers with index in Python. So let's get started. So first of all, I'm going to declare a list. So now we have three variables. First is a list, second is a tuple, and third is a string. Now there is a function called slice which you can use with your lists, tuples and strings to slice something out of your collection. So to use this slice, I'm going to declare a variable, and then I'm going to use this function which is slice, and you can provide some parameters in the parentheses here. So the first parameter you can provide here is, for example, start. The second parameter you can provide here is the end, and the third parameter you can provide here is the step. So let's say I want to get out of this list the numbers from 0 to 4. So as a first argument we can define number 0, which is the first index, and at the end index we can define 5, and then I'm going to press enter, and once again I'm going to use my list variable and pass this x variable which contains the slice object which is returned by this function here, and then press enter, and you can see here it gives me the values from 0 to 4. So the first argument in the slice function is the index from where you want to start. The next parameter is the index of the element before which you want to stop. Okay, so if you want to stop at 4, you provide the index 5. If you want to stop at index 5, you will provide the stop value as 6. Okay, so it will be always one more than what you want. Now there is a short notation for achieving the same also, and for that you can use your list, and inside the square bracket you can provide the start value and the end value, and then press enter, and it's going to give you the answer. But instead of comma, I need to provide the colon here, and then it will give me the answer. Okay, so here you can use colon to give the start value and the end value, and also an optional value which you can give as a third parameter, which we will see in a moment. Okay, so this is the short notation of creating slice in Python. So as I said, this is the start value and this is the end value plus 1. Okay, so let me show you something. I have a list here, and you can see here I have written, you have the variable a, it can be a list, it can be a tuple, or it can be a string, and inside the square brackets you give the start value and the end value separated by this colon symbol, and what it's going to give you is the items from start through end minus 1. Okay, so whatever end value you will give here, you will get the value end minus 1. You can also use this notation, so start colon and without giving the end value, and also reverse is possible, so you can give only the end value and not the start value, and also this notation is possible. So we will see one by one how to use all these notations. So first of all, I will give, once again I will use the tuple now, and this time I'm going to just give the start value. Let's say I want to start from 4 here, and then colon, and then press enter, and it's going to give me the result from index 4 until the end of this tuple. Once again, let me give the end value. So instead of using this value before colon, this time I will give the value after the colon, and I will leave the start value blank. And here let's say I just want to go before 6, so I'm going to press enter, and you can see it will give me the result from 0 to 5, that is end value minus 1, right? So until 5. And also you can give this kind of notation. So this time I'm going to use the string variable, and you can use colon without giving the start and end value, and when I press enter, it's going to give me the whole string. Let's say if with this string I want to provide the start and end value, let's say 0 to 5, and then press enter, it's going to give me a string from 0 to 4. So this slice functionality you can use with the tuples, lists, and also with the string, or essentially whatever collection which have the indexes, you can use this kind of slice notation with those kind of collections. Now in addition with the start and end value, you can also give the step values. So let me just print the value of a once again, and you can see the values inside the a. And let's say I want to get out of this list 0, 2, 4, 6, 8. Okay, so essentially I want the every second value from the list. So what I can do here is I can give the variable name and then start to end, so from 0 to index 9, and the third argument here you can give is the step. So let's say I want to get the every second value, so I can give 2 here and then press enter, and it returns me 0, 2, 4, 6, 8. Now let's say I want to get every third value, so I can write 3 here, and it's going to give me 0, 3, 6. Okay, in a similar manner, if I want to get the every fourth value, I can write 4 here and then press enter, and it gives me 0, 4, 8. Also, if you don't want to give this range from start to end, you can leave the start and end value as blank and then press enter, and it's going to give you the same result. Now in Python, you can use indexes with the negative numbers also. So let me explain what I mean by negative number index. So let's say I have a string called Python. It have these character Python. You already know that you can access the P character or P letter using the index 0 and the Y letter using the index 1 and the T letter using the index 2. So this is the positive index, right? You can also use the negative index, which starts from the right hand side. So it starts from N, and the index you can give here is from -1. So the last index here will be -1, then -2, -3, -4, -5 and -6 here. So let's use these kind of indexes and let's see how we can use them. So we have this string here, and let's say I want to get this value, which is 9, which is the last letter of the string. So I can use C, and here inside the square bracket I can give -1 and then press enter, and it's going to give me the last letter of the string. If I give -2 here, it will give me the second last letter. Okay, so the negative index starts from the right hand side and it goes from -1 till the end of the string. Now let's use this negative number index with the list which we have. So we have this A list, and we can use A, and then we can give a colon -1, which is going to give you all the numbers in the reverse order in the list. So our list was starting from 0 to 9. It will give us 9 to 0 in the reverse order. Now let's say if you want to get the first two items in the reverse order. So this is when you use this -1 as the third parameter, it will give you everything in the reverse order. Okay, so -1 as the step value is used to give everything in the reverse order. So when you give, for example, 1 here and leave the end parameter empty, it's going to give you, you can see 1 0. So as you can see, our list starts from 0 1, and it's going to give us the reverse order values. So it's going to give us 1 0, because here we have given 1 and it's the end value for this reverse string because we have used the -1 here. Let's take some more examples. So instead of the start value, I can give -3 here and then press enter, and you can see it gives us 8 and 9, which are the last two items of the list in the reverse format. Okay, because our index in reverse starts from -1, -2, -3, and we are skipping the -3 option because we have seen that we just take the end -1, right? So -1, -2, and these will be given to us in the reverse order because we have used -1 here. Now you can also give, for example, -3 as the start value. So I'm going to give the -3 as the start value and then press enter, and it's going to give us 0 to 7, right? So 0 to 7 except 8 and 9 in the reverse order. So because 3 this time is the start value and end value is until the, so because 3 this time is the start value, so we go from -1, -2, -3. So -3 is this index and this is the start value. So we get 0 to 7 in the reverse order. So this is how you can use slice function and negative values with indexes in Python. In this video, I'm going to show you how to use loops in Python, and we will start with the while loop. So first of all, what is a loop? So a loop allows us to repeat over some block of code again and again until and unless some condition is met. Now let's see how to use while loop in Python. So let's say I'm going to declare a variable called I, and I'm going to initialize it with the value 0. And to use a while loop, you use this keyword and then you provide some condition. So let's say I want to check whether the value inside the I variable is less than 5 or not. Okay, and as in the case of if also, we have seen we provide after the condition this colon symbol, and then in the next line we write the code which we want to perform again and again until this while loop condition is true. So let's say we want to just print something, and we will print that the value of I is, and then we will print the value of I like this. Also, I want to change the value of I with every step. So I will change the value of I using this expression, which is I plus equals 1. This essentially means that we want to just add 1 every time whenever this code is executed. Also, we can say that we want to perform this operation I is equal to I plus 1. So this statement is similar to this statement. Let me provide some spaces here. Now in here also you will observe that I have provided some indentation here, and indentation means that these two lines of code is the part of while loop. Okay, so when I want to write something outside the while loop, I will start from here with no indentation, and let's say I want to just print that we are finished. And now let me run the code and let's see what's the result. And you will see here, first of all, this string is executed, which is the value of I is, and then the value of I is printed, which is 0, 1, 2, 3 and 4. So as you can see here that we have initialized I is equal to 2. So the initial value of I is 0. Now when we come to this code and when this condition is checked, here the value of I is 0, which is less than 5. That means this condition is true, and that means that these two lines of code which are under while loop will be executed. So this line is executed where value of I is printed, which is I is equal to 0, and this line of code increments the value of I by 1. So when this line of code is executed, now the value of I becomes 1 because previously it was 0, and once again this program flow goes to the starting to evaluate this condition, and this time the value of I is 1, which is less than 5, and the condition is true once again, and again this line of code is executed, and this line of code is executed, and the value of I is incremented by 1 once again, and the value of I becomes 2 here, and this will happen again and again until the value of I becomes 5. And when the value of I becomes 5, this condition will be false, and that means this code will not be executed. This code will only be executed when the while loop condition is true, and then at last this line of code is printed, which is finished while loop. Now let me give you one more example of while loop, and I will start from the top once again, and this time I will declare a variable called num, and I will initialize this value by 0, and also I will declare a variable called sum, and initial value of sum is also 0. Now here first of all I will ask the user to enter a number, so I'm going to just write, and also I will ask the user if he or she wants to exit from the loop, he can enter zeros. And then in the next line I will start with my while loop, and I will give the condition if the number, so if the number, I'm going to write number, is not equals to 0, we want to perform some operations. And what operation we want to perform? We want to ask the user to provide any number, and we will transfer this number into the variable num. So here I will first of all write input, and then I will ask the user to provide the number. And when the user provides the number, I want to convert it to a float value, so I will just typecast this input to a float value, and then this number will be assigned to the variable num. Now here don't forget to give the colon, and in the next line what I will do is I will just use my sum variable, and I will just add the number value to the sum. So I can just write sum is equal to sum plus num, and this means that initially the value of sum will be 0, and then this number will be added to the sum, and until this loop runs we will get the sum of all the numbers which is entered by the user. And at last I'm going to just print the value of sum. So now what do you think will happen? So in this condition we are evaluating that num should not be equal to 0, and then only this code will be executed, and we have provided the initial value of number is equal to 0. So this condition will never be met and this statement will never be executed. So we need to provide the initial value of num is equal to 1, and then whenever the user provides the value, this 1 will be overwritten by the value which is provided by the user. So this time when we run the code, you can see first of all the program asks us to provide a number. So I will provide 100 here and then press enter, and you can see the sum is printed which is equal to 100. Once again we will provide some number and then press enter, and now you can see sum is equal to 150. Once again we will provide one number and then press enter, and now the sum is 1050. Now let's say we provide a number is equal to 0 and then press enter. You can see that our while loop is finished because 0 is not equal to 0, that means a false condition, and then the flow of program comes out of the loop, and then the other while loop will be executed, which is this while loop, and that's why this output is printed. We can also write that sum is equal to, so we know that this is the sum, so sum equals, and then after the comma we will print the value of sum. And once again when we execute the code, and once I want to exit from the code, I can use 0 to exit. So 0 and then press enter, and I come out of this loop. Now Python also supports the else statement to be associated with the loop statement. So what I mean by the else statement to be associated with the loop statement is that I can use after the end of this while loop condition, I can use here else, and after the colon I can provide some code which I want to execute once this loop is finished. Okay, so I can write here that I want to print, for example, finished sum. So let me run the code once again, and I will quickly provide some numbers here and which will provide the sum, and when I provide 0 here, then we come out of the loop, and you can see this finished sum string is printed using this else. So once your program comes out of the loop, this else statement will be executed. Similarly, we can go down, and here also instead of writing this finished while loop, we can also give else statement here. So I'm going to just write else, and after the colon here I need to provide the indentation. So 4 space indentation, 1 2 3 4, and everything will be okay. And once I run the code, and first of all I will provide 0 here to see if this is executed, and you can see this else condition is called once your while loop is finished. Now also you can provide some condition here which is always true. So for example, I can write true here, and this means that while loop evaluates to true every time, and this means that this statement will be executed forever. So this is also possible, but you need to think carefully, what do you want to do? Do you want to execute this code infinitely, or do you want at some time that this condition will be false? So this is how you can use while loops in Python. In this video, we are going to see how to use for loops in Python. So first of all, what are for loops? So a for loop is used to iterate over a sequence, and that sequence can be a list or a tuple or a dictionary or a set or a string. So for that, I'm going to declare some variables, and the first variable is A, which is a list. Second variable is B, which is a tuple. Third is C, which is a set. Fourth is a string, and fifth variable is E, which is a dictionary. Now before seeing the syntax of for loop, I'm going to show you how to use in operator in Python because it's used in for loop. So I'm going to first of all use print, and then I'm going to use 0 and then use in operator, and then I'm going to use this first variable which is a, which is a list, right? And let's see what happens when I try to run this code. So it prints true. So in operator will give you true or false depending upon whether this value is present in your sequence or not. So for example, when I write 100 here, which is not present in the list, it's going to return us false. So this you can use with the tuple also. Let me just use it with tuple, and let's use 1 here, and I'm going to run the program, and it prints true once again. Also we can use in operator with strings, so I can write D here, but for that I need to convert this 1 into a string. So now when I run the code, it will give me true. Now let's see how to use a for loop in Python. So for loop, as I said, we can use with some sequence. So let's use it with a, which is a list. So I can write x in a, and a is a list in this case, and then I can just print the value of x, and let's see what happens first of all when we just write this kind of a for loop. So we are going to run the program, and what it does is it prints the values from 0 to 5, which is the element present inside the list. So for loop is going to iterate over your list one by one, and this in operator is going to check whether this value is there in your sequence or not, in this case in our list or not. So first of all, when for loop start, it will transfer the first value, which is 0, into x, and then it checks whether x is in this list A or not, and then it's going to print the value of x, which is 0. And once again program sequence goes here, and once again the next value is transferred to x, which is 1, and once again this condition is validated if 1 is in this list A or not, and then the value of x is printed, which is 1. And this iteration goes on and on until 5 is reached, which is the last value in the list. So 5 is printed, and after that there is nothing inside x, and then the program flow comes out of this loop. You can also use this for loop with the tuple also. So let's try it with tuple, and let's see what happens. And it's going to print the same values. Also with the set, let's see what happens. So I'm going to run the program once again, and it prints 0 to 5 once again, because these are the content of the set also. Once again, let's try to use this for loop with the string, and let's see what happens. And it's going to print out the content of this string, which is 0, 1, 2, 3, 4, 5, and it prints them one by one. Now with the dictionary, we use this for loop in a little bit different way. So for example, I will write the variable name, which is a dictionary, and then let's say I want to just print all the keys inside this dictionary. Then I can write e.keys, and then we have all the keys using this function, and when I run the code, it's going to print all the keys inside your dictionary. Also, when you use the function called dot values, it's going to print out all the values inside your dictionary. You can see max and the age 20. Now let's say you want to print out all the key value pairs which are there in your dictionary. You can use a function called items, and this is going to give you keys and values, right? So I can just write key, comma, value here, and then I can print the value of key first of all, key, and let's provide some space here, and then let's print out the variable value here, okay? And when I run the code, it's going to give you first of all key and then the value, once again key and then the value. So in order to print out the keys and values from a dictionary, you can use this kind of notation. Now you can also use a function called range. So let me show you how to use this function, which is range, which returns us the values starting from 0. So there is a function called range here, and in here you can provide a number, and this range is going to return the number starting from 0 to 5. So whatever number you write here, the range will be returned from 0 until that number except whatever number you write here. Okay, so let me just try to print out the values which is there in the X, and when I try to print this, it's going to return me from 0 to 5. And you can see here 6 is not printed because the range will give us the value except that value which you write here. You can also provide the start value here. So let's say I want to start from 2 and I want to go until 5. I can write something like this, and now you can see now it start printing from 2 to 5. Also, you can give a third parameter here, which is a step parameter. So I can give 3 here, for example, and let's say I want to write 30 here, and let's run the code. And now what is going to return is it starts from 2 because we have given the start value 2 here, and it's going to go until 29 because we have given 30 value here, right? And this is the step. So every third value will be printed after 2 here. So 5 will be printed, then 8, then 11, 14, 17, 20, 23, 26 and 29. Every third value, right? If you write here 2, then we will increment in the step of 2. So this is how you can use range function with your for loop. Also, as I said in the last video, you can use else statement with your loops. So I can also write else here, and then after the colon in the next line I can print something, or I can execute some statement. So for now I will just print finished, and then I'm going to run the code, and once the loop is finished, you can see this else statement is executed, which prints finished. So else statement will be executed once your for loop is finished. So in this way you can use for loops in Python. In this video I'm going to show you how you can use break and continue keywords with your Python loops. So to start with, I have here 2 loops. One is a for loop and other is a while loop. Now this for loop takes a list and then print every element out of this list using this print function. In a similar way, while loop evaluates the value of I. If it's less than 5, then it's going to print the value of I and then increment the value of I by 1. Now this is all normal and we have already seen this kind of code. Now you can use a break keyword with your loops in order to terminate the execution of loop immediately. So let's see how we can use break keyword first, and then we will see how to use continue keyword. So here I'm going to give a condition inside my for loop, and I'm going to just evaluate whether x is equal to 3 or not, and if x is equal to 3, I'm going to use this break keyword. In the same way, I'm going to use this if condition inside my while loop also, but instead this time I'm going to evaluate I is equal to 3, and if I is equal to 3, then I'm going to use this break inside this if condition. So let's run the code and let's see what happens. And you can see in the for loop it has only printed 0, 1, 2. Even though this for loop is supposed to print from 0 to 5, it has printed until 2 from 0, because as soon as this x value becomes 3 and we call break here, the loop is terminated immediately and our program will come out of the loop immediately as soon as this break keyword is called. In the case of this while loop also, as soon as this I value becomes 3, we are calling the break keyword, and as soon as this break keyword is called, our loop is broken and the execution of code will come out of this loop. So until 2 everything was okay, but as soon as the value becomes 3, this break is called and then we come out of the loop. Let me just print a line here in order to separate these 2 loops, so we know that from where one is starting, right? So I'm going to once again run the code, and you can see for loop prints from 0 to 2, and also while loop prints from 0 to 2. If you change the value here, for example here you want to evaluate x is equal to 2 or not, and here you want to evaluate if x is equal to 4 or not, and then you break out of the loop. And once again, when I run the code, you can see the for loop runs only 2 iterations for 0 and 1, and as soon as the value of x becomes 2, we call the break keyword and we come out of this loop. And in the case of while loop, as soon as this value of I becomes 4, we come out of the loop. So the value from 0 to 3 is printed. Now let's see how we can use a continue keyword instead of this break keyword. So instead of this break keyword, I will use a keyword called continue here, and also in the while loop also I'm going to use this keyword called continue, and I'm going to run the program and let's see what happens. So now when you see here, so you can see here for loop starts from printing 0, 1, and as soon as the value of x becomes 2, this condition is met and this continue is called, and as soon as this continue keyword is called, everything whatever code comes after this continue keyword will be skipped and your program execution goes once again to a for loop for the next value. So you can see in case where x is equal to 2 and continue is called, this statement is not executed, because as soon as we execute continue in our loop, then that iteration is skipped and all the code after the continue will not be executed. Okay, so we go to the next iteration. So that's why 2 is not printed, because this was skipped in case of 2, and then directly 3 is printed, and then 4 and 5 is printed. In case of while loop also, as soon as the value of I becomes 4, you can see 4 is not printed here. You can also change this value to 2, and then I'm going to run the program once again, and you can see while loop prints 0, 1, and why it prints 0 and 1. So because as soon as the value of I becomes 2, this continue keyword is called, and after that this iteration is skipped, and also because this iteration is skipped, these two lines of code are not executed, and because this line of code is not executed, that's why the value of I is not incremented and the value of I always remains 2, and that's why this becomes an infinite loop, right? So instead of increment the value of I at the last line, we can increment the value of I just after this condition check whether I is less than 5 or not, and then we run the code. Now you can see it prints 1, 3, 4 and 5. So now what's happening here is initially the value of I is equal to 0 and this condition is evaluated, and then we first increment the value by 1, and that's why it starts with the printing of 1 by using this print function, and as soon as I is equal to 2, this continue is called, and that's why here 2 is not printed, because as soon as the value of I becomes 2, this continue is called, and every code or every statement after the continue will be skipped for that iteration. That's why 2 is not printed here. So in this way you can use break and continue keywords with loop. In this video I'm going to show you what is a function in Python and how to use functions in Python. So first of all, what is a function? So a function is a group of statements within a program that performs a specific task. Now functions can be of two types. One is built-in function and other is user-defined function. Built-in function, we have already seen that print is a built-in function, or for example input is a built-in function, or for example min is a built-in function, and so on. Now usually function does one task at a time. So you can see this print function only prints something, whatever input you give here, it's going to print it. input function takes some input from the user. Min function finds out the minimum out of some values. So a particular function do one task at a time. Now let's see how we can define a function. So to define a function, you use a keyword def, and then you give the name of the function. So name of function, and after the name of the function, you give these parentheses and you provide number of arguments or parameters. So for example, arg1, comma, arg2, comma, arg3, and so on. So you can give any number of arguments to your function. Now after this ending parenthesis, you give this colon, and then under this function signature, you write some statements which you want to execute when this function is called. So for example, if you want to print something, you can print something, or if you want to calculate something, for example, the product of 2 or 3 variables or a sum of 2 or 3 variables, you can do under this function declaration. So let's take an example of function and let's see how we can define a real life function. So I'm going to define a very simple function which is going to add 2 values. So I'm going to name it as a sum, and for example, it takes 2 values. One is, let's say, arg1 and other is arg2, and then after the colon, I want to add these 2 values. So I can just write print here, and then I can write arg1 plus arg2. So this is a very simple function which takes 2 arguments and then add these 2 arguments and print them. So this is how you declare a user defined function. Now after declaring a function, you need to also call this function. So in order to call the function, you just use the name of the function and then you provide the arguments which is required by the function. So our function requires 2 arguments right now, arg1 and arg2. So we are going to provide these 2 values. Let's say I want to provide 15 as the argument 1 and I will provide 60 as the second value. Now let's run the code and let's see what happens. So when we run the code, you can see our function prints 75, which is the sum of these 2 values which we have provided as an argument to this function. Now also, if you remember, this plus operator you can also use to concatenate 2 strings. So I can use this sum function, and this time I'm going to provide, for example, hello as the first parameter and then world as the second parameter, and then I'm going to run the program and it's going to print hello world. In addition, we can provide 2 float numbers here. For example, I will provide 15.647 and the second argument I'm going to provide is 80.258, and this is also allowed. So I'm going to just run this code and it gives us the sum of these 2 values. So this function sum is doing one single task, which is to add 2 values, whether it's a string or it's a number or it's a float value. Now you may also observe that when I provide, for example, as a first argument I will provide a string and as a second argument I will provide a number here. Will this work? Let's see. So it's going to give us an error, and this error says can't convert int object to string implicitly. So this is a problem. So to solve this problem, we can provide here a simple condition, and we are going to check the type of both the arguments. So if type arg1 is not equal to type arg2, this should be arg1, not agr1. So let me just change this here. And if the type of arg1 is not equal to arg2, we are going to just use this keyword, which is return. So this return keyword is used to return something. So you can return, for example, 0 here or any string here. And when you write this return function without any value here, it's going to return nothing. But as soon as this return keyword is called, nothing after that will be executed. So even though you are returning nothing from here, then also this statement will not be executed. So whenever return is executed, after that all the statements which are under the return will not be executed. Also, we can print a message here that please give the args of same type. Okay, and let's run the code now. And you can see now it prints this message which says please give args of same type. So if these arguments are not of same type, whether it's an integer or a string or a float value, if the user provides first argument which is a string type and the second argument which is an integer type, then this condition will be true and this statement will be executed, which is going to print this message, and then return is called, and after this whatever statements are there will not be executed. So now, as I said, you can also return some values from a function, and here when you don't give any values after this return keyword, it's not going to return anything. But let's return the addition of two arguments using a return keyword. So I'm going to use this return keyword here, which is going to return the addition of these two values using this sum function. So now what will happen is, let's run the code once again, and you can see this sum is executed, this sum is executed, this sum is executed, but the result is not printed. So in order to get the result out of this function, when it returns something, we need to save this return value in a variable. So let's save this value into a variable, and then you can use this variable to print the value of the sum. So I can do something like this. Also, you can directly enclose this sum function inside a print function, and then also it's going to print the sum of these two strings. So either you can assign the result of this sum function, which is returning the result, into a variable, or you can use directly this print function to get the result and print it. So I'm going to use print with other two functions also. So first print and the second print here, and let's run the code once again. And now you can see what happens. So first of all, it prints 75, which is the addition of these two numbers, which is returned by this sum function into a variable a, and we are printing the sum using this print function. Here in the next result, it prints hello world, because this sum function now returns the concatenation of these two strings. Similarly, this sum function is going to return the sum of these two float values. And in the last result, because the type of hello is not equal to the type of 15, then this message is printed, because this condition is true in the last case, and then return will be called. And when this return is called, we were printing whatever is returned from the sum function. And you can see at last none is printed, because at last this sum function is returning nothing, because the type of these two arguments is not same. So we were returning without any value, and that's why none is printed here. Now there are few things to note here. Okay, so the first thing is you can define a function using def keyword and then the name of the function, and under these parentheses you provide the argument. So these two are called arguments. So this is an argument 1 and this is an argument 2. Also, you can use alternatively the name parameters for these two arguments. So this is a parameter 1 and this is a parameter 2. Now it's possible to return from a function, like you can return the addition of two values, or it's also possible to return nothing from a function. So when you use return without a value, it's not going to return anything. Now when you use this function somewhere, it's called calling a function. Now at last, let's discuss about some of the benefits of using functions. So the first benefit is function makes your code simpler, because if you don't use function to execute this kind of code, then you need to write this code again and again whenever you want to use this functionality at different places. The second advantage is function makes your code reusable. So the same code is used to add two integer values, to concatenate two string values, to add two float values, and it's also used to give the error if you provide the arguments of different types. So that means you write the code once and use it multiple times, and that results in faster development of the code. So if you use a function, you can develop your code much faster than if you don't use a function. And the last but not the least advantage is when you declare functions, you can test and debug your code in a better way. So this is how you can declare and use functions in Python. In the last video, we have seen how to declare functions and how to use functions in Python. In this video also, we will discuss some more properties which are related to functions in Python. So let's get started. So to start with, I have a function called student which takes two arguments. One is name and other is age. And inside the function, we just simply print the value of name and age using the print function. And when we call this function with the name and age, it's going to print this kind of output. Now Python allows us to set the default value of the arguments. So after this name, you can put equals to symbol and then put the default value, whatever you want to set for the name. For example, if somebody doesn't provide any name, then you can just say unknown name. Similarly, we can set the default age here. Let's say default age is 0. If somebody doesn't provide any age with the student function, then the default value will be 0. Now instead of using this student function like this, let's say I don't provide any argument to this student function, and let's run the code. And you can see if I don't provide any argument to this student function, the default values are taken. So the default values are used when you want to make sure that every argument in your function should have some value. Now let's say I just provide a name here and don't provide the age, and let's run the program. And now you can see the name is overwritten by the argument what we have provided here, right? So default value will be this one if no argument is provided. Similarly, if we give the value of age and now we run the program, the default age is replaced by the age which is provided using the arguments. So this is how you can use default values with the arguments of the function. So let me just remove these default values, and I'm going to give you the next example, which is variable length arguments. So let's say with the name and age, I want to provide the list of scores which this student has scored for different subjects. So as a third argument, I'm going to provide an argument called marks. And somehow I want to provide a list of marks which is scored by this student. And let me print the value of marks using this print function also. Now in Python, you can use asterisk in front of your argument. And this means that you can provide multiple arguments when you use this kind of notation. So let's just provide, for example, we already provided the name and age here, and let's provide different marks scored by this student. So I can provide 95 for first subject, then 70 for second subject, then 80 for next subject, then 50 for next subject. And let's say we don't know how many subjects the student has taken, we just have only the information about these 4 subjects which he has taken. So we can provide 4 values here, and then let's run the code. And now you can see name is Tom, age is 22, and the value of marks is shown as a tuple. Okay, so whenever you provide this asterisk in front of an argument, you can provide the values for that argument using normal arguments as you provide for normal argument. So first 2 variables are associated with name and age, and all the other variables which you provide here will be assigned to this marks variable because it has this asterisk in front of it. So now you can also use a for loop in order to iterate over tuple. So x in marks, for example, and then you can print every value, or you can access every value inside this tuple. And let me comment this print function, and let's run the code once again. And you can see for loop has printed all these marks which are there inside the list. Now if you want to use this type of variable length argument, then I will suggest you to use this argument as the last argument of your function, so that it will be clearer to the reader of the function that whatever you provide at the end will be the part of this last argument. Now you may ask that we have provided these marks for this student, but for which subject these marks are given to the student. Now in Python, you can also use double asterisk in front of your function argument, and this means that now you can provide the key value pairs as a marks arguments. So instead of using 95, I can also say that 95 is scored in English, let's say, and then 70 is scored in math, and then let's say 80 is scored in physics, and the 50 marks is scored in biology. So now when you use these double asterisks in front of your function argument, you can provide these kind of key value pairs which are separated by this equal to symbol. And how you can access these values, so let's run the code and let's see what happens. And now you can see only keys are printed and not the values of these subjects are printed. So let's first uncomment this print function and let's see what type of value we are getting. So whenever you use these double asterisks, the values are given to you in the form of a dictionary. Okay, so if you use single asterisk, the values are given to you in the form of tuple. But whenever you use these double asterisks and whenever you try to access this variable, then this variable will be of type dictionary. And you already know how to print the values of dictionary. So you can just write marks.items here, and then here you can just write key comma value, and then you can print the value of key and value. So I'm going to just print key first of all, and then I'm going to just give a space here, and then I'm going to print the value, right? And now when we run the code, it will give me first of all the key, for example English, math, physics or biology, and the value which is 95, 70, 80 or 50. Now before starting our object-oriented programming journey in Python, let's discuss about what is the difference between the procedural programming and the object-oriented programming. So you will have the better idea why we use object-oriented programming. Now traditional programming languages such as C or Pascal were called procedural programming languages or structural programming languages, where the basic unit was functions. Now programming in these type of procedural languages involves choosing a data structure and then designing the algorithm and then translating that algorithm into a code. So if this sounds a little bit confusing, let me try to explain it with an example. So let's say you have been given a task to create a program for a passenger who wants to travel from one place to the another place using a cab service. So if we think from the point of view of procedural programming, what we do in the procedural programming is we create some global data structure which holds the data. So here, for example, we create some kind of data structure which can hold the data. For example, in case of a cab service, which cab service is it, or which type of cab is it, and at what location this cab is standing. All these kind of data we store in a data structure in a global environment. Now after storing the data, we design an algorithm. So let's see what kind of algorithm we can develop in the procedural programming language for our cab booking service. So this is a pseudocode which I have written. So first of all, the passenger will open the app from which he can book a cab, and then he will book the cab, and once the cab is booked, he will wait for the cab, and then once cab arrives, he will sit in the cab, and then he will reach to his or her destination, and at the end he will pay the fare of the cab. And this is the pseudocode of that algorithm, and then we will translate this algorithm into actual code in procedural programming language. Now in these type of procedural programming languages, we concentrate on creating the functions, and the major drawback of using these functions is that data and operations on the data are separated. That means we need a methodology to send this data to these functions. So here we need to send this data which we have saved globally into these functions, and these functions take this data either as argument or as a global variable, and then perform some actions on this data and give you some result. Now these kind of functions are passive. What do I mean by passive here? That is, these kind of function cannot hold any information inside them. So once you give the data, they are able to give you the result back after performing some operations, but they cannot save or hold the state or the data, so that if you want to use that data in some other place in your code, then it will be very difficult using these kind of functions which you use in procedural programming. Now let's look at the object-oriented approach of doing things. So in object-oriented programming languages like C++ or Java or Python, the basic unit is class. Now if we take the same example of a passenger who wants to travel from one place to another using a cab service, using object-oriented programming thinking, which depends upon the creation of object, we can create different kind of objects. For example, for a cab, we can create a class called cab, and then we can create a class for cab driver, and the third class we can create for a passenger. Okay, so a class you can create for any real life object. It can be a car, it can be a motorbike, it can be a book or employee or a person. So object-oriented programming allows us to create object. So first of all, what is a class? So a class refers to a blueprint in which we can have data and methods. Okay, so for example, for our cab class, what attributes this cab class can have? For example, a cab service, which cab service we want to take. What is the make of the cab? Is it a Toyota or a BMW or a Volkswagen cab? At which location this cab is right now? What is the number plate of that cab, so the passenger can recognize this cab? So all these things which I have written here are called data because they can hold some kind of data. Number plate has number plate data, location have geolocation data, make have the make data, cab service can have data like Uber or any other cab service. And the other thing which a class can have are called method. So earlier we have seen that we can create functions, and when these functions you use inside a class, they are called method. Okay, so functions inside a class are called method. Now the data inside this object or class is called attributes or the member variables which can hold some data. And using this class we can create object of the cab class, which means we can create different object using a same class. And how to create object using classes we will see in the next video in the real life example. So don't worry if you don't understand how these things works. I will give you a real life example so you will be able to understand in a better way. Now what is an object? An object is a software unit that combines data and methods. Okay, so we have this data here and then we have the methods inside the class, and object is able to combine both of them, which is data with the methods. Now these objects, for example a cab object and the passenger object, can exchange the data between them also. So data is interchangeable between, for example, the passenger object and a cab object. So let's rewind once again what we have learned about object-oriented programming. So the basic unit in object-oriented programming is a class, and a class refers to a blueprint which can have the data and methods. Now using a class we can create objects. And what is an object? Object is an instance of a class, and each object can have its own data and method, and an object is able to store the state of some kind. So at which location this cab is right now. So this is a state, and an object is able to store that state. Now in procedural programming, if you remember, there is no relation between the data and the method, right? We need to provide the data to the method, which are separate entities in the procedural programming language. Now these data members are called attributes or member variables, and these functions which you define inside a class are called methods. And what are some of the key differences between procedural programming language and object-oriented programming language? The first is the unit in procedural programming language is function, and on the other hand in object-oriented programming the unit is class. The second is the procedural programming concentrate on creating functions, while object-oriented programming starts from isolating classes and then they can have data and methods inside it. In procedural programming language, the data and the functions are separate, and in object-oriented programming language, data and methods are not separate. They are the part of a single object of a class. Now if all this seems to be little confusing to you, don't worry, you are not alone, and I will try to solve this confusion in the next video, in which I will tell you how to create the classes and how to use classes in Python. In this video, I'm going to show you how you can create your first class in Python. Now, if you haven't seen my last video in which I have discussed what is object-oriented programming and what are classes, I will highly recommend you to watch that video because this will be a continuation of that video. So let's create a class in Python. So for that, I will create a new project. So let's create a new project in PyCharm. So just click on File here and then click on New Project. And then the project name I'm going to give here is Oops. And then I will just click on Create, and I will choose this option which says open in current window, and also this option which is add to currently opened project, which is going to create this project in this window itself which is already open. So now you can see we have a empty project here, and inside this project let's create a Python file. So right click on the project and then new, and then we are going to create a new file, and let's create a class called car. So I'm going to name the file name as car because we are going to create the car class. Now in order to create a class in Python, you use a keyword class and then you give the name to your class. So the class name in our case is car, and then you give this colon, and for example I write here a keyword called pass. Now when you write this keyword after the declaration of a class, this means that it is an empty class. You can also use this pass keyword to create an empty method. So this keyword pass is used to create an empty class or an empty method. Now here, after the class declaration, let's see how we can create an instance of a class. So it's really easy to create an instance of a class. So let's create a first object, and I'm going to name it as Ford, which is a car brand. And then you use your car class name and use these parentheses here. Okay, so this here Ford is an object, or you can also say it's an instance of the class car. In a similar way, we can create multiple objects. For example, Honda is another car brand, and you can create the Honda object using this class car. Once again, you can create a new object, for example Audi, and then you can once again use this car class to create this object. So what we have done till now, we have created 3 objects from the class car. Now in the previous video I told you that you can associate some data with your object. So let's associate some data. So for example Ford, we can associate an attribute called speed, right? So we can assign the speed, for example 200 here. For Honda, we can assign speed, let's say 220, and for Audi we can assign the speed, let's say 250. So speed here is called the attribute, and whenever you create an empty class using this pass keyword, you can add these attributes on the fly. So you can see we have added these attributes after the declaration of the class and after the creation of the objects. Let's add some more attribute to these instances or the objects. So a car can have the color. So I'm going to just write color, and the Ford has, let's say, the red color, and let me just copy and paste here, and let's say the Honda have the blue color, and we have the Audi of black color. So once again, color is an attribute here. Now if you want to print these attributes, you can use this print method, and then for example we want to print the speed of Ford and the color of Ford, then we can do it like this, and let's run the code. So in order to run this code, first of all, when you create a new project and a new Python file, you need to right click on this file and then click on run the file name, whatever is your file name. My file name was car. So you can see now the result is printed here. First is the speed, and second is the color of an instance Ford. Similarly, you can print the color and speed of Honda and Audi objects also. Now if you want to change some attribute, it's also possible. So let's say I want to change the speed of Ford object. So I'm going to use Ford dot speed once again, and this time I want to assign 300 speed to this attribute. Let's say we also want to change the color of the Ford object. So I'm going to just use Ford.color, and this time I want to use the color blue here. And let's once again we will try to print the color and speed of the object Ford, and now you can see this result. So before, the speed was 200 and the new speed is 300 for the object Ford, and before the color was red and the new color is blue for this object Ford. Now if you have followed the last video, this speed and color is the data. So speed and color are the variables which holds some data inside them. But still we haven't added any behavior or methods to our class car, and that we will do in the next video. Now let's create a new class, because understanding classes in any language is difficult. So let me give you another example. So this time I'm going to create a new Python class, and I'm going to name this Python class as a rectangle, and then press OK, which is going to create this class. And to create a class, you already know, you use the keyword and the name of the class and then the colon, and we will also make this class an empty class using this pass keyword. And in order to create an instance, I'm going to just write rect1, which is the first object, using the rectangle class, and then I'm going to create rect2, which is the second object, using this rectangle class. And now what are the attributes which we can relate to the rectangle? A rectangle have a width and the height. So let's add the width and height. So let me use the first object, and let's say height is 20 for the rectangle 1, and then we are going to use the second object, and once again we are going to add the height for the second rectangle. Let's say the height of second rectangle is 30. Similarly, we can add the width to the rectangle. So width is equal to, let's say it's 40, and rect2 object have the width, let's say 10. So what we have done here, we have created a rectangle class, and then we have created two instances of the rectangle class, rect1 and rect2, which are also called objects. And then we have added some attributes to our objects, which are height and width. Now let's say you want to calculate the area of these two rectangles. I can use the print method, and then what is the area of the rectangle? It's the multiplication of the height and the width, right? So I can use this rectangle 1 object, and then I can call the height and width of this object, and this will give me the area of the rectangle 1 using this multiplication operator. Similarly, I will do the same for the object 2 here, and let's run the code. And if you remember what we need to do, if we create a new Python file, we need to right click on the file and then click on run, right? So once the file is running, you can choose from here which file you want to run, but at least once you need to right click on the file and just click on run whatever file name you have. So you can see the area of rectangle 1 is 800 and the area of rectangle 2 is 300. So this is how you can create a very simple class in Python. In this video, I'm going to show you how to use init method in Python and how to use a keyword called self in Python. So I will continue with the class which I have created in the last video, and this was the class which we have created, and we have used this special keyword pass there, and pass we were using to create an empty class. Now I'm going to remove this pass and I'm going to add a method called init here. So I'm going to just write def and then underscore underscore init and then press enter. and you can see this init method is created here. So this is like a normal method with double underscore in front and back of this init keyword. And you will also see the self keyword is already added as the first argument of this method. Now this init method serves as a constructor for the class. So usually it is used to initialize some attributes or some functions, because this is the first method which will be called when you create an instance of a class. So here we are creating an instance of a class, and this init method will be the first method which will be called when this object or instance will be created. So let's check what I'm saying. So let's say I want to print inside this init method that the underscore underscore init underscore underscore is called. And let me run this code. So I will change this to car and then run this code. And now when I see this result, you will see this line is called 3 times because we have created 3 instances from the same class. Okay, so every time this instance is created, this print is called, and that's why this line is printed 3 times, and everything else will be printed after that. Whatever we were printing, for example, speed or color of the car, will be printed after that. Now, one important thing to notice here is I said init serves as a constructor. It's not a constructor. Although it would be tempting to call this init method as a constructor, actually it's not a constructor, but it behaves like a constructor because init is the closest thing we are going to get in Python to a constructor, because it is the first method which is called whenever an instance is created. Now, if you are familiar with other object-oriented programming languages like Java and C++, there is a destructor also in those kind of languages with classes. Now, Python doesn't have any destructor because Python has an automatic garbage collection. So you don't need a destructor in Python because Python will take care of anything which should be taken care of. Now, as I said, usually init method is used to initialize something. So instead of initializing the value of speed and initializing the value of color, let me just comment this code first of all. So I'm going to select whatever I want to comment, and then I can press Control / to comment all the line. You can also go to code and then use this option which says comment with line comment, and you can see the shortcut for that, Control +/. Okay, so this is going to comment your lines of code. And now I want to use the speed as the initialization value. So after this self keyword, I can give the next parameter, which is speed here, and then the third parameter is the color here. And now to print the value of speed and color, I can use once again print, and then first of all I'm going to print the speed, and then I'm going to print the color attribute. And as soon as you do this, and when you try to run this program, it will give you an error. So let me run the program and it will give me the error. It says init missing 2 required positional argument, which is speed and color. Okay, so once you create an init method and provide any arguments other than self is automatically provided by Python whenever you create an instance of a class. But other than self, when you write for example speed and color arguments here, you need to provide those arguments at the initialization of your class. So here first we will give the speed inside these parentheses, for example 200, and then the color, for example red here. Okay, same we need to do for the other 2 instantiation of the car class. So let me do it for the second instance and also for the third instance. And now let's run the code once again and let's see what happens. So now you can see everything works fine and no error is given to us. And you will also see, because this print is called first, you can see the speed is printed first and then the color, and then this line is printed after that. And that means we will get the speed, color and this line 3 times for every instance with different values, whatever values you have provided for the instantiation of your car class. Now usually you provide these arguments because you want to initialize the value of speed. So let's try to access the value of the Ford object speed and color. So let me just uncomment this code and let's run this code, and it will give us an error. You can see this says that car object has no attribute called speed, right? So what is the error? Because we have provided these attributes speed and color, but we haven't assigned these values to any attribute inside this car class. Earlier what we have done is we have assigned the speed value to a speed attribute and the color value to the color attribute, but we have already commented those codes. So how can we assign the speed and color to the car object? So it turns out that you can use the self keyword, and then using the self keyword you can assign the value to the current object. So self is essentially the current object. Okay, it's similar to using this in C++ or Java if you are familiar with those two languages. So you use self dot and then the name of the attribute, for example speed in our case, is equal to whatever argument you provide for speed. So we have provided the same argument, which is speed itself. Once again I can use self to set the value of color here. So self dot color is equal to color. Let me remove this semicolon because it's not required. And now when I run this code, you will see that there is no error now. So because we have now used the self keyword to set the attributes of speed and color, so we can easily access the values of the speed and color using any object of the car class. So let me once again minimize this. So now let's talk about the self keyword here. So whenever you create a class. Hey guys, in this video I'm going to show you how you can download and install OpenCV for Python on your Ubuntu operating system. So I'm using Ubuntu 18.04 LTS version for this presentation. So first of all, you just need to open your terminal. You can open your terminal by just pressing Ctrl Alt T, which is going to open the terminal. And then first of all, you just need to type sudo apt update and then press enter and then give your Ubuntu's password. I'm going to provide my Ubuntu's login password and then press enter, and it's going to do the updates, plus it's going to refresh the packages index. So once the update command is successful, I'm going to clear the terminal first of all, and then let's give the second command, which is to actually install OpenCV. So the default version of Python on Ubuntu 18.04 is Python 3. So let's check first of all which version of Python is available on my Ubuntu operating system. So I'm going to give this command python -- version and then press enter, and you will see it's going to give this message which says command python not found but can be installed with these commands. Now let's check the version of Python 3. So just give this command, which is python 3 -- version, and you will see Python 3.6.5 is available at the time of making this video on my Ubuntu operating system. So that's why we are going to install OpenCV for Python 3 on our Ubuntu operating system. So I'm going to once again clear the terminal and then give this command sudo apt install python 3 hyphen OpenCV. Okay, so just give this command sudo apt install python 3 hyphen OpenCV and then press enter, which is going to start installing this package. And in between you will be asked if you want to proceed, just press Y and then press enter. So now after this installation is finished, it's time to check whether OpenCV is working fine with our Python script. So what I'm going to do is I'm going to once again clear the terminal, and then I'm going to open the Python shell by giving this command python 3, and now we are going to import the CV2 library, which will be available after the installation of python 3 OpenCV. So I'm going to just write import CV2 and then press enter, and if this import doesn't give any error, that means OpenCV is installed successfully on your Ubuntu operating system. And now we are going to try to check the version of CV2 package which is installed on our operating system. So just give this command cv2 dot version, and it's going to display the version of CV2 which is installed on your Ubuntu operating system, which is at this time 3.2.0. Now if you go to the OpenCV website, which is opencv.org, on its home page you can see at the time of making this video OpenCV 4.0 version is available, but we can see here that version of OpenCV we have installed is 3.2.0. So if you want to install the latest version of OpenCV for Python, which is version 4.0.0 at the time of making this video, then you can follow these commands which I'm going to show. So I'm going to close this terminal, and then I'm going to open the terminal once again. And first of all, in order to install the latest version of OpenCV, we need to install Python pip, which is a package manager for Python packages. So in order to install pip for your Python 3 version, you just need to give these commands. So first command you need to give is sudo apt update and then press enter, and then provide your Ubuntu's password. So once the update command is finished, I'm going to clear the terminal and then give this command, which is sudo apt install python 3 hyphen pip, and then it's going to ask you if you want to continue. I'm going to press Y and then press enter. So now the installation of pip for our Python version 3 is completed. So I'm going to clear the terminal once again, and now we are going to check the version of pip which we have installed. So just give this command pip 3 hyphen version and then press enter, and it's going to give you the version of pip which is available for your Ubuntu operating system. So once the installation of pip is finished successfully, we are going to install a package called OpenCV-Python using this pip3 command. So just give this command pip3 install OpenCV-Python and then press enter, which is going to start the installation of this package, which is OpenCV-Python. So once the installation of this package OpenCV-Python is completed, we are going to just check whether we can import the CV2 version which is available after the installation of this package using pip. So I'm going to clear the terminal once again, and let's give the python 3 command to open the Python shell, and then I'm going to import the CV2 package and then press enter, and if it doesn't give any error, that means CV2 is available for your operating system. And to know the version of OpenCV available for your CV2 package, you can once again give this command, which is cv2 dot underscore version underscore and then press enter, and you can see this time that 4.0.0 OpenCV version is available for your Ubuntu operating system. So this is how you can install pip on your Ubuntu operating system, and this is how you can install OpenCV for Python on your Ubuntu operating system. I hope you've enjoyed this video, and I will see you in the next video. Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video, we will see how to read, display and save videos using cameras. So often we have to capture live stream from camera. So first of all, we will see how we can capture the live stream from the camera. The same method you can use to display the video from a video file. So let's get started and let's see how we can capture the live stream from your default camera. So I'm going to just create a variable called cap, and then inside your CV2 package there is a class called video capture. We are going to take this class and create an object of it, and as an argument here you can provide either the input file name. So for example, if you want to just read the video from a particular file, you can give the file name, for example my file.avi or mp4, or you need to provide the device index of your camera from which you want to read. So by default this index will be either 0 or in many devices it's also -1. So first of all we are going to try with 0 device index, which in most cases works. So if this device index 0 doesn't work, try with -1. Now if you have multiple cameras and if you want to use the other camera, then you can also try 1 for the second camera or 2 for the third camera and so on. So we are going to use the default camera, which is at device index 0. So this is the argument we need to provide here, and then we are going to create a while loop in order to capture the frame continuously. So let's create a while loop here, and this loop we are going to run indefinitely. So we are going to just say that while this loop is true, we want to capture the frames. So we are going to just define these variable ret and frame, and then using this cap instance we are going to call a method called read. Now this read method is going to return true if the frame is available, and this frame will be saved into this frame variable. So here the true or false will be saved. If the frame is available, this ret will be true, otherwise it will be false, and this frame variable will actually capture or save the frame. Now in order to show this captured frame, we can use ImShow. So I'm going to just use a cv2 dot ImShow, which is going to show this frame inside the window. First of all, you can give the name to your window, for example frame, and then second argument will be the frame which you are reading, which is this variable here. Now in the next step, we have seen in the last video also, we are going to use the cv2.wait key in order to wait for the user input, and if this input will be Q, we will quit the window and destroy all windows. So we are going to just say cv2.wait key, and the argument here will be 1. And I have told you you need to provide this mask for 64-bit machines, so you can provide this mask, and then we are going to just see if this key which is pressed is Q or not. So we are going to use the ORD method for this, and we will just check if the Q key is pressed, and if this Q key is pressed, we are going to break from the loop and we will come out of the loop. And after we come out of the loop, the first thing we need to do is to actually release the capture variable. So this is important. After reading your video, you need to release the resources. So you need to just call this method cap.release, and then we will just destroy all windows. So let's run this script and let's see what is the output. So I'm going to run this script, and you can see in this window the input from my default webcam of my laptop. Right now I'm just showing some book in front of this camera. That's why you will see this book, and as soon as I press Q key, our window will be destroyed and we come out of this script. Now let's say you want to change the frames to gray. So we want to convert our video input from the colored image to the grayscale image. For that, what you can do is you can define a variable called gray or anything else, and then there is a method called cv2.cvt color, which is to convert color, and the first argument which it takes is the source. So in our case, the source is the frame which we are capturing from the cap.read method. The second argument is actually the conversion what we want to do. So we will just call cv2.color underscore, and by default the default colored image is captured as BGR image, that means blue, green, red channel images, and we want to convert it to a grayscale image. So we will just write BGR to gray. This means we want to capture the BGR image to the grayscale image, and now this is going to give us the grayscale image, and this input we can just transfer to the IamShow method as the second argument of this IamShow method. So let's run this script once again and let's see what is the output of the script. And now you can see the video captured is in grayscale image, and as soon as I press Q, it's going to release all the captured resources and then destroy all windows. Now, as I said, if you want to display the image from a video file, you just need to give the name of the video file, for example name, and then the extension, which is, let's say, AVI or MP4 or any other format. Now using this cap instance, you can read few properties about the video which is captured, and the first property is if the video is open or not. So in case whenever you provide the file name and the file path is wrong, then this is going to give you false. So there is a method called isOpened, and this means if the file name of the video which you want to provide here is correct, this is going to give us true. Otherwise, this isOpened is going to give us false in case the file path is wrong or the index which you give here for the device is wrong. So let's give any random index here, and then let's see what happens. So I'm going to run this script, and you will see nothing will happen because this isOpened is going to give you false. Let's print that also, and let's verify with the print statement the same thing. So I'm going to just use this and then run the program once again, and you can see it prints false. That means you cannot capture the video using this index. So my device is at index 0 by default, so I need to give this index name. Otherwise, for example, I provide the wrong file name here also, it's going to give us the false value. There is a method called cap.open also. So if this cap is open gives you false, you can try opening your capture video using cap.open also. Now there are other properties which you can read using this cap instance, and the property you can read using a method called get. So you can just write cap.get, and as an argument of this get method you can provide the prop ID. So there are different prop IDs which you can read. So let's say we want to read the property which is called frame width and frame height, which is going to give you the height and width of your frame. So for this you just need to write cv2.cap underscore prop underscore frame underscore width. This is going to give you the width of your frame, and if you want to get the height of your frame, you can use cap underscore prop underscore frame underscore height. And this whole list you can find on the official documentation of OpenCV. So I will provide you this link where you can see different values of the prop ID. So right now I have used this ID and this ID, but there are several number of IDs available here which you can use to read the property of your frame. So let's use print method to just print out what property we are reading. And let's once again run this script. And here you can see in the output, you can see the value 640 and 480, which is the width and height of your frame by default. Now let's see how we can save the image which we have captured from our webcam or the default camera. So as we already know that we read frame by frame when we capture the videos from your default camera. So for creating the capture, you have used video capture class, and for saving the video, we are going to create the video writer class. So I'm going to first of all create a variable called out for output, and then I'm going to call a class called video writer. So let's call this class, which is video writer. And now this class takes few arguments. The first argument is the name of your output file. So for example, I can just give the name output.avi, the extension of the file. The second argument here is the 4cc code. Now 4cc is a 4-byte code which is used to specify the video codec. And if you want to know more about 4cc code, you can visit this website, which is 4cc.org/codec.php, and here you can find several 4cc codes. So for now, what we are going to do is we are going to just get the 4cc code using a class called video writer underscore 4cc. So I'm going to declare a variable 4cc, and then I'm going to use cv2 to call a class called video writer 4cc. So as an argument of this class, you just need to provide the 4cc code. So for example, I can give this kind of code. So you can provide this argument, which is asterisk, and then your 4cc code, which is xvid in this case. Or otherwise, what you can do here is you can also give this code in this format. So for example, x comma, then second argument is v, and then third argument is I, and the fourth argument is d. So you can either give this type of notation, or you can just use asterisk, and then in single quotes you can just write xvid or any other code here. And then this 4cc code we are going to pass as the second argument. The third argument is the number of frames per second. So let's say we just want to use 20 frames per second, and the fourth argument is the size. So we already know that the size in which we are capturing is 640 by 480. So we are going to provide this in the form of tuple. So 640 comma 480. So this will be the size of the video which will be saved in this file. Now inside our loop, as we have seen, we are just reading the frame here in the frame variable, and this is the boolean variable. If the frame is available, it's true, otherwise it's false, right? So first of all, we are going to check if its value is true or false. So we can just write if ret is equal to true, then only we are going to just save this file into the output file. So I'm going to just put everything inside this if condition. Otherwise, we are going to break out of this loop. So I'm going to just say else break. Now inside this if condition, we can just write this frame into a file using a method called out.write. So out is the instance of video writer. So I'm going to just use out.write, and then we are going to just pass the frame which we have captured, which is inside the frame variable. And now at last we are going to release all the resources using the out instance, which is the instance of video writer. So I'm going to just write out dot release, and then let's run the script and let's see what happens. So one thing to note here is our video will be saved as it is, that is in the BGR mode, that is in the colored mode. So let's run the code and let's see what happens. So I'm going to just start my script once again, and now I'm going to just press Q. So you can see here our video is shown in the grayscale, and our video will be saved in the original format because we are saving every frame before the conversion. So it will be saved in the original format. So I'm going to just close this script, and as soon as I close the script, you can see the output.avi file. And in order to verify this file, I'm going to go to the project, and here I'm going to start this file using, let's say, VLC media player, and you can see it shows the output of the output.avi file. So this is how you can read videos, display and save videos using the default camera or the video file. I hope you have enjoyed this video, and I will see you in the next video. Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video, we will learn how to draw different geometric shapes using OpenCV. So to start with, I have this code, and I have already explained what this code does. So this IamRead is used to read an image, and then we are just showing this image into a window using this IamShow method. And then using the wait key, we will wait for the closing event, and the destroy all window will destroy all the windows which we have created. So this we have already seen. Now let's say we want to draw some geometric shapes on this image. So to start with, let's learn how to draw a line on our image which we have read from this read function. So what we are going to do is we will overwrite this image. So we have already created this image variable. So what we are going to do is we will draw a line on the same image. So I'm going to just write img is equal to cv2.lines, and you can see in the suggestion this line method takes few arguments. So the first argument is the image itself. The second argument is the starting coordinates of point 1. The third argument is the ending coordinates of point 2. And then the fourth argument is the color, and fifth argument is the thickness. So let's use this line method and then give these arguments one by one. So we want to write to the image which we have read using this file. So the first argument is the image variable, and the second argument is the coordinates. So the coordinates should be given in the form of tuple. So let's say we start with 0, 0 coordinate, and the ending coordinates will be, let's say, 255, 255. Okay. The fourth argument will be the color, and the color you need to give in the BGR format. So if you want to give the blue color, then you can just write 255, 0, 0, because first is the blue color, second is the green color, and third is the red channel color. So if you specify here 255 in the first channel, that means the blue channel, then it's going to draw the blue line. If you give here 255 and then you make other channels 0, then it's going to draw the green line. And if this 255 comes at last and the other channels are 0, then it's going to draw the red line. So let's say we want to draw the red line, that's why I have given 255 here. And the next argument is the thickness. So the thickness you provide in the numbers. So starting from 1 is the lowest thickness. You can increase the thickness 2 or 3 or let's say 5 or 10. So it's going to increase the thickness based upon this number. So let's say we want to give the thickness to our line 5. So this is going to draw a red line on our image. So let's run the code and let's see what happens. So you can see our image is loaded in the grayscale. That's why you don't see any color on the line, but our line is created here. So let's load this image in the colored format by changing this argument to 1, and let's run the code once again, and you will see the image is loaded in the colored format and the line color is red. Now if you want to change the thickness of this line, you can just increase this number, and if you want to change the color of this line, you can change it using these color channels. So let's change the line color to green, let's say, and I'm going to run the code, and you can see the thickness of the line is increased and now the color of the line is green. Now if you want to draw the line with any other color, you can just go to your favorite browser and search for RGB color picker, but always remember our image will be loaded in the BGR format, so in the reverse order, so blue, green, and then the red channel. So let's say we want this color here, and its RGB channels are this. So I'm going to just copy all these channels, and then I'm going to give these channels in the reverse order. So first of all 147, then 96, and then third channel is the 44, and then I'm going to run my code, and you can see you get the same color which you have chosen here. So this is how you can change the color of your lines. Now there is a function called arrowed line. Let's say we want to use this function which is called arrowed line, and this is going to draw the arrowed line as it says. So let's say we want to just draw this arrowed line in blue color. So I'm going to just give the color channels here and then run the code, and this arrowed line is overlapping on the previous line. That's why you don't see the previous line. So let's change the coordinate of this line. So let's draw this line in this coordinate, which is going to draw the straight line in my opinion. Let's see what happens when I run the code, and you can see it draws the straight line from left to right, which is the arrowed line, and this was our original line. Now let's see how to draw the rectangle. So to draw the rectangle, we will do the same. We will just overwrite on the same image. So we will just say image is equal to cv2 dot rectangle, which is a method, and you can see what are the argument it takes. So the first argument is the image itself. The second argument is the 0.1 and 0.2. This 0.1 and 0.2 coordinate I'm going to explain in a bit. The third argument is the color, which is same as line, and the fourth argument is the thickness. So let's use this rectangle function to draw the rectangle. So first of all, I'm going to just pass the image variable here. The second argument is the top left vertex coordinates. So let me just draw something here so you will be able to understand in a better way. So when you want to draw a rectangle using OpenCV, this here is a top left vertex coordinates, which is x1 and y1, and this is here the lower right vertex coordinates. So the top left vertex coordinates you give in the second argument. So let's give some coordinates here. So 384, 0, and the lower right coordinates I want to give here is, let's say, 510, 128. So let's say we want to give the red color. So I'm going to just write 0, 0, 255, and the thickness I want to give here is 5, and I'm going to just remove this because it will just create problems. And now let's run the code, and you can see the rectangle is drawn with the red color of thickness 5. You can change the thickness of this rectangle by changing the value of the thickness, and then you can run the code, and now the thickness of this rectangle line is increased. Now one more thing you can provide here is, instead of giving the thickness value, if you write here -1, then it's going to fill the rectangle with the color which you provide here. So when we give -1 here, let's see what happens. So now we get the filled rectangle because we have provided -1 option here. So if you provide -1, then your rectangle or whatever shape you are creating will be filled with the color which you specify here. So let me just change the thickness to 10 once again, and now let's see how we can draw the circle. So to draw the circle, we once again use cv2 dot circle function, and once again you can see what are the argument which it takes. So the first argument is the image, the second argument is the center of the circle, the third argument is the radius of the circle, and the fourth and fifth argument is the color and the thickness once again. So once again we will provide the image, the second argument is the center of the circle. So let's give the center of the circle, which is the coordinate on which you want to give the center. So I'm going to provide, let's say, 447, 63 here, and the third argument is the radius. So radius we want to provide here is, let's say, 63, and the fourth argument is the color. So let's use 0, 255, 0, which is going to draw the green color, and then let's give -1 here. So our circle will be filled with green color, and let's run the code and let's see what happens. So you can see this circle is drawn here, and this circle is filled with the green color. Now let's see how we can put some text into the image. So to put the text on our image, we will once again use the image variable and overwrite on it, and then we will use a method called putText. So this is the method which we are going to use. The first argument is the image, the second argument here is the text which we want to put. So let's say we want to just print OpenCV on our image, so we can just write OpenCV as the second argument. The third argument is the starting point of your text. So you need to give the coordinates where you want to start your text from. So the coordinates I want to give here is, let's say, 10, 500, and then the next argument is the font face. So the font face you need to give here using a variable. So I'm going to create a variable, let's say font, and then there are many font faces available using cv2. So you can just write cv2 dot font in capital, and you can see what are the options available here. I'm going to choose the first one itself, which is font Hershey simplex font, and then we are going to pass this font as the fourth argument. The fifth argument here will be the font size. So let's say I want to give the font size 4 here. The sixth argument here is the color of your font. So let's say I want to just draw 255, 255, 255, which is going to give us a whitish kind of color. The next argument we will give here is the thickness. So let's say I want to provide the thickness 10 here. And the next argument you can give here is the line type. So let's say I want to give the line type CV2 dot capital line underscore AA. And now let's run our script and let's see what happens. So you can see here OpenCV is printed in the white color of thickness 10. And if you want to change this color, you can change it from here. So I'm going to just put the first channel as 0, and now this color is changed to yellow color. Now one more thing I want to show here is how you can create an image using numpy zeros method. So either you can use an image which you read from imRead method, or what you can do here is I'm going to just comment this code and we can create an image using the numpy zeros method. So I'm going to create this img variable, and then I'm going to use the numpy module. So just import this numpy as np, and then we are going to use this mp to call the zeros method. Now in order to create a black image using this zeros method, you need to give the first argument in the form of list, and inside this list the first element will be the height, second will be the width, and third will be 3. So let's say we want to provide the height 512, we want to provide the width also 512, and the third argument will be 3. And the next argument you give here is the d type or data type. So you can just write np dot u int 8 here. So this method is going to give you a black image of the size 512 by 512. So let's run our code and let's see what happens. So you can see now you can see the black image, and on our black image the line is drawn, the arrowed line is drawn, and the text and the circle and the rectangle are drawn here. So this is how you can draw different geometric shapes on your image. There are several other methods you can use, for example cv2 dot polyline method or cv2 dot eclipse method to draw eclipse and polygon on your image. So just try those method to draw different shapes on your image. So that's it for this video, and I will see you in the next video. Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. So in this video we will see how to set some properties to our captured images. So in the video capture lesson we have seen that when we create a cap variable using the video capture class, we can get many properties using the cap.get method. So we were able to get the width of the frame and the height of the frame. Similarly, we can use the cap.set function to set some values. So you can just write cap.set, and then you can set the values of the property. Generally, all the properties which you can read like this, you can also able to set those property using the set method. Now this notation you can also give in the form of numbers. So every property here has a defined number. So for example, instead of using cv2.capProp_frame_width, you can just write 3 here, and that will work also. So every property has a number associated with it. So using that number, either you can just, let's say we want to set the width and height, either you can write this as the first argument and the second argument is the actual width you want in the video, right? Or you can just give the number of that property and then give its value. So let's say we want to change the width of this video to, let's say 1208, and then let's just set the height. So cap dot set, and the associated number for the height parameter will be 4. So 3 for width and 4 for the height, and let's say we want to just move it to 720, and then we will once again print the value of the width and height, and this time we are going to just give their associated numbers, which is 3 and 4. So let's run this program. You might already know this program, what this program is doing. So it's just capturing the video from your default device at index 0, and then it's just showing all the frames using this IMShow method in a window. So now I'm going to run this script and let's see what happens. So when I run this script, you can see the size of this frame is changed. So let's see in the terminal also. You can see before, the original size of the video we are capturing is 640 and 480. So width was 640 and the height is 480. Now once we have changed the width and height, you can see the width is changed to 1280 and the height is changed to 720. So even if I have given here 1208, the default camera will automatically set its value according to its resolution. So let's just close this video, and let's say we want to just change this value to some random number. So let's say 700 by 700. Will it work or not? So let's run the script once again and let's see what happens. So the script is running, and you can see that even though we have provided the 700 and 700, the camera will automatically take the resolution which is available for your default camera. So the resolution remains the same even though we have set the different value to it. So you need to keep in mind, even though you can give any value here, but the camera will only set the resolution which is available for it. So let's give a very big value here. So I'm going to provide, let's say 3000 here, and height also 3000, and let's run the script once again and let's see what happens. So when we run the script, you will see the resolution is changed, but the resolution will change to the maximum resolution of my default camera, which is 1280 and 720. This is the maximum resolution which is available for my webcam. So let me just close this window. So this is how you can set some values. So there are many values you can set using this set method. You just need to go to the documentation and then search for the value you want to set. I hope you have enjoyed this video, and I will see you in the next video. Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. So in the last two videos, we have seen how to capture videos from our default camera device, or how to add geometric shapes on the images. Now in this video, we are going to combine the knowledge we have gained in the last two videos. So if you haven't seen the last two videos, I will recommend you to watch those videos and then come to this video. So in this video, we will see how we can just draw something on a video, and more specifically, the aim of this video is how to show the current date and time on a live video. So now in the last video, we have seen how to draw shapes on images, and we have also seen how to put text on our images, right? So let's say we just want to print the value of width and height on the default camera. And let me just remove this line which we have used to convert the BGR image to the grayscale image. So we will just see the colored BGR image. So now what we want to do is we want to print the width and height which we get from these properties on our video which we are capturing. So in the last video we have already seen that we can use a method which is cv2 dot put text. Yeah, so this method we have seen in the last video, and first of all we will define the font which we will pass to our put text method. So the font I'm using here is cv2.font Hershey underscore simplex, and now the first argument here will be the frame which we are capturing, because every frame is just like an image and a video is the combination of multiple images. So the first argument here will be the frame. The second argument here will be your text. So the text which we want to show here is, let's say, width and height. So let's define a variable which we want to show on our video. So let's say the variable name is text, and first of all I'm going to define the width. So just say width, and then we are going to provide the value of the width using the concatenation operator. Now because this value will be in integer and we want to convert it to the string, so we will use the str method to convert the integer to the string, and then we can pass the width here inside our string variable. Once again we will use the concatenation operator, and then let's provide some space here, and then we will just write height colon, and then once again the concatenation operator, and once again we will use this string method, and inside this string method we will now take the height. Okay, and now we will pass this text to our put text argument. Now the third argument is the coordinate. So let's say I want to just put this text at the coordinate 10, 50. The fourth argument is the font which we have already declared. The fifth argument is the thickness. So let's say the thickness we want is 1, and then the color. So let's say the color we want is 0, 255, 255, and then the thickness. So I think the thickness comes after the color, and the value 1 we have set for the font scale. So you can change the font scale 1, 2, 3, 4, any font you can change it from here. So this value 1 is for the font scale, and the value we are providing right now is for the thickness. So let's say the thickness is 2, and the last argument here will be the line type. So I'm going to just provide the line type as cv2 dot line underscore AA. So what do you think, will this text will be printed on our image or not? So it will not print yet because we need to write on the frame this text. So we need to just write frame is equal to, and then put the text on the same frame which we are seeing right now. So now this will work, and let me just break this line so you will see all the code. And now let's run the code and let's see what happens when we run the code. So let me run this script, and you will see here that now we are seeing the width and height on top of this video, which is 1280, and the height is 720.0. So this is how you can show text on your video which you are capturing from the web camera or from the video file. Now let me just comment these lines of code because they are changing the resolution of our video, and it's not fitting this video screencast. So I have commented this code, and now let's do something more interesting. So now let's say we want to show the current date and time on the video, and you might have guessed how to print it, but let me show you if you don't know how to print the date and time on your live video. So first of all, we are going to import the package which is available inside Python, which is datetime. And then we are going to create this datetime variable. Let's say the datetime variable name will be date t. And then first of all, we are going to use the str method to convert the date and time to string. And then there is a method inside this datetime library. So we just need to write datetime dot datetime once again, and then the method called now, which is going to show you the current date and time. So once we have converted our current date and time to the string variable, then we can pass this variable as the second argument. And now let's run this script and let's see what happens once again. So I am running this script, and now you will see that it shows the current time and current date on the video itself. So this is how you can put the text on your video. You can even put some shapes which we have seen in the last video on this video itself. So you can put the line or the rectangle or the circle on your video which you are capturing from the camera or some file. So this was some kind of a mini project which we have created from the knowledge which we have gained from the last two videos. I hope you have enjoyed this video, and I will see you in the next video. Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video, we will learn how to handle mouse event in OpenCV. Now, mouse event can be anything. For example, a right click event, or left mouse button click event, or a left button double click event. So there are many mouse event available in CV2 package. Now, to list out all the events in the CV2 package, you can write this kind of code. So first of all, I'm going to create a variable called events, and then I'm going to just iterate over all the events inside CV2 library. So I'm going to just write I for I in dir inside our CV2 package. So this dir method is the inbuilt method which is going to show all the classes and member functions inside your CV2 package. Okay, so we are iterating over all the function names or member variable names, and then we want to see what are the events available inside this package. So we can just filter those events using a condition. So we are going to just say that we want to just see the variables or the member properties which have this keyword event in them. So event in I, and then we are going to just print out all the events. So I'm going to just print out all the events, and then I'm going to run this code, and here you can see the list of all the events which are available inside your CV2 library. So you can see there is an event called event flag R button for the right button for the mouse, or there is event for left button double click event, or the event for L button down event. So there are many such events available here, and we are going to use those events to listen for the mouse events. So this is how you can print all the events which are available inside your CV2 library. And now we will create a script or a program to listen for the mouse event. So first of all, we will create a mouse callback function which is executed when mouse event takes place. So in order to create this callback function, we are going to just define a function, and then we will give the name to our function. For example, click event function, and this callback function generally takes few arguments. So the first argument will be the event which is taking place when we click our mouse, and then it's going to give us the x and y coordinate on the image where we are clicking with our mouse. So we are going to get the x-axis value and the y-axis value whenever we click the mouse at certain position in our image. Also, we will get the flags and we will get the param. So for creating the mouse click callback function, it has this kind of specific format which is same everywhere. So these are the parameter it takes, and then inside your callback function you can define the logic. So let's say whenever I click the left button down, then I want to show the x and y coordinates on the same image. So I can just say if the event variable is equal to cv2 dot event, and then I will just look for the left button down click event. So if this event occurs, then I will first of all print the x and y axis values. So let's print x comma y, and you can also provide some space between x and y coordinates using this kind of string. And then what we are going to do is we are going to just put this x and y coordinate values on the same image which we are opening. So we have already seen in the last videos how to put text on the videos. We just need to create this font variable for the font, and then there is a method called cv2.putText. So we are going to just write cv2.putText, which takes few arguments. First is the image. Now you can see this image shows error, and this error says unresolved reference, but don't worry, when we write our code fully, this error will go. So first will be the image, the second is the string which we want to put. So let's say we want to put the string str for the x and y value. So I'm going to just write x, y, and then we are going to just print the x value, then concatenation operator, and then comma, and then once again concatenation operator y. And don't forget to convert these coordinate values into the string using the str function. So str function here, and for the y-axis also you need to use this str to convert it to the string value, and then the string we pass as the second argument. The third argument will be the location where we want to put the text, and this location we already know from this x and y value. So it's easy for us. We are going to just say x comma y because we already know the x and y coordinate using this callback event. The fourth argument will be the font. The fifth argument will be the font scale. Let's say it's 1. And then the next argument is the color. So let's say color we want to give here is 255 comma 255 comma 0. And the last argument I want to give here is the thickness. Let's say thickness we want to give here is 2. And then we will show this text on the image using cv2.IamShow method. So I'm going to just write IamShow and then the name of the image window, for example image, and the image itself, which is img. So right now this is showing error to us, but when we will call this callback function using a standard function called set mouse callback, then this error will go. So I'm going to define the img variable first of all, and let's say we want to create a black image using numpy. So we will call np.zeros method here. So np.zeros, and the size of this image will be 512 comma 512 comma 3, and the data type will be np.uint8. And once we have this image, we are going to show this image using once again the imShow method, and this image name will be the same image, and the variable we want to pass here is the image variable, which is the black image which we have created using this numpy zeros function. Now the next and the important step here is calling a method called set mouse callback method. So this method we are going to use to call our callback function which we have created, which is click event function, whenever somebody clicks on the image which we are showing using this imShow window. So the first parameter it takes is the name of your image. Make sure that this name here which you take in the imShow method, you can see I'm taking the same name here in the imShow method also here. So the window name should be the same everywhere, then only it will work. So here also you need to just give the parameter. First parameter here is the window name. So the window name is image, and the second parameter is the callback function which we want to call whenever this event take place. So this is the callback function which we have created. Now the next step are the obvious steps which we have already seen. So first of all, we will call the wait key method to wait for the escape event, and the second is the destroy all windows. So we will destroy all the windows once we are finished. So let's run this code and let's see what happens. So now you can see the black image which is created by numpy zeros method, and when I click on this image anywhere, you can see the coordinates of the position where I've clicked is printed here. So let's click here. You can see when I give this left down button click event, then the position of the x and y coordinate is printed on this black image. So I'm clicking again and again this left down button, and the position is printed. Okay, so let me just close this window. Now what I want to do is let's just reduce the size of this font to 0.5. Then the font size will be little bit smaller. Now what I want to do is I want to listen for some other events. So I will go to my callback function once again, and I will add one more condition here. So once again, if event is equal to cv2, and this time I want to listen for the right click event. So I'm going to just write event right button down event. Okay, so whenever somebody presses this right button down for the mouse, then this event is going to be captured inside this condition. Now if you remember, I have told you that image is shown in OpenCV in the form of BGR format, and we already have this image. You can see we have declared the image variable. That's why this error is also gone. So using this image, we want to find out the red, blue and green channel. So now inside this condition, what I want to do is I want to print out the BGR channels of the image wherever I click. Okay, so you can first of all declare a blue variable name, and then we have img variable, which is this one. And using this image variable, we can get the blue channel using the coordinates. So first of all, you can provide y comma x. We already have the y and x coordinates, and then the channel for the blue color is channel 0 because it starts from blue bgr, so blue, and then green, and then red. Okay, so I'm going to just copy it 2 more times. The second is green, and the channel for it will be the 1, or index will be 1 here, and for the red channel this index will be 2 here. So I'm going to just write red here, and once again I'm going to just copy this code, and this time what I want to do is, instead of printing the coordinates, I want to print the BGR channel. So here I'm going to just write blue, and then second will be the green channel, and then the third will be the red channel. So I'm going to just write comma and then concatenation operator str and then red channel. Okay, so this will be the string. We are going to name it as BGR, and this string we will put here. The color also we can change, so the color for the coordinates will be different, and the color for this event will be different, 255. Okay, so it's going to print the BGR channels on your image. Now because we are creating the black image, whenever I just click the right click mouse event, you can see the BGR channels for this black image will be always 0 0 0, right? When I click the left click, then these are the coordinates. When I click the right click, these are the BGR channels. So let's change this image from the black image to something visible. So I already have the Lena image, so we can use this Lena image using the cv2.imread method. So I'm going to just write cv2.imread, and the first will be the name of the file, which is lena.jpg. So now let's run this code once again, and now I have this colored image, so we will be able to see these functionality in a better way. So first of all, the left button click event, you see the coordinate, and when I click the right click button event, then you can see the BGR channels are printed. Once again, here you can see the BGR is different. Here also these BGR colors are different. So you can see everywhere they are a little bit different because this is the colored image and the color differs at every pixel level. So this is how the mouse click event works in OpenCV. I hope you enjoyed this video, and I will see you in the next video. Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In the last video, we have seen how to use mouse click event in OpenCV using Python. So we have seen how we can create a callback function which listens to a mouse click event, and then how to use this callback function using the setMouse callback method. Now in this video, I will show you some more examples about mouse click event. So the first example I want to show about drawing a point and then connecting points using the line. So to start with, I'm going to just remove this if condition for the right down button click event, and every time somebody clicks the left button down click event of mouse, then what I want to do is every time the mouse is clicked down, I want to draw a circle, very small circle, and when he clicks on the next point, then I want to join those 2 points using a line. So for that I will need a CV2 circle. So I'm going to remove this code which we don't need right now. We just need this condition which listens for the left button down click event of mouse, and then what we will do is we will just use CV2 to draw a circle. So we will just write dot circle, and first of all this circle method takes the image, so we are going to pass the image, and then the second argument is the coordinates, x and y coordinate. So we already have x and y coordinate using this callback function with the second and third parameters, and then the third parameter will be the radius. So I will take the radius 3, which is like very small, which will give you effect like a point on an image, and then we can give the color. So let's give 0, 0, 255, and then we will give the thickness. Now the thickness I'm going to give here is -1, and you might already know what this -1 do. So this -1, whenever you give as a thickness, it fills your circle or any closed shape. Okay, so your closed circle will be filled with this color which you provide here. Now next what I want to do is I want to create an array of points. So I'm going to just declare a variable called points and initialize it with an empty array. Now this empty array variable we can use inside our callback function, and what we are going to do is we are going to just add or append every time this mouse is clicked. So I'm going to just call an append method here, and then we are going to append the x and y coordinate to this points array. So we know that where this mouse is clicked, and we are saving the coordinates wherever the mouse is clicked in the form of array. Now in the next step what we will do is if the mouse is clicked more than 2 times, so we can just test the length of this array, which is points, and if the length of this array is greater than or equal to 2, because the first click will be only a point, so we cannot connect this point with a line, but when we have 2 or more points, then we can connect those points with a line, right? So if this points array length is greater than 2, then we are going to just create a line between those points or the circles in our case. So I'm going to just call cv2 dot line method, and first argument here will be image. The second argument here will be the point 1, so the coordinate of point 1. Now we want to join the last 2 points, right? So we are going to just use this points array, and then to get the last value of an array we use -1 here. So here as an index we will give -1, which means the last element of an array, and then we will join the second last element of an array. So I'm going to just give this will be points variable, not print. So let's give the points variable, and then we are going to pass the -2 here, which will be the second last element. So last and second last element we want to join, and then the next argument will be the color. So let's say the color we want here is 255, 0, 0, and the next point will be the thickness. So we will give the thickness of 5 here, and then we will show this image using IamShow method. This code I have already shown you in the last video, so I will not explain what this code is doing. If you want to know more about this code, you can see the last video. And this time I will use the NumPy zeros array, which will be a black image. So let's run this script and let's see what happens. So I'm running this script, and now I click on some position on this image, and you can see this red circle is created. This circle is created using cv2.circle method, and because the radius is 3, the circle is very small, and because the thickness is -1, the circle is filled with the color which you provide here. Now we have said that if the point is only 1, then we don't want to create any line. If there are points which are 2 or more, then we want to connect those points with the line. So let's click here, and you can see point 1 and point 2 are connected with a line. I click here, and you can see the last and the second last points are connected with the line. That's why we have taken this -1 and -2 argument, which means the last element of the array and the second last element of the array. So when I click at any point, it will be now connected with this blue line. So this kind of line drawing you can use in satellite images where you want to connect 2 points together with the line. Now let's see the next example which I want to show you. So in the next example, what I want to do is I want to first of all read an image, and then I want to click on any point on the image, and then I want to show the color of the point on which I have clicked using a second window. So for this, instead of using the NumPy array, which is the black image, I will use the normal image, which is the lana.jpg image. And now I will just remove this code from here. So first of all, I want to read the BGR channels. So first of all, I will just declare these variables. First is blue, and we have the image. And in the last video, we have already seen how we can get the BGR channels, because we have the x coordinate and the y coordinate, and we also know that blue is the first channel. So we use the index 0 here to get the blue channel from this image at this coordinate, which is x and y. Same we will do for the green channel. So green, I am G, and then x comma y, and then the channel index will be 1 here, and then we will just get the red channel from this image. And now what we are going to do is we are going to just draw a circle on this point where you will click this mouse down button click event. So I'm going to just write cv2.circle, and now I will not explain the parameters, because you might already know what these parameters are. In the next line, what we are going to do is we are going to create a NumPy zeros image, and then we will pass our BGR channels which we got from the particular point on an image. So let's create an image. So I will just say my color image, and then we are going to just use np for NumPy, and then we will just call a zeros method here, and it takes 3 argument in the form of this list, which is the size of your image. Let's say this size will be 512 comma 512, and the channel will be 3 channels, and then the next argument will be the data type. So np dot uint8. So we have a black image using this numpy zeros, and now we want to fill this image with the BGR colors which we got from the particular point of the image. So in the next line, what we are going to do is we are going to just use this variable, and then we are going to just write this kind of notation. This means we want to fill every channel or every point of this list, and then we will just pass our BGR channel values which we got from the image. So blue, green, and then the red channel values we are going to pass. So this will give us the BGR channel, which will be the color of the point where we have clicked. And now we have the new image with the color, so we can show this image using a new window with let's say this is the color window. Okay, so this is how you will get the new window with the color on which you have clicked. So let's run this code and let's see what happens. So I'm going to run this code, and you can see this is the image, which is the colored image. Let's see, I click on this point, and you can see the same color on which I have clicked is opened in the next window. Let's click here on the hat. You can see it's going to give you the same color on which I have clicked. Let's click on the eyes, and you will get the same color on which I have clicked. Let's see what happens when we just load a black image instead of this colored image. So I'm going to just use this numpy zeros image, which is the black image, and let's run this code. And now whenever I click on this, every time I click on any point, it will be the black color window which will open. So this is how you can use some examples to understand how mouse click events can work, and you can use them to develop your applications. So I hope you have enjoyed this video, and I will see you in the next video. Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video, we will see some of the basic and arithmetic operations on images using OpenCV. So let's get started. So here I have this code. Some of this code you already know. So you already know how to read the images using IamRead method, and then show it inside a window using IamShow method, and destroy all windows using this destroy all windows method. But this code in between is a little bit new. So let me explain line by line what this code does. So when you have this image using IamRead method or any other method, you can use these attributes like shape, size, and dtype to get different values from this image. So image.shape is going to return a tuple which contains the number of rows, columns, and the number of channels in this image. The image.size will return the total number of pixels which are there inside the image. And image.dtype is going to return the data type of the image which you have obtained. Now here, if you want to split your image in 3 channels, then you can use cv2.split method and pass your image as an argument, and it's going to give you the BGR channel of your image. Now if you have BGR channels and you want to merge those BGR channel into an image, then you can use cv2.merge method and pass these BGR channels in the form of tuple, and it's going to give you the image which you can load using IamShow method. So let's run this code and let's see what we are getting using these attributes. So you can see this messy5.jpg image is loaded, and here you can see first of all the shape of the image. So the shape returns the number of rows, number of columns, and the number of channels. So number of rows here is 342, columns are 548, and number of channels are 3 here. The number of pixel which we have calculated using the size is this number, which is 562248, and the data type of an image is uint8. So sometimes you need to debug the data type of your image, and this attribute will be very useful in those cases when you need to debug if something is correct or wrong. And because we have splitted this method using this split and re-merged these BGR channels using this merge method, so we will at the end get the same image which we have at the beginning here in this code. So there is no change in the code. So once again, let me just load this image, and now let's talk about the ROI of an image. So ROI stands for region of interest. So sometimes you need to work with certain region of the image. So let's say you only want to work with the face here, or you only want to work with this ball. Okay, so this is called the region of interest, or in short form it's called ROI. So let's say we want to just work with this ball here. So this will be our region of interest, or ROI, and I want to just copy this ball to other place in this picture. So I want to just copy this ball and place it on the other place, let's say somewhere here. Okay, so how we can do this? So I already have the coordinates of the ball, but you already know how to get the coordinates of some place in the image. We have already discussed this in our previous video, so I'm not going to show you how to obtain those coordinates. But let's say I have those coordinates of the ball, so I'm going to create a ball variable, and we have our image. So we will take our image, and there are certain NumPy indexing features which we can use here. So I'm going to just write 280 colon 340, which is going to give you 1 point on the ball, which is the upper left hand side of this ball. And then we will give 330 here colon 390, which is going to give us the bottom right hand corner of this ball. Okay, so now we have this ball. So this indexing is going to copy this ball, all the pixels of this ball, and then now we have the ball, so we can place this ball on any place on this messy image which we are reading. So what we can do is we can once again use IamG, and using those NumPy indexing features, we can place this ball at some other place. So let me just give those indexes here. So let me give 273 colon 333. I have already tested this code, so that's why I know exactly where I want to place this ball. But if you are not sure where to place this ball, then you might have to first calculate or know the coordinates where you want to place this ball, and you already know how to find out the coordinates on an image, and you will be able to place that ROI or interest of region at some other place. So what I'm doing here is I have just copied the ball, and then I am placing the ball on this coordinate. Okay, so I just need to just assign our ball on this coordinate, and then this ball will be copied to this index on the image. So let's see what happens when we run the code. So now you can see we have copied this ball and we have placed this ball here on the image. So this is how you work with the ROI, or region of interest. Okay, so let me close this window. Now the next thing which I want to show here is how you can add two images. So for that I need one more image. So you can see in my project I have this messy5.jpg, and I have this other image which is OpenCV-logo.png file, which is of the same size as the messy.jpg image. So I'm going to just write img2 and then once again cv2.imread method, and then I'm going to give the name of this file, which is OpenCV-logo.png file. Okay, so this is this file. So this file we are reading, and then there is a method called add. Okay, so we are going to use this method here. Let's use this method cv2.add, and this method I'm going to show you what it does in a moment. But this method takes two arguments. First is the first numpy array. So let me show you what this method do first of all. So this is the add method inside your cv2 package. You can also see the documentation on the opencv.org, and what it does is it calculates the pre-element sum of two arrays, or an array and a scalar. Okay, so here we can just pass our two arrays which we got from the imread method and pass here as the first and the second argument. So img and img2 are the 1 and 2 parameter, and there are some other parameters also, like output array, input array mask, and int, which is the data type, which are set by default, so we are not going to set them. So we are just using cv2.add method on these two images, and then I just want to assign the new image which we have added to a new variable. Let's say this is dst for destination image, and then we are going to just show this image using this imshow method. Okay, so we have two images. Let me show you those images one by one first of all. So this is the first image I have, and the second image is OpenCV-logo, which is like this one. Okay, so those two images we have, and when I run this code after adding those two images using add method, you will see, first of all, you will see this error. And why this error is coming? Because you will see here that the size of those two input is not matching. Okay, so in order to add two images, you need to have the images or the arrays of same size, and then only you will be able to add those two images. So let's resize those two images into a size which is common to both of them. So what we are going to do next is we are going to resize those images. So once again, I'm going to just use img variable. So what I get after the resizing, I will once again assign to this img variable, and there is a method called cv2.resize, and this helps us to resize the image. So first of all, we need to give the source which we want to resize, and then we are going to give the size which we want to get. So the number of columns and number of rows we can give here. Let's say we want to just resize this image to 512, 512, which is the number of rows and number of columns, right? Same we will do with the next image. So img2, and then once again cv2.resize, and then the source here will be image 2, and the size which we want here is again 512 comma 512 in the form of tuple. So we have resized this image and this image, which are of different sizes, to the same size. And now let's run the code once again, and now you will see that these two images are merged now. Okay, so you will be able to see the hand here and little bit foot, and here the ball of this image 1, which is messy 5, and then we have the second image, which is OpenCV, which is added to the first image. So this is how you can add two image using OpenCV. Now there is one more method which is called add weighted. Okay, so this add method is going to just add these two images, but if you want to add the weight, for example, you want to give the weight 90% to the first image and 10% to the second image, there is one more method. So let's go to the documentation once again, and there is this method called add weighted method. Okay, so this add weighted method takes several arguments. Here you can see first is the source of the first array, and second argument is the alpha value. Alpha is the weight which you want to give to the first image. Okay, the third argument is the source 2, so in our case this will be the image 2. The fourth argument is the beta. Beta is the weight which you want to give to the second image, right? So this weight you can give from 0 to 1, anything. And this gamma is the scalar value which you want to provide, and this second last parameter is the destination, and the last is the D type or the data type here. Okay, so this is the formula which this method is going to use. So source multiplied by alpha and source 2 multiplied by beta plus gamma. So this is the method which will be used using these arguments, or simply you will use this kind of method. So source multiplied by alpha plus source 2 multiplied by beta plus gamma, which is the scalar you can add to the image. Okay, so let's use this method. So I'm going to just copy this method and then comment this and go to the next line, and instead of using add, I'm going to use the add weighted method. Okay, so the first argument is the source, which is the first source, which is img in our case. Second argument is the weight. So first, this is the messy image, right? So we want to just give the weight here 90, or you can just give 0.9 here. And for the second image, we want to give the weight 0.1. Okay, so the sum of this weight and this weight will be 1. And also we are going to give the gamma value here as 0. So we don't want to add any scalar value to this add weighted method. So the next value here will be 0, which is the value of gamma. And let's run this code, and you can see now we have our messy image, which is dominant here because it has the weight 0.9, which is 90% of the 2, and the OpenCV image have the weight 0.1, which is 10% of the 2. Okay, so the OpenCV image is light and the messy image is a little bit dominant here. You can just give 0.5 and 0.5, so the weight of the two images will be the same, and now you will see those two images in the same domination. Okay, so 50-50%. Now let's say we want to increase this value of OpenCV to 0.8 and the messy image weight will be 0.2, then the dominant image here will be OpenCV, and in the background kind of thing you will see this messy image. So this is how you can add two images with their weight and the scalar. And that's it for this video. So in this video you have seen some of the basic operations on the images and some of the arithmetic operations on the images which you can do using OpenCV. So I hope you enjoyed this video, and I will see you in the next video. Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video, we will talk about bitwise operations on images using Python and OpenCV. So bitwise operations can be very useful when working with masks. Masks are binary images that indicates the pixel in which an operation is to be performed. So let's see how we can perform bitwise operations on images. So to start with, I have here one image, which is image underscore one.png file, and let me show you the image also. So this image is half black and half white. Now the second image I'm creating using NumPy. So first of all, I've used np.zeros and I'm just creating this image with the same dimension as this image underscore one is having. So 250 comma 500 is the dimension of this image, and the number of channels are 3, and this code is going to create a black image, as you might already know from our previous videos. Now this code is just creating a white rectangle inside the black image which we got from NumPy's zeros array. Okay, so this is the dimension of the rectangle inside your black image, and the color of the rectangle will be white because this is 255 comma 255 comma 255, and we are taking thickness as -1. That means your rectangle will be filled with white color. Now here I'm just showing both the images using IamShow method, and this code you might already know what this is doing from our previous videos. So let me run this code and let's see what happens first of all. So when we run this code, you will see first image is this one which we have created using the NumPy 0. So this is img1, and this is the black image, and we are just creating a white rectangle inside this NumPy 0's image. And this is the second image which is half black and half white. Now we want to perform some bitwise operations on these two images. So let's see how we can perform these bitwise operations on these two images. So to perform these bitwise operations, we have some methods inside the OpenCV library. So the first method will be bit and. So I'm going to just create a variable called bit and with let's say like this, and the method inside OpenCV is cv2.bitwise underscore and. So this bitwise underscore and takes several arguments, as you might see here: the source of the first image, the source of the second image, and the destination, which is none by default, and the mask, which is also optional. So we are going to just provide our images here. So I'm going to provide the img2 here first of all as the first argument, and the second image will be img1. And once we perform this bitwise AND operation on these two images, we are going to show the result in the form of window. So I'm going to create one more window which is cv2.imShow, and I'm going to name this window as let's say bit and the second argument will be our variable bit and, which we got from the operation bitwise and on these two images. So let's run this code once again and let's see what happens. So now as a result we have the third image. So let me just open all the images. So this is our first image, this is the second image, and the last one is the result, which is the bit and operation on these two images. So now you might already know how the logical AND works, but those of you who might not know how the logical AND works, let me show you the truth table of logical AND. So this is the truth table of logical AND, and if the input A and input B is 0, then we get the result 0. Okay, if input A and input B, either of them is 0, then also we get zeros, right? The result 1 we will only get when both the sources are 1. So A and B are 1, then only we will get a 1 in case of AND logic. So same AND logic will work here. So this is the zeros array, right? So we have created this black region from the zeros. So here in these images, black is performing as zeros and white part is performing as 1. So when 0 and 0, the result will be 0, right? So from this truth table we have seen when the input is 0 and 0, the result is 0. Same here we are seeing. So when the image is black and black, we get the result black. When the input is white and black, this means 0 and 1, the result will be once again 0 using the logical AND. But when the input will be white and white, that means 1 and 1, the result will be white, that means the 1. Okay, so the only region white here is the result of this white and this white, and the resulting image you can see here, and all the other part is black because the AND operation on 0 and 0 is 0, and 0 and 1 is also 0. So this is how bitwise AND works. Let's see how bitwise OR and other operation works. So I'm going to just comment this code, and now we are going to just create the bitwise OR operation. So for that, I'm going to just instead of writing bit AND, I'm going to just write bit OR, and instead of bitwise AND, we are going to just write bitwise OR here, and then we will simply call this image using IAMShow method. So we are just calling here bit OR. Now let's run the code once again and let's see the result. So you can see the result here. So let's see the truth table. So in the logical OR, if only one input is 1, then the result will be 1. So either A or B is 1 or both are 1, then the result will be 1, and if both inputs are 0, then the result will be 0. So same you will be able to see here. So when the first source and the second source is 0, the result is 0. But when the first source and second source is 1 or white, the result is white. When the first source and the second source is 0 and 1 or black or white, the result is once again 1 or white here. Okay, so this is how the logical OR works on the image. Now let's see how the XOR operation work on those images. So I'm going to once again comment this code, and this time I'm going to just perform the XOR operation on these two images. And now we are going to run this code once again, and you will see this kind of result. So once again, let's see how the XOR logic works. So when both the inputs are 0 or both the inputs are 1, then we will get the 0, and if either A or B is 1, then only we will get the result 1. So same you will be able to see here. So when both first and second source is 0, the result is 0. when both the first and second source is 1, you can see here and here the result is once again 0 here, right? But when the input is 0 and 1, result will be 1. And in this case also, the black and white will result in the white image, which is the logical XOR operation. So once again, let's close this. And now let me show you how the NOT operation work. So I'm going to just comment this code, and then I'm going to just use the bitwise NOT. So here bit NOT, let's say we will perform the bit NOT on the first image and the second image. So I'm going to just write bit NOT on the first image because it only takes one argument. Bit NOT is just the opposite of the source. So if you get the input 0, then the result will be 1. If you have the input 1, the result will be 0. So the opposite of the input. So let's perform this operation on image 1 and image 2. And let's comment this code, and we are going to just show these two result windows using the IamShow method. And also I need to change this name, otherwise we will face problems. And here also I haven't changed the name of these IamShow windows, so let's change the name of these windows, and let's run the code once again, and now you will get these results. So we will get the first result. So the first bit NOT 1 is the NOT of the first image, and bit NOT 2 is the NOT operation on the second image. So you can see wherever we have white, we got black, and wherever we have black, we got white. So just the opposite of the input. Here also, wherever we have the black region, we got the white image here, and wherever we have the white pixel, we got the black pixel. So this is how bitwise NOT operation works on the images. So these are some of the bitwise operations which you can perform on your images. And as I said, bitwise operations can be very useful when working with masks, which we will see in the later videos. So stay tuned and keep watching these videos, and I will see you in the next video. Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video, we will talk about track bars in OpenCV. Now, track bars are really useful whenever you want to change some value in your image dynamically at runtime. So let's see how we can use track bars in OpenCV. Now to start with, I have this simple code which you might know what it does. So first of all, I have imported CV2 as a CV, and then I'm creating an image using the numpy zeros array with these dimensions, and then I'm creating a named window with the name image. So this might seem new to you because I haven't created a named window in the previous video. So the named window you can use to create a window with a name, and this time we have given the named window name as image. Now in this while loop, we are just using this IamShow method to call this window and then loading this image inside this named window. Now you might already know what this code does. It just waits for the key, and if the key is escape key, then we will break out of this loop. And in the last, we are just destroying all the windows which we have created. Now in order to create a tracked bar, you just need to use CV and then call a method called create track bar. Now the first argument here you need to give is the track bar name, because you can create multiple track bars in your image window. That's why you need to provide a name which is unique to this track bar. So I'm going to just give the name to my track bar as B, because what I want to do is I want to change the BGR values of the image using the track bar. So the first track bar will change the B channel values. That's why this first argument is the track bar name, which is B, and the second argument here we will give is the name of the window. So that is why we have created this named window, so that we can provide the name of the window, which is image in this case, and that is how we know that in which window we need to add the track bar. So in the image window, which is this one, we want to add the B track bar. Now the third argument here will be the value, which is the initial value at which your track bar is set, and the next value here will be the count, which is the final value you want to set for your track bar. Now there is this last thing which we want to set here, and this is the callback function, which will be called whenever your track bar value changes. So here, for example, I'm going to create a callback function called nothing, and this callback function definition or signature I'm going to create here. So we can just create a callback function with a name nothing, and this function can take this value x, and this is the value of the current position of your track bar. So we will see what it does little bit later, and what we are going to do is we are going to just print the value of x, so we will know the current position if this track bar is changed. So this is the callback function which will be called whenever your track bar value changes. Same we will do with the other track bars. So we will create the 3 track bars in the same window with the name B, and the next track bar name will be the G, and the last track bar name will be R. Okay, so this will be capital R. So now let's run this code and let's see what happens when we run this code. So I'm going to right click and run this script, and you can see here inside this named window with the name image, we have this black image which we have created using NumPy zeros array, and now we have 3 track bars here with BGR names. So these track bar values you can change using this scroller, and as you can see here, let me show you in this terminal, whenever you change the value of any bar, the corresponding value will be shown here using this callback function, and inside this callback function we have the print statement. Okay, so as I said, whenever you change this value, this callback function is called and it will print the value of the current track bar. Okay, so for this functionality, what we want to do is we want to get the current position of the track bar, and because we can change the value of BGR channels from 0 to 255, that's why I have given the range between 0 to 255 to the track bars also, so that you can change these BGR channel values. So now in order to get the current value of your track bar, first of all we will just check the value of the B track bar. So we will just use cv.get track bar position, which is this method, get track bar POS, and then we just need to give the name of our track bar. So let's say we want to check the position of track bar B, then we will just say we want to have this track bar position with the name B, and the second argument here will be the name of your window. So in which window this track bar is present. So our track bar is present inside the image window, right? So same we will do for the G and R values also. Now we have the values of B, G, R channels from the track bar. So now we want to set these values to our image. So what we can do here is we can just write for example I am G. Inside these square brackets you can just give this kind of notation and then give the BGR channel values. So I'm going to just write B comma G comma R. That means we want to set the current B, G, R values to this image. So let's run this code and let's see what happens now. So I'm going to run this code, and now when I change the blue channel values, you can see this image becomes blue colored, right? Let's bring it to 0 once again, and now let's change the value of G. So you can see this image color is changing to green, and then we can try changing the red color, and you can see when it goes to 255 the color of the image is red. You can change the values of different track bars, and the corresponding color will be displayed in this window here, right? So you can see the color is changing. You can change any track bar here. One more example I want to give here is how to add a switch using a track bar. So for that I'm going to use one variable called switch, and then here I can add first of all the name of the switch. And in the next line we will once again call cv2 dot create track bar with the name switch. Okay, so now the name of our track bar will be switch. So now we have added one more track bar to our named window, and now here we will get the current position of this switch track bar. So I'm going to name it as S, and the name of the window is switch. So we will just give the first argument of this get track bar position as switch. Okay, and the window name is image itself. So now we can add some condition here. So let's say if this position of the switch which we have, if this position is equal to 0, because we only have 0 and 1 in this last track bar. So if this position is equal to 0, what we want to do is we want to set I am G, and then in the square bracket this colon, and we don't want to change any value. So we will say that I am G this square bracket colon is equal to 0, which means that we don't want to do anything. Or in the other condition, which is when your track bar is at position 1, then only we want to change the BGR channel of the image. Okay, so let's run this code and let's see what happens. So I'm going to run this code, and now you can see the position of this track bar switch is 0, and when I change it to 1, so let's change this position to 1, you can see the value to 1. And when this position is at 0, you can change anything here, any track bar, nothing happens, because this condition is met, which means that we don't want to do anything. As soon as we change the switch to 1, that means we want to change the BGR values. You can see this color is changed inside the image. So the 0 is just like off switch, so we don't want to change any color, and 1 is like on switch, so when it's 1 the value of RBG channels can be changed. Now I want to give one more example of track bar to use, so that's why I have created one more file, which is Python OpenCV track bar example 2, and this time I'm going to use just 2 track bars here, so that's why I'm going to delete some of the code here. So using the first track bar, let's say I want to just change some values inside our image and I want to print that value on that image. So let's say now our range is between 10 to 400. Okay, so the lower range is 10 and the upper range is 400, and using this track bar I want to print the current value on our image, and also I want to have a switch which I can toggle, and I want to change the color of the image from the colored value or colored image to the grayscale image. So now our switch is between color to the grayscale image. Now in here what we want to do is we want to just assign this IAmShow value to the image variable itself, and then we want to get the current position of the track bar, so we will use this method to get the current position of the track bar, and I'm going to name this current position as POS variable, and the name of this track bar, let's change this name to something else, let's say CP for current position, and also here CP for the current position, and the name of the named window is image itself, so we are not changing it. So now we have the current position. So first of all we will just create the font, and then we will just use the cv dot put text method. You already know what this method does. It just print the text on your image, and then we will provide the parameters. First argument is the image, the second argument is the value which we get from the track bar, so this is the position, and because it's a number we need to convert it to the string using str method, and then the position at which you want to show this text, so let's say it's 50, 150, and then next is the font, so I'm going to just give the font, and then the next value is the font scale, which is 4, and the next value is for the color of the text. So let's say the color here will be 0, 0, 255, and this should be cv dot font Hershey complex. Let's change this font also, let's say this is just the simplex font. Okay, so this code is going to just print the current position of the track bar on your image, and then inside this condition what we want to do is we want to get the switch value. So let's use this s variable and then get the current position of the switch using this switch name from the image window, and then if the switch is at 0 position then we want to do nothing, so we will just pass this situation, and in case the value of this switch is 1, then what we want to do is we want to change the image value from color to the grayscale value, right? So we can just write cv dot cvt color, and the first argument is the image which we are loading, and the second argument is cv dot color bgr to gray, which is to convert this colored image to grayscale image. But you can see here we are just creating a black colored image, and in our project we also have this image, so let's read this image. So I'm going to just write cv dot im read, and then give the name of the image, which is lena dot jpg. So this is our colored image, and this way we will be able to see the change of color to gray scale image in a better way. So let's run this code and let's see what happens. And you can see image appears and disappears, and there is an error. So let's see what is the error. So the error here is coming from this line. So we need to read this image inside the while loop. Okay, so this is why our error is coming, and at the last we want to load this image after this if condition. Okay, so now let's run this code once again, and you can see this value is printed on our image, which is 10, which is the value of CP, and if we change this value, it is changing on our image also, right? And once we change this 0 to 1, then our image is converted from colored image to the grayscale image. You can also change the font size here. For example, let's say it's 6 here, and the thickness also, if you want to change, you can change it using this parameter. Let's say it's 10, and let's run this code once again. You can see the thickness and the size of the font is changed, and you can see this value in a better way. Okay, so this is how you can use track bars in OpenCV. I hope you have enjoyed this video, and I will see you in the next video. Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video, we will see how we can perform object detection using HSV color space. Now, we have already seen how to work with BGR or colored images or grayscale images. And we have already seen how we can convert from colored images to grayscale images. So there are more than 150 color space conversion methods in OpenCV, and one of them is colored image to HSV image. Now, what is HSV color space? So HSV stands for hue, saturation, value. So H stands for hue, S for saturation, and V for the value. Now, generally RGB in RGB color space are all correlated to the color luminance. That is what we loosely call intensity. In other words, we cannot separate color information from luminance. So HSV or hue saturation value is used to separate image luminance from color information. So this makes it easier when we are working on or we need luminance in our images. That is why generally we use HSV in the situation where color description plays a very important role. Now, as I said, HSV stands for hue, saturation, and value. But what is the meaning of each and every single word in HSV? Now, HSV is also known as the hexagon color model. So this color space can be described in this kind of cylindrical cone model, where hue is this circular angle which varies from 0 to 360, and hence just by selecting the range of hue, you can select any color. So you can see different colors are available at different angles. So these colors are basically red, yellow, green, cyan, blue, and magenta. So hue is this angle in this cylindrical cone. Now we have saturation. So the saturation is amount of color, that is the depth of pigment or the dominance of hue. And this value is described from the center towards the outer layer of this cylindrical cone. So here you can see at the center, this saturation start at 0 and it can go up to 1 at the end of this cylindrical cone. And this saturation can be increased from 0 to 100%. Similarly, the value is basically the brightness of the color. So this brightness can be increased from 0 to 1, from the bottom of the cone to the top of the cone. So all these three values, hue, saturation and value, can be used to pick any color, as we can do with the BGR color space. So this is the brief introduction about HSV color space. And now let's see how we can use this HSV color space to detect an object in an image. So here I have this simple code to load an image using IamRead method and show it inside a window. So by now you might already know how this code works. So let's run this code and let's see what does this code do. So I have this image which is called smarties.png, and here are some circles in different colors. So we have blue circles or green or red, orange and brown circles here inside this image. So let's say we somehow want to detect only the blue circles or balls or green circles or balls. How can we just detect only these balls? Let's say we just want to detect the green balls. How can we achieve this using OpenCV? We are going to see this using this HSV object detection. And here we have one more window, which is the tracking window, which is coming from this code, which is cv2.named window, and the name of the window is tracking. So this tracking window we are going to use little bit later when we will add the track bars to our image. But let's say we want to use this image and detect these colored balls. So first of all, after this image is read, what we want to do is we want to convert our colored image into a HSV image. And by now you might already guess how to convert an image. You can just write HSV is equal to cv2.cvt color, and then your frame name, which is frame in this case, and then cv2 dot whatever color space you want to convert from and whatever color space you want to convert to. So you can just write color underscore BGR to HSV. So this is the property we are going to use. Now in the next step, we will threshold the HSV image for a range of blue color. So we are going to just define L underscore B for lower blue color, and then we are going to use the numpy array, so np dot array, and inside this array we are going to define the lower range of blue color. Now by experience I know that these HSV value for lower blue color will be 110, 50, 50, right? But you might not have every time the idea what is the lower color range or the upper color range of some color. So that is why later in this video we will use the track bar in order to perfectly define the lower and upper values for this HSV color space, right? So right now I'm just going with my experience. So for the upper value I'm going to define the next variable, which is ub is equal to np dot array, and then once again I'm going to define these three color channels, which is 130, 255, 255. So this will be the upper limit for the blue color for our HSV image. Now in the next step, what we are going to do is we are going to threshold the HSV image to get only the blue color, let's say. So I'm going to just define a variable called mask here, and then I'm going to use cv2 dot in range method, where I will provide first of all my HSV variable or image, and then I will provide the upper and lower range for this function. So my lower range is this numpy array for the blue color. So I'm going to just say L underscore B is my lower range, and u underscore b is my upper range. Now we have already seen how we can use bitwise AND or bitwise operations on images. So what we are going to do next is we are going to define a variable called res, and then we will just call cv2 dot bitwise AND to mask the original image. So here the first value will be our frame, which is the colored frame, right? So this is the frame which we have read from this image, which is the Smarties image. So this is the source one. Source 2 will be the same. So the frame itself will be the source 2. And what we want to do is we want to provide the mask of the lower blue color and the upper blue color values, right? So here we can just say mask is equal to whatever mask variable we have created. So this is the attribute we can set in order to apply the mask for the lower blue value and the upper blue values. So once we have this result frame, what we can do is we can use this cv2.imShow method in order to show the mask, let's say. So we are going to show the mask and we are going to show the result using res variable. So this is going to open 3 windows, and let's see what happens when we run this code. So we are going to run this code and this opens 3 windows here. And now you can see the mask first of all. So we are just detecting the blue colored balls using this mask. That's why we have defined the lower boundation of the blue color and the upper boundation of the blue color, right? So that's why it's only detecting, you can see the blue ball is here, here and here, and here also you can see the mask also detects only the blue values here, right? And then in the result you can see when we have applied this mask and we have masked all the other things other than the blue colored ball, you can see only the blue balls here. So the same method you can apply to detect any other colored ball from this image. Now, as I said, it's not easy to detect these lower and upper boundation for the colors. So that's why you can use the track bar for adjusting these lower and upper boundation of any color. So for that, what we are going to do is, first of all, we will create a named window, and then we are going to create a new window which we will use to adjust the lower and upper boundation of HSV values. So now I'm going to just use cv2 dot. We have already seen how to create a track bar, so I'm not going to explain in detail how this works, but let's say this track bar name is lower hue for LH. Okay, so this is the lower hue value, and then the name of the window, which is tracking, which is this one. So we are going to provide the name of the window, and the next argument will be the starting and the ending values. So we are going to define the start value 0 and the end value, let's say we are going to define the 255 here. Okay, and the last thing we want to give here is the callback function, which I have already created, which is this function, which is just doing nothing. We are going to just provide this callback function as a dummy function, so it's not going to do anything. So this is the track bar for the lower hue value. Similarly, we are going to define the track bar for lower saturation and lower value, and upper saturation, upper value, and upper hue. Okay, so this will be lower saturation, this will be lower value, and then this will be UH, which is upper hue, and then this will be US for upper saturation value, and this will be upper value, right? So HSV lower values and HSV upper values. So here we are going to set the initial value for the upper value. So let's say everything is set to the maximum, so 255, 255 and 255 here. Okay, so the lower values are set to zeros and upper values will be set to 255. Now you already know how to get the values from a track bar. So you can use, for example, L_h for the lower hue values is equal to CV2 dot get track bar position. So just use get track bar position method, and then first of all give the name of the track bar from which you want to get the position. So let's say we want to get the position from the LH track bar, and then the name of the window which is tracking in our case. So here is the second argument. And similarly, what we are going to do is we are going to define the other lower values and upper values. So and also the name of your track bars. So once you have the values of lower HSV and upper HSV, you can provide these values here in place of these static values. So first element of this array will be LH, and then the LS variable, and then the LV variables. Similarly, for the upper boundation, we will provide these three upper boundation variables. And now when we will run our code, let's see what happens. So we are running our code, and you can see these windows, these three windows. One is the mask, other is the result, and the third one is the frame. And we also have these track bars in order to change the value of lower and upper HSV values. So first of all, let's set this mask for the blue color. So I'm going to just move it to 110 as we have done in the last step, and then this will be around 50, and this also will be around 50. Okay, so let's move it to 50, and upper value here will be around 130, right? So you can see once again, using this track bar, it's easier to adjust these lower and upper boundation. And now you can see all the three blue colored balls. So you can refine this object detection by moving these track bars little bit left or little bit right. You can see here. Now let's adjust this value to detect some other balls. So let's say we want to detect the green balls. So let's see what happens when we just change the saturation values here, and you can see now you almost see the green values, and the blue color is almost disappearing. So you can see now there are only green balls which are detected, and all the other balls are masked. So you just need to play with this track bar for the lower HSV values and the upper HSV values, and you will be able to detect the object, whatever colored object you want to detect from the image. Now this is the object detection from the image. Similarly, we can use the same method in order to track an object from a live video. So I'm going to just escape to just close all the windows. And in order to change this code for the video input, what we can do here is we can just add this code. So we are going to just add the cap variable, which is the capture variable, is equal to cv2 dot video capture. So we are going to use this one, and we are going to capture the video from our default camera, which is at the index 0. And then you already know how we can read the values from the camera input. So I'm going to just comment this code, and instead of reading the image, what we are going to do is we are going to write underscore comma frame. is equal to cap dot read, which is going to read the frames from your default camera. And at the end, when you are done playing with your images, you can just destroy this cap using the release method. So you can just write cap dot release, which is going to release all the cameras you are just capturing, right? So now this is the 3-line code you need to use in order to capture the camera input and then track any object of any color. So I'm going to run this code now, and you can see I'm just holding a blue colored object here, and I'm moving this object on the left and right, and you can see only blue colored object is detected and every other frame value is masked. So this is how you can do the object tracking of any color using the HSV color space. So you can see the real image which is captured from the camera, and then the mask, and then the result of the mask and the real image in this blue colored object tracking. So this is how you can do object detection and object tracking using HSV color space. I hope you have enjoyed this video, and I will see you in the next video. Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video, we will see how we can perform simple thresholding on images using OpenCV. So first of all, what is thresholding? So thresholding is a very popular segmentation technique used for separating an object from its background. The process of thresholding involves comparing each pixel of an image with a predefined threshold value. And this type of comparison of each pixel of an image to a threshold value divides all the pixels of the input image into two groups. So the first group involves pixels having intensity value lower than the threshold value, and the second group involves the pixels having intensity value greater than the threshold value. And using the different thresholding techniques which are available in OpenCV, we can give different values to these pixels which are higher than the threshold value and which have the intensity lower than the threshold value. So let's see how we can use simple thresholding techniques on an image. So to start with, I have this simple code which loads an image on a window, and this image is called gradient.png. So let me show you how this image looks like. So this image looks like this. So as you can see in this image, we have on the left hand side the black values, and when we gradually move from left to right, we move towards the white value. So on the left hand side, the pixel value are closer to 0, and on the right hand side, the pixel values are closer to 255. So now we are going to just involve some thresholding techniques, and we will see how this image is affected by the thresholding techniques. So first of all, what we are going to do is we are going to define two variables. One is underscore, because the result of the thresholding gives two results. One is RET value, and the second is the thresholded value of an image. So I'm going to just say the second value which is given by the thresholding technique is th1 is equal to cv dot threshold, and this threshold method takes several values. The first is the source, so our source is image. The second is the threshold value. So as we have seen that our image have on the left hand side 0 pixel value, and when we move towards the right, its pixel value increases to 255, right? So let's say our threshold here is 127, and the maximum value of the threshold is 255, which is the white color on the right hand side. And then the fourth value here will be the threshold type. So there are several threshold type in simple thresholding. We are going to see them one by one. So the first thresholding type is CV2 dot thresh binary. So first of all, let me show you how the result looks like, and then I will explain what does this thresh binary type does. So what we are going to do is we are going to use one more cv2.imShow method to show this thresholded value into a new window. So we are going to just show this value into a new window, and we already have the original image in the image window. So let's run this code and let's see what happens. So you can see in this binary thresholding, we are comparing each and every pixel of this original image to 127. And if the value of the pixel is less than 127, the value is assigned to 0. And if the value of the pixel is greater than 127, the pixel value is assigned 255, that means white. So if the value of the pixel is 0, it will look black, and if the value of the pixel is 255, it will look white. So this is how binary thresholding works, and by the name itself you can understand that this is just a binary thresholding. So it's either 0 or 1. Now let's see the other type of thresholding technique. So now I will just change the name of this variable as th2, and the next type of thresholding is called thresholding binary inverse. And as the name suggests, the thresholding binary inverse is going to give the inverse result of what you get from the thresh binary. So I'm going to once again use the IMShow method to show the result of this thresholding binary inverse value, and let's run the code and let's see what happens. So this is the original image, and then we have the thresholding 1 image and the thresholding inverse image. So this image you got from the first thresholding, which is by using thresh binary, and the second image you got from this method, which is thresh binary inverse. And this thresh binary inverse image is just the inverse of what you get using the thresh binary. So if the pixel value is lower than 127, which is our threshold, the pixel is assigned 255. Otherwise, if the value is greater than 127, then the pixel value is assigned 0, which is the inverse of what we got in the previous step. Now let's change this threshold to, let's say, 50, and here also let's say we change this threshold to 200, and let's see how this result changes when we change the threshold value. So I'm going to run this code once again, and you can see this is the result of thresh binary. And now because our threshold is up to 50, that's why our result is like this. So until the pixel value is 50, it's black. Otherwise, if the pixel value is greater than 50, it's going to give you the white pixel value. And the thresh binary inverse is going to give you the inverse value of what you get in the thresh binary step. So I'm going to once again just close these windows, And let's see the next thresholding type. So I'm going to name my variable as th3. So the next thresholding type is called thresh trunk. So this is this type, and let's first of all see what is the result of this thresholding technique, and then I'm going to explain what it does. So we are going to just show this thresholded image into a new window and run the code, and now we have the result. So let's move it like this, and we have here the original image, and the result of the thresh trunk is this th3. So here what happens is, up to the threshold, the value of the pixels will not be changed. So up to 200, because our threshold is up to 200, so when the pixel value is up to 200, the pixel value will not change, and after the threshold, which is 200, the pixel value will remain the same, which is 200. So from here to here, the pixel value will remain 200. Let's change this threshold to some other value, let's say 127, and then let's run this code, and you will see that now from black to 127 pixel value, the value of this image will not change. So original image up to half is the same, and after the pixel value 127, the value remains 127. Okay, so the pixel intensity value will remain 127 until the end. So if the value is greater than 127, the value will remain 127, and if the pixel value is lesser than 127, then the pixel value will remain unchanged. So this is how the thresh trunk works. And let's see the other method, which is, let's say, th4, and this is the method which is called thresh20. So we are going to just use thresh20, and then we are going to open this th4 into a new window, and let's run this code and let's see what happens. So now we have this result. Let's move this to the left, and the result of the thresh20 is this one. So in thresh20 thresholding, whenever your pixel value is lesser than threshold, the value assigned to pixel will be 0. Okay, so when the pixel value is lesser than the threshold, the pixel value is assigned to 0. That's why you can see half of the image is black. And when the pixel value is greater than 127, which is our threshold value, the image or pixel value will remain the same. So after 127, all the pixels will remain the same. Let's see the other technique, which is called thresh20 inverse, which you already understood, I think, what it does. So this is thresh20 inverse, and we can just change this variable name to th5, and here we can just open it into a new window, and I'm going to run this code once again. Let me move this here and the result here. So you can see this thresh20 inverse is just the opposite of the thresh20. So if the value of the pixel is greater than the threshold value, which is 127, the value will be assigned to 0. Otherwise, if the value of the pixel is lesser than threshold, the value of the pixel will remain the same. So this is how some of the simple thresholding techniques works in OpenCV. We will see other thresholding techniques in the later videos. So stay tuned, and I will see you in the next video. Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In the last video, we have seen how we can perform simple thresholding in OpenCV using Python using various thresholding techniques. So we have used thresh binary inverse, thresh trunc, thresh to zero inverse. So these were all the simple thresholding techniques. Now in these thresholding techniques, we were setting a global value of our threshold. So in this example, for example, here the global value of threshold is 50, here 200, here 127. So we were setting in simple thresholding the global value, and this means that it is same for all the pixels in the image. Now in this video we are going to learn how to use adaptive thresholding. So adaptive thresholding is the method where the threshold value is calculated for the smaller region. So the threshold is not global for every pixel, but it's calculated for a smaller region, and therefore there will be different threshold value for different regions. Now, why do we need this type of adaptive thresholding? So using simple thresholding might not be a good idea in all the conditions. So there might be conditions where the image has different lighting conditions in different regions, and in those cases where the lighting conditions in the images varies from point to point, in those cases we might want to use adaptive thresholding. So as I said, adaptive thresholding calculates the threshold for a smaller region of images. So we get different thresholding values for different regions of the same image, and as a result, adaptive thresholding gives us better results for images with varying illumination. So let me show you the problem with simple thresholding for the image which have different illumination at different regions. So I have this image called sudoku.png which I'm loading using imRead method, and then I'm just showing this image using imShow method. And then let's use the simple thresholding technique, which is thresh binary for this, and we have set the global threshold value of 127 here, and then we will see the result after this threshold is applied to the image. So I'm going to run this program and let's see what happens. So this is our original image, and then this is the result which we got. So in the result you can see when we apply a same global threshold value, some of the region of this image is black and other region of this image is visible, right? So because the image have different illumination value at different regions, that's why we see half of the image which have the good illumination, and we don't see half of the image which doesn't have the better illumination. So in that case, it's a better idea to use adaptive thresholding. So let's see how we can use adaptive thresholding. So here what I'm going to do is I'm going to declare a variable called th2, and then we use cv.adaptive threshold. So this is the method which we are going to use for performing adaptive thresholding, and this takes few arguments. So first is the source. So our source is the image variable. Now the second parameter here is the max value. So the max value is the non-zero value assigned to the pixels for which the condition is satisfied. So in our case, the maximum value which we can provide to a pixel is 255, and we cannot go more than that, right? Now the third parameter here is the adaptive method. So this adaptive method is going to decide how the thresholding value is calculated, and there are two types of adaptive methods which we can use. So the first method is called cv2.adaptive thresh mean C. So what is the meaning of this adaptive thresh mean underscore C? So using this method, the threshold value is the mean of the neighborhood area. And here is the documentation of these two methods. So adaptive thresh mean C gives us the threshold value using this function, and this is going to give us the mean of the block size multiplied by block size neighborhood of x comma y minus C, which is the constant. And the second adaptive threshold type is this one, which is adaptive thresh Gaussian underscore C. And in this adaptive thresholding, the threshold value is the weighted sum of neighborhood values where weights are the Gaussian window. So let's use the first adaptive method, which is the adaptive thresh mean underscore C. Now the next parameter here is the threshold type. So the threshold type which we are going to use is the thresh binary, which we have also seen in the last video also. And then the next value is the block size. So block size decides the size of the neighborhood area. So here we are going to give the block size 11, and the next parameter here is the value of C. So we have seen that we need to give the value of C also when we use the adaptive thresh mean C and adaptive thresh Gaussian C. So this is the value of C which we are going to give, and C is just a constant which is subtracted from the mean in the case of this adaptive thresh mean method, or the weighted mean in the case of Gaussian adaptive threshold. Okay, so constant we are going to give here is 2, and now what we are going to do is we are going to just load this image which we got after applying this adaptive thresholding. And let's just comment the other window, so we will just see the original image and the adaptive thresholding result. So I'm going to run this code, and you can see the original image here and the result of adaptive thresholding, which looks much better than the simple thresholding technique. So let's uncomment this also. So I'm going to uncomment this, so we will see all the three results at the same time. So this is the original image, and you can see the simple thresholding gives us this value using the global threshold of 127, and adaptive thresholding gives us this value or this image which is much more readable than the simple thresholding technique image. So this is how you can use adaptive thresh mean C method. In the same way, we are going to use the other adaptive thresholding technique, which is called adaptive thresh Gaussian C. So instead of this, we are going to use adaptive thresh Gaussian C, and then all the parameters we are going to leave as same, and let's load the result of this type of thresholding, which is stored in th3. So let's run this code and let's see what happens. So we have already seen this image, which is the simple thresholding. This is the result of the adaptive thresholding mean C, and this is the result of adaptive thresholding Gaussian underscore C. So both of the result looks good because the adaptive thresholding algorithm calculates the thresholding value for different regions. So the thresholding value is not global for each and every pixel of the image. And we have seen the two adaptive methods which are available in adaptive thresholding. So in this way, you can use adaptive thresholding in OpenCV using Python. I hope you have enjoyed this video, and I will see you in the next video. Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video, we will talk about a library called matplotlib, which you can use with OpenCV images. So first of all, what is matplotlib? So matplotlib is a plotting library for Python which gives you a wide variety of plotting methods. And on the official website, which is matplotlib.org, you can see matplotlib is a Python 2D plotting library which produces publication quality figures. So it's primarily a 2D plotting library, but it's widely used with OpenCV to display graphs and images and histograms. So we will see how we can use matplotlib with OpenCV. It's also written here that for simple plotting, the PyPlot module provides a MATLAB-like interface. So first of all, let's see how we can install matplotlib, and then we are going to see how to use matplotlib with OpenCV. So to install matplotlib using pip, you just need to open your terminal and then just give this command, which is pip install matplotlib, and then press enter, and in some seconds this matplotlib library will be installed using pip. So now you can see matplotlib is installed on my Windows operating system, and to check it, I'm going to just give the Python command, and here I'm going to import matplotlib. So I'm going to just write from matplotlib import pyplot as plt, okay, and then press enter. And if this import doesn't give you any error, that means it's imported successfully and you can start using matplotlib. Now, as we are using PyCharm IDE, let me show you how you can install matplotlib on PyCharm. So just open your PyCharm IDE, and then here just click on file and then settings, and then go to project colon your project name. My project name is OpenCV examples, and then click on interpreter, and you can see other packages are already there, and we just need to install the matplotlib package. So just type here in the search matplotlib, and you will be able to find matplotlib here in the results. So just click on matplotlib and then just click on the install package. So I'm going to just click on the install package, and in some seconds matplotlib library will be installed in your PyCharm IDE. So you can see this message which says package matplotlib installed successfully. That means we can close this window, and then you will be able to see matplotlib is available in your project interpreter. So everything is fine, and I'm going to just close this, and now I will be able to import matplotlib. So I'm going to just write from matplotlib import pyplot as plt. Now, in order to show the image which you read using the OpenCV ImRead method, you can use this code. So just write plt.imshow. So there is also a method inside your pyplot library which is available inside matplotlib, and this method you can use to show the image which you have read from the OpenCV ImRead method. So for now, just write this kind of code, and to show the matplotlib window, you just need to write plt.show. So this is going to show this image using the matplotlib library. So we are opening this image using the OpenCV ImShow window as well as matplotlib window also. So let's run this code and let's see what's the result which we are getting. So you can see this is the image which is loaded using the matplotlib, and this was our original image which is loaded using the OpenCV library. And straight away you can see some difference. So this is the original image, which is the colored image, and in the matplotlib window we also want the same result, but it's giving us the different result. And the reason behind this is OpenCV reads the image in the BGR format and the matplotlib reads the image in the RBG format. So in order to show this kind of colored window using matplotlib, you need to convert your image from BGR to RBG, and then only you will be able to see this kind of colored image using matplotlib. So I'm going to just close these windows, and now after I'm showing this image using the CV2ImShow method, I'm going to convert this image. So I'm going to just write img is equal to cv2 dot cvt color, and then I'm going to convert this image from BGR image. So I'm going to just write cv2 dot color underscore BGR to RGB. Okay, so our matplotlib library shows the image in the RGB format, and the OpenCV reads the image in BGR format. So now we have converted our image from BGR to RGB image, and now we are showing this image using the matplotlib. And let's run this code and let's see what happens now. So now when we run this code, you see both the image looks the same, right? Now let's see the advantages of using matplotlib. So you can see this is quite static window, but when you see in matplotlib, when you hover over this image, you can see x and y coordinates of the mouse point, and this is helpful. You can also save this image in the form of a PNG file, so you can just press this and save this image wherever you want. You can also zoom this image if this feature is available. There is also configuration subplots options, so you can just increase these values left, bottom, wherever you want to place your image. You can do that. These are some options which are available here. You can also reset these options, and you can see the coordinates here. So because matplotlib is primarily a 2D plotting library, so you can see the x coordinates and y coordinates, and because this image is about 512 by 512 pixels, that's why here it's showing 0 to 512, and here also on the y-axis 0 to 512. So this is how you can load your image using matplotlib. And now I'm going to show you one more thing, and this is when you write plt.xtics here, and then when you pass empty array here, which is empty square bracket, comma plt.ytics, and also here you pass empty array. This is going to hide the tick value on x and y axis. So now when I run this code, and you can see now that these x ticks and y ticks on x and y axis are gone. So let me just comment this out once again, and you will be able to see this x and y coordinates here on the image. And when you use this code, which is to hide the ticks on the x and y axis, then you will see the image without these x and y axis ticks. So if you remember, in the last video we have seen how to use simple thresholding in OpenCV, and we were using 6 windows to show these 6 different images using OpenCV. Now let's say you want to show all these 6 windows in one matplotlib window. How you can do it with the use of matplotlib, I'm going to show you. So first of all, we are going to import matplotlib, import pyplot as plt, and then what we are going to do is we are going to define the titles, and then we are going to define these 6 different titles for 6 different images. So first one is our original image, second was the trash binary, third was trash binary inverse, fourth was trunk, fifth was 20, and sixth was 20 inverse. In the same way, we are going to define a variable called images, and inside this square bracket we are going to pass first of all our original image, and then th1 comma th2 comma th3 comma th4 comma th5. Okay, so these are the 6 value we want to show, and these are the 6 titles of these images. And now we are going to use the for loop. So for I in x range, so using the Python x range, we are going to just iterate over these 6 values. So I'm going to just write x range, and then the range we are going to provide here is 6. And then inside this for loop we are going to just call plt, and we are going to call a method called subplot. Okay, and this subplot method takes few arguments. So first argument is the number of rows which we want to show in our matplotlib plot. So because we have 6 images, so we are going to divide these images into 2 rows and 3 columns. So the first argument here is the number of rows, and the second argument here is the number of columns, and the third argument here will be the index of the image. So the index of the image will be I plus 1, and then we are going to write comma plt dot im show. So this is going to show this image and the index of the image, so we are going to just write images and then square bracket I. So this is going to give you a particular image at index I, and then we want to show this image as a grayscale image. So anyway, when you use thresholding, you use the grayscale image, so you just need to write gray here. Then we are going to show the titles of these images, so we are going to just write plt dot title, and then this title method takes the title name which we are getting using this titles array, and then at the index I, this is going to give you the title name which we have declared in this title array. And at last, if you don't want to show the ticks on the images, you can give these 2 methods, which is plt dot xticks, and the argument here is the empty list, and also plt dot yticks, and the argument is the empty list. And at the end, what we want to do is, instead of using this kind of code, we just want to show our window. So we can just say plt dot show, and this is showing us this error unresolved reference. Yes, so this is when you are using Python 2, but in Python 3 this x range is changed to a method called range, and that's why it was giving us the error. So let's run this script once again, and you can see 6 different results and 6 different titles. So these are all the titles which are shown here, and then the result are shown under these titles. So using matplotlib, you can include multiple images into one window, and this is very useful when you want to show multiple image at the same time in the same window. So this is how you can use matplotlib library with OpenCV images, and there is a lot of things which you can do with matplotlib. So if you want to learn more, you can just go to the official website, which is matplotlib.org, and then you will be able to see more documentation here. So that's it for this video, and I will see you in the next. Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video, we are going to discuss about morphological transformations in OpenCV. So we will discuss different morphological operations like erosion, dilation, opening and closing methods, etc. But first of all, what are morphological transformations? So morphological transformations are some simple operations based on the image shape. Now, morphological transformation is normally performed on a binary image, and when we perform morphological transformation, there are two things which are required. First is the original image, and second is called a structuring element or a kernel, which decides the nature of the operation. Now there are different type of morphological transformations and we are going to see them one by one. Now to start with, I have this simple code which reads the image using OpenCV IamRead method, and we are just loading or showing this image using matplotlib. Now if you are unfamiliar with matplotlib and how to use matplotlib to show images, in the last video I have explained this topic in details. So if you want to see that video about matplotlib, you can see it, and this is the code I have used in the last video also, and I have explained this code in details in the last video. So if you are confused what this code is doing, just see the last video. Now there is one important thing to notice here is I am reading this image in a grayscale mode. Okay, so either you can provide here as the second argument of IamRead cv2.IamRead underscore grayscale, or you can provide simply 0 here in order to read this image in grayscale. So let's run this code and let's see what it does. So as expected, it's just opening the image in the grayscale mode using matplotlib. Now, as I said, normally we perform the morphological transformations on the binary images. So that's why we need to provide a mask to our image using the simple thresholding. So let's just do that. So I'm going to just write underscore comma the mask. So I'm going to name my variable as mask here. And then I'm going to just write cv2 dot threshold, and this threshold take few arguments, as you might already guess. First is the image itself, second argument is the value of the threshold. So for now I'm going to just provide the threshold of 220 here. The maximum value of threshold will be 255. Then the next argument here is the type of the threshold. So we are going to provide cv2 dot thrash binary inverse. So this is our mask. So let's load the mask in the matplotlib window. So I'm going to just provide in this titles array one more title, which is mask, and then we are going to see how this image looks like after the mask. Okay, and here the range I'm going to increase it to 2 because now the array is of 2 elements, and the subplot is also, let's say, 1 by 2. So we want to show 2 images, and I'm going to just run this code, and you can see this was the image, which was the grayscale image, and the second image is the masked image. Now if you see this image carefully, let me just increase the size of this image, and if you see this image carefully, after masking there are some black dots here on the balls, and let's say we want to remove these dots which are there in between this white area, this black dot or this black dot, or you can see some black dots are there inside your ball in the white area, and we want to remove these dots from the balls. For this we are going to use the dilation transformation. So first of all, what we are going to do is we are going to just write dilation, which will be our variable name, and then we are going to use this method called cv2.dilate. Okay, so this method uses the source, which is mask in our case, and then the second thing is the kernel. Okay, so let me explain what the kernel is. So a kernel is normally a square or some shape which we want to apply on the image. So we are going to define a kernel of numpy once, which means we want to apply white square on our balls. So you can see when we run our code, once again it shows us error because this kernel is undefined. So let me define this kernel first of all. So I'm going to just say kernel is equal to np.once, and then we are going to define the shape of this kernel. Let's say this is of 2,2 size, and then we will just say np.uint8. So this is our kernel, and kernel in this case is nothing but a 2 by 2 square shape, and this square shape kernel is going to be applied on our image wherever these black dots are there. So now we have defined this kernel. So let's see after this kernel is applied on our masked image how it looks like. So I'm going to just add one more title here, which is dilation, and then I'm going to add the image after the dilation is applied on our image, and then we are just going to increase the range to 3 because now we have 3 images, and let's say this plot contains images 1 by 3, so 1 row and 3 columns, right? So I'm going to just run this code once again, and now you can see all these 3 images. First was the original image, second is the masked image, and the third one is the image which we got after we applied the dilation. Let me just increase the size of this image somehow. So now you can see that, for example, here there was a black dot and now it's reduced, right? The size of this black dot is reduced. Here also there was a black dot, but its size also is reduced, but still we can see these black dots here, right? So how we can remove these black dots completely? So there is a third parameter which we can provide to this dilate method, and it's called iterations. So number of iterations. So we can just provide iterations is equal to whatever the number of times we want to perform dilation on our image. By default it's 1, and you can provide, let's say, 2 here, and let's see what is the result now. So I'm going to just run this code again, and now you can see those black dots which we can see here on the masked image are now gradually gone, but still I can see some little dots on the images. The small dots are already gone, right? So now what we can do here is we can increase the size of the rectangle. So this rectangle is applied to our area which have these spots. So we can increase the size of the rectangle, and the bigger the rectangle is, the better the result will be, but there will be a problem which I'm going to show you. So let's run this code, and you can see now all the black dots from our image is gone. So there was a black dot here which you don't see anymore, and there was a black dot here, 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 and here, and we don't see these black dots here. But you might also observe that the size of this white area is also increased after we applied the dilation on this masked image. So now this ball and this ball in the result after the dilation is merging here, right? So you can see it's merging because the size of our kernel is big, and when we apply dilation, the pixel element is 1 if at least one pixel under the kernel is 1. That's why the shape of these balls are increasing. So let's see how our next morphological transformation works, which is called erosion. And after that, I'm going to explain you how this erosion works and what is erosion. So I'm going to just declare a variable called erosion, and then I'm going to just call a method called cv2.erode. So the method name is erode, and the first argument here is the source. The second argument here is the kernel, as we have seen in dilate method, and the third argument is the optional argument, which is the iterations. So for now we just apply one iteration, which is by default also 1, and now we are going to just add this image to our matplotlib window. So I'm going to add the title and the image, and now I will increase the range of the array to 4, and let's say now we want 2 by 2 matrix of these images, right? So let's run this code and let's see what happens. So now you can see 4 results here, and first was the original image, second was the masked image, third was the dilation. So all the spots in the balls which are black are gone using the dilation, but the size was increased. And using the erosion, you can see the sides of the ball eroded. So the basic idea of erosion is just like soil erosion. It erodes away the boundary of the foreground object. So when this erosion is applied, the kernel which we have defined slides through all the image, and a pixel in the original image, either 1 or 0, will be considered as 1 only if all the pixels under the kernel is 1. Otherwise it is eroded, and this means this value will be set to 0, which means this will be a black area. So let's increase the number of iterations here. So let's say we want to apply the erosion 2 times on the same image, and I'm going to just run this code once again, and you can see now these balls are eroded more. Let's say we want to increase this to 5 times and then run the code, and you can see now these balls are really small because we have applied this erosion multiple number of times. So let's say this is 1 once again, and let's make this size of our kernel small, 2 by 2 rectangle size, right? So you can see now our result is better because all the spots from these balls are gone, and these balls are not so much eroded. Now there are 2 more morphological transformation methods which are called opening and closing. So we are going to first of all see how opening works. So I'm going to define a variable called opening, and then I will call cv2.morphologyx, okay, and then we will provide the source, which is mask. The second method is the type of morphological operation which we want to perform. So in this we are going to just call cv2 dot, and then we can specify which type of morphological operation we want to perform on the image. So just write morph and then the type of operation. So we want to perform the morph open for the opening, right? And then the third argument here is the kernel which we have defined, And now we are going to just add this opening to our matplotlib window. Let's add this, and then let's do 5 here, and then let's say our matplotlib is going to show these images in a 2:3 format. Okay, so let's run this code and let's see what happens. And let me increase the size of this image now, and this is the result of the opening. So what is opening in morphological transformations? So opening is just another name of erosion followed by dilation. So when you perform this opening morphological operation, first of all, erosion is performed on the image, and then the dilation will be performed on the image. So you can see the effect of the erosion followed by the dilation. Still you see some spots here which can go if you can just increase the size of this block. So let's rerun the code. Let's see what happens. So now this image somehow looks better than the older image. So opening is the erosion followed by dilation. Now there is a closing method also, which is just the opposite of opening. In the closing morphological transformation, dilation is performed first on the image and then it is followed by the erosion. So let's see if we get the better result when we perform the closing morphological operations, and the morphological operation here will be close. And run this code, and now you can see the result here. So in closing, as I said, first of all the dilation is applied and then the erosion is applied. In the opening, first of all erosion is applied and then the dilation will be applied. Now there are different type of morphological operations you can apply using this morphology X. So for example, I'm going to just use some of them. So the main morphological operations other than opening and closing is, let's say, morphological gradient. So I'm going to just say mg for morphological gradient, and you just need to change the second argument here. So cv2 morph underscore morphological gradient. So we are going to just call this morph gradient, and it's going to apply the morphological gradient. And then the next is the top hat and the black hat. So there are different morphological techniques you can apply. So I'm going to show you one more and then I will leave you with the other techniques. So th for top hat, and here also the second argument you just need to change it to top hat, right? Otherwise you can see there are so many number of techniques you can apply on your image. So there is gradient, close, open, we have already seen, black hat, cross, dilate, ellipse, erode, hit miss, rect, and then top hat, which is we are going to use right now, right? And then we can just add these two things to our list of titles and list of images. So mg, and then we have th for top hat, and now we have 8 images, so range is increased to 8, and let's say we just want to show them in 2:4 matrix here in the matplotlib window. So you can see this is the result of morphological gradient. So morphological gradient is the difference between the dilation and erosion of an image, and this is the result of top hat. That means it is the difference between the image and the opening of an image. So this is how you can perform some of the morphological operations on the images. Now I will show you one more example. I have an image called j.png. So I'm going to just load this image also, and because this j.png is already a binary image, I don't need to apply this mask here. So instead of this mask, I can just directly use our image variable. So I'm going to just write this, and let's load this image 2 times because we already have defined this mask variable inside our title list and image list. And now I'm going to just run this code. So the original image of this j.png looks like this, and after we applied the dilation, you can see the dilation increases the area of this j. The erosion just erodes away the corners of this j, right? Opening is going to apply the erosion first, followed by the dilation, and closing is going to first of all perform the dilation followed by the erosion. This morphological gradient is going to give you the difference between the dilation and erosion of the image. So it's going to give you this kind of result, and you can see the top hat result here, which is the difference between the input image and the opening of the image. So this is how you can use different type of morphological transformations on your images using OpenCV. I hope you've enjoyed this video, and I will see you in the next video. Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video, we will discuss about smoothing or blurring images in OpenCV. So smoothing, which is also known as blurring, is one of the most commonly used operation in image processing. The most common use of smoothing operation is to remove noise in the images. Now, when smoothing or blurring images, we can use diverse linear filters because linear filters are easy to achieve and are also relatively fast. Now, there are various kinds of filters available in OpenCV. For example, homogeneous, Gaussian, median or bilateral filters, which we will see one by one. So first of all, we will see the homogeneous filter. So homogeneous filter is the most simple filter, and in homogeneous filter, each output pixel is the mean of its kernel neighbors. Now in homogeneous filter, all pixels contribute with the equal weight, and that's why they are called homogeneous filters. Now those of you who don't know what the kernel is, I have explained about kernel in the last video, so you can see the last video. And in simple word, a kernel is a shape which we can apply or convolve over an image, and you can use, for example, NumPy to create this kind of squared kernel. So in homogeneous filter, the kernel looks like this image which you see on your screen. So in homogeneous filter, kernel k is equal to 1 by the width of the kernel multiplied by the height of the kernel. So let's say we want to use a kernel of 5 by 5, then using this formula, we will have k is equal to 1 by 25, and then we will have our kernel matrix of 5 by 5 ones. So let's create this kernel first of all, and then we will see how to use this kernel for the image filtering using 2D convolution or homogeneous filter. So what I have right now here is the simple code which loads this image using matplotlib, and this code you might already know because I have explained in detail how matplotlib works and how to read the images using OpenCV. One thing to note here is I'm just converting the image from BGR to RGB because matplotlib reads the images in the RGB format and OpenCV reads the images in the BGR format. So this conversion is necessary. So let's define our kernel. So I'm going to just say kernel is equal to np dot once, and then we are going to take the kernel of 5 by 5. So we are going to define this kernel 5 comma 5 of ones. So I'm going to just say np dot float 32 here, and then we are going to divide this kernel by 25 because our kernel is of 5 by 5, because the formula which we have seen, in that formula we have the kernel which was a matrix of ones, and then we have the multiplication of 1 divided by the width and height of the kernel. So that's why the multiplication of the width and height is 25. That's why I have taken 25 here. So now we have our kernel, so we can define our destination image using this kernel, and we are going to use cv2 dot, there is a method called filter2d which we are going to use, which is used for this homogeneous filter. So here the first argument is the image. The second argument is the desired depth of the destination image. So for now we are going to take it as -1. The third argument is the kernel. So now when we have applied this kernel on our image using 2D filter, let's see what the output will look like. So I will name this image as 2D convolution, and the destination is the final image which we got using filter 2D. And let's increase this range by 2, and let's say we want to show this image on matplotlib in 1 by 2 format. Okay, so I'm going to just run this image. So this is the result. On the left hand side is the original image, and on the right hand side is the 2D filter applied image. So this is the image which we got by applying the homogeneous filter using filter 2D function. So you can see on the corners here there is a little bit noise, and after applying this 2D convolution over this image, you can see all the corners are now smoothened, and overall this image is now smoothened or blurred a little bit. So these noises are removed or suppressed by this blurring. So this is one way of blurring an image using filter 2D, right? Filter 2D function. Now, as in one-dimensional signals, images also can be filtered with various low-pass filters or high-pass filters, etc. So low-pass filter helps in removing the noise or blurring the image, etc. And high-pass filters helps in finding edges in the images. Now, when you want to achieve image blurring, we need to convolve over the image with the low pass filter kernel. Now, there are some algorithm. As I said, there are various kind of algorithm available in OpenCV. So we will also see them one by one. So first algorithm is the blur method, or it's also called the averaging. So what I'm going to do is I'm going to define a variable called blur, and then I'm going to call a method called cv2 dot blur. Okay, so this is the method which we will use to apply averaging algorithm for blurring the image, and this takes two arguments. One is the image and second is the kernel. So the kernel we are going to apply is once again 5 by 5, and now we are going to just see the result of this blurring method. So we are going to just load it using the matplotlib. So range, I'm going to increase it by 1 once again, and let's see this these three images in 1:3 format on the matplotlib window. So this is the result, and you can see the original image, the result which we got using the filter to the method, and the result we got using the blur method, which is also called averaging. So the result is more or less looks the same to me, because we have applied the same kind of kernel to both the functions. So this is the result of filter 2D function, and this is the result of the blur function. Now there are more functions which are available in OpenCV, so let's see them. So the next algorithm which we are going to see is the Gaussian filter algorithm. So the Gaussian filter is nothing but using different weight kernel in both x and y direction. So in the result, pixels located in the middle of the kernel have the higher weight or bigger weight, and the weights decreases with distance from the neighborhood center. So pixels located on the side have smaller weight, and the pixels located on the center have the higher weight. So when we take a 5x5 kernel, its result is going to look like this, which is shown in the image. And now let's see how we can use this Gaussian blur in our OpenCV code. So I'm going to remove this semicolon which I somehow added here, and let's declare a variable called g blur for Gaussian blur, and then we are going to use cv2 dot Gaussian blur. So the method name is Gaussian blur, and the argument here are same as the blur method. So first argument is the image itself, second argument is our kernel. We are going to take the same kernel of 5x5, and the third argument here is the sigma x value, which we are going to take 0 for now. And let's see the result of the Gaussian blur method when it's applied to an image. So I'm going to just define one more title, which is g blur or Gaussian blur, or let's take this name, which will be more clear. And then our result image is g blur, and let's increase the range to 4, and let's say we want to show this image in 2x2 format, so 2 rows and 2 columns. So I'm going to run this code, and for OpenCV logo, the results looks the same. You can see for the 2D convolution or filter 2D method or blur method, using the Gaussian blur, you can see there is a little bit different between the blur method and Gaussian blur method results. The Gaussian blur result is more better in my eyes than the blur method. Let's try this Gaussian blur method with another image. So I have this image called halftone underscore Gaussian underscore blur, and I'm going to run this code now with the new image, and you can see the result now. So this was the original image, which have too much noise here. So you can see the pixels here which have too much noise, and after applying the Gaussian blur, you can see this eye image in a much better way, and all the noise is removed. So the Gaussian blur method is designed specifically for removing the high frequency noise from the image, like this one. Now let's see the next method, which is called the median filter. So median filter is something that replaces each pixel value with the median of its neighboring pixel. So this method is great when dealing with something which is called salt and pepper noise. Now if you don't know what the salt and pepper noise is, you can open the Wikipedia and under this URL, or just search for salt and pepper noise Wikipedia page, and you can see more details about salt and pepper noise. So you can see this is an image and there are some pixels which are distorted here. So there are some pixels where the white dots are there, or white noise is there, and there are some places where the black noise is there. So that's why it's called salt and pepper, because we have white pixels which are distorted like salt, and we have the black pixels which are which looks like pepper. So that's why it's called salt and pepper noise. So I have this same image which I'm going to use as a source now. So it's called water.png in my case. And now let's see how we can use the median blur method. So I'm going to just define a new variable called median, and then I'm going to use cv2 dot median blur method. So this method is called median blur, where the first argument is the image and the second argument here is the kernel size. Now one thing to note here is that the kernel size must be odd here. So this must be 3 or 5 or 7 and so on, except 1. Okay, so when you just give 1, it's going to show you the original image, and let's say we just give 3 here as the kernel size, or in our case we have the kernel size of 5, so let's take the 5 kernel size here. So let's just show this result of the median filter in the matplotlib window. So I'm going to just increase the range 5, and let's say this is 2 by 3 matrix now, and I'm going to run this code, and now you can see the results of all the filtering method, and you can see the best result you get using the median filter method. So when you have this kind of salt and pepper dots on your images, then you can use the median filter. Now let's see the last filter, which is called the bilateral filter. So by using all these filters, for example homogeneous filter or averaging or the Gaussian or the median filter, we not only dissolve the noise but we also smooth the edges. And sometimes we need to preserve the edges. That means we need that all the edges must remain sharper even if the image is blurred. So let me show you one example. So I have this lena.png image. So I'm going to define a variable called bilateral filter, and then there is a method called cv2 dot bilateral filter, and this bilateral filter takes the first argument, which is the image. The second argument is the diameter of each pixel neighborhood that is used during the filter. So let's take it as a 9. The third argument is the sigma color, and the fourth argument is the sigma space. So the sigma color is the filter sigma in the color space, and sigma space is the filter sigma in the coordinate space. So for this we are going to take this filter sigma color and sigma space as 75 and 75 here, and let's see it in the result window. So bilateral filter, and then the result bilateral filter, and this gives me error because this image is called lena.jpg, not png, so jpg, and then we need to increase this range by 1 to see all the 6 images. And let's run this code and let's see what happens. So you can see the result now. So let me make it a little bit bigger so you can see them, and from here also. So now you can see by applying the bilateral filter, the edges are preserved in a much better way. So here you can see the hat border is blurred, but here you can see in the result the border of the hat are preserved. So the images in which you need to preserve the borders, then you can use the bilateral filter. So bilateral filter is highly effective in noise removal while keeping the edge sharp. So these are some of the methods and algorithms you can use to smoothen or blur your images using OpenCV. I hope you've enjoyed this video, and I will see you in the next video. Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video, we will talk about image gradients in OpenCV. So first of all, what is an image gradient? So an image gradient is a directional change in the intensity or the color inside the image. Now the image gradient of an image is one of the fundamental building blocks in image processing. For example, we use image gradients inside the image to find the edges inside an image. Now there are several image gradient methods available in OpenCV, and we are going to see three of them. First is the Laplacian derivatives, second is the Sobel X method, and third one will be the Sobel Y methods. And all these methods which I mentioned are different gradient functions which uses different mathematical operations to produce the required image. So the Laplacian calculates the Laplacian derivatives, whereas Sobel method is joint, Gaussian and differentiation operations. But don't be overwhelmed with the details. You just need to keep in mind that these are just the functions which we use for finding out the gradients of an image to analyze the image. So let's use the first method, which is called the Laplacian gradient. Now to start with, I have this initial code, and you might already know what this code is doing. So first of all, I'm just reading this image messy5.jpg in the grayscale mode using the imRead method, and then I'm just loading this image using the matplotlib window. So let's first see how the result looks like. So this is going to look like this. This is just a normal image of Messy. And let's see how we can apply the Laplacian method to find out the Laplacian gradient of an image. So for that, we are going to declare a variable called lap, and then there is a function available inside your CV2 library, which is called Laplacian. And this Laplacian method takes few arguments. First argument is the image. The second argument here will be the data type, which we are going to use, which is called cv2 dot cv underscore 64f. So cv2 dot cv underscore 64f is just a data type, and we are using a 64-bit float due to the negative slope induced by transforming the image from white to black. So you just need to keep in mind that this is just a data type which is 64-bit float, and it supports the negative numbers which we will be dealing with when the Laplacian method is run on our image. Now in the next line, what we are going to do is we are going to take the absolute value of our Laplacian image transformation, and we are going to convert this value back to the unsigned 8-bit integer which is suitable for our output. So I'm going to just write lap, and then using the numpy uint method, so np.uint8, and as an argument we are going to pass np.absolute, and then inside the absolute method we are going to just pass our image, which is going to give us the absolute value of our Laplacian image transformation, which is going to convert this into the unsigned 8-bit integer. Now let's see the result of this Laplacian gradient. So I'm going to just add a new title to my title array, which is called Laplacian, and also inside the images list I'm going to add this lap variable which contains this image right after the Laplacian gradient is applied here, and here the range will be 2, and we are going to see it in 1/2 format on the matplotlib window. So here you can see the original image, which is this one, and after the Laplacian gradient method is applied on this image, you can see all the edges which are detected by this method when we applied this method on this messy5.jpg image. And an image gradient, as I said, is the directional change in the intensity or the color in an image. So let's close this window, and there is one more argument you can provide here, which is the kernel size. So you can just say k size is equal to 5. This is the kernel size, and I'm going to just run this program once again, and you can see the kernel size is increased, but our result is deteriorated, right? So let's reduce it to 3, and then once again run this program, and the result looks fine. And if you apply k size is equal to 1, let's see the result, and you can see you get the better result, I think. So for now I'm going to just use k size is equal to 3, and now let's use the other two image gradient methods, which are sobelx and sobely. So these methods, which are called sobelx and sobely, are also called Sobel gradient representation. So let's just use them, and then we will discuss how they are useful. So first of all, I'm going to declare a variable called sobelx, and then I'm going to use the method inside this CV2 library, which is called sobel. So this is the method which takes again few arguments. First is the image, second is again this data type, which is cv2 dot cv underscore 64, and the third argument here will be the dx. So when you write 1 here, this value can be 1 or 0. So when you write 1 here, that means we want to use the sobelx method, okay? And then the fourth argument here is the dy value, okay? So this is dx, which is for the x direction, and this is for the dy, which is for the y direction, and dx stands for the order of derivative x, and the dy stands for order of derivative y. Now once again we are going to declare the sobel y variable. So let's declare the sobel y, and then cv2 dot sobel, and this also takes a few arguments. Here the difference will be only the third and fourth argument, so I'm going to just use the second argument same. The third argument will be 0 for sobel y, and the fourth argument will be 1, right? So this is the order of derivative x. If it's 1, this is called the order of derivative, which is in the x direction, and in the second case it is in the y direction. And the fifth argument here can be the k size, as we have seen in the Laplacian method. So if you want, you can provide the kernel size also here as the fifth argument, but we are going to skip it for now. Now again we are going to convert these values into the unsigned int, as we have done in the case of Laplacian. So what we are going to do is we are going to once again overwrite this variable Sobel x, and then we are going to use np dot u int 8, and in the parenthesis we are going to just write np dot absolute, and then we are going to just pass the value inside the Sobel x variable. Same we are going to do with the Sobel y variable. And now let's see the result, how the result looks like. So I'm going to just add these elements inside the title and the image list. So let's add Sobel x and Sobel y here and here also. So Sobel y, and now let's increase the range to 4, and let's see it in the form of 2 by 2 matrix on the matplotlib window. So I'm going to just run this code, and you can see the result here. So original image, Laplacian gradient, and then Sobel x and Sobel y. So you can see when you apply the Sobel x gradient method, the direction or the change in direction in the intensity is in the x direction. And when you apply the Sobel y method, the change in direction in the intensity is in the y direction. So this is like horizontal and this is in the vertical direction. I have one more image which will illustrate this Sobel x and Sobel y gradient method in a better way, I think, and this is called Sudoku. So I'm going to just write sudoku.png file, and hopefully I didn't do any mistake in the naming. Yes, it works. So you can see the Laplacian result here, and then Sobel x and Sobel y result here. So in the Sobel x you can see more vertical lines, so because Sobel y is good for the directional change in the vertical direction, so you can see more change in intensity in the vertical direction, and using the Sobel y you can see the directional change in the intensity in the horizontal direction or the y-axis. You can also combine the result of Sobel x and Sobel y images, and how we can do this, let's see. So to combine these two result, I'm going to just create one more method which is called Sobel combined is equal to cv2 dot, we are going to use the bitwise OR operator in order to merge these two images. So we are going to just write bitwise OR, and then we are going to provide the two sources. One is Sobel x and the other is the Sobel y image. So this is going to give us the bitwise OR result of these two images, and then we are going to just add this into the title list. So let's say Sobel combined, and also in the image list, so like this, and let's just increase the range to 5, and let's see it in the form of 2 by 3 on matplotlib. So I'm going to just run this once again, and you can see the result now. So this here is the combination of Sobel x and Sobel y method, and you can see now, you can see the directional change in the vertical as well as in the horizontal direction, because this is the combination of Sobel y and Sobel x images. So this is how you can use the image gradients inside OpenCV. In the next video we are going to see how we can use Kenny edge detection method to find out the edges in an image. So stay tuned and please rate, comment and subscribe, and I will see you in the next video. Hey guys, welcome to the next video on OpenCV tutorials for beginners using Python. In this video, we will talk about Kenny edge detector in OpenCV. So first of all, what is Kenny edge detector? So the Kenny edge detector is an edge detection operator that uses multi-stage algorithm to detect a wide range of edges in images. Now this Kenny edge detector was written and developed by John F. Kenny in 1986. That's why it's named after his name, which is Kenny edge detector. Now the process of Kenny edge detection algorithm can be broken down in 5 different steps. The first step is to apply Gaussian filter to smooth the image in order to remove the noise. The second step is to find the intensity gradients of the image. The third step is to apply the non-maximum suppression to get rid of spurious response to edge detection. The fourth step is to apply double threshold to determine the potential edges, and the fifth step is to track edges by hysteresis. That is to finalize the detection of the edges by suppressing all the other edges that are weak or not connected to strong edges. So this seems little bit complicated, but in OpenCV it's really simple to use. So there is a built-in function in OpenCV which is called Kenny, and we are going to use this function. So to start with, I have this sample code which loads this image which is called messy.jpg using the matplotlib library. I'm going to just run this to show you the result. So this is the image, and we want to detect the edges of this image. So what we are going to do is we are going to first of all declare a variable called Kenny, and then there is a method, as I already said, inside your CV2 library which is called Kenny method, which takes few arguments. So the first argument here is the image source itself. The second argument and the third argument, as you can see, is the first threshold value and the second threshold value. So this first threshold value and the second threshold value you need to provide for the hysteresis procedure. So there is the last step, as I mentioned, and in that step hysteresis take place, and for that procedure we need to provide the values of the threshold 1 and the threshold 2. So for now I'm going to provide 100 as the threshold 1 and 200 as the threshold 2. But later you might want to add a track bar in order to see the changes in the edges when you just move the track bar from left to right for the threshold 1 and the threshold 2. So this might be a small assignment for you. You can just add the track bar and see how the edge detection changes when you change the value of threshold 1 and threshold 2. And I have already explained how you can use track bars with OpenCV. So just watch that video and you will be good to go. So now we have the result of Kenny edge detection function. So we are going to just add it to our list, first to the list of titles and then second to the list of images, and the range we are going to increase it to 2, and this we are going to just see the images in 1:2 format. So I'm going to just run this Python script and see the result. So you can see we have the original image here which we have loaded in the grayscale, and on the right hand side you can see the result of the Kenny edge detection methods. So you can see all the edges which are available here on this messy5.jpg image. You can use this on the other images also. So for example, I have the lena.jpg image. Let's see the result of that, and this is the result of the Kenny edge detection method on this lena.jpg method. So this Kenny edge detection is really useful because in the last video we have seen how to find out the image gradients, and let's see in comparison to those image gradient methods how Kenny edge detection method performs. So these are all the methods I have explained in the last video: Laplacian, Sobel X and Sobel Y, and I have shown you how to combine the result of Sobel X and Sobel Y. And additionally I have added this line to the previous code which I have shown you in the last video, which is edges is equal to cv2.kenny, which gives us the result on the same image using the Kenny edge detection method, and I have added it to the title and the image, right? So let's run this script once again and let's see the differences in the result using all these methods. So you can see all the 6 results. This is the original image, this is the result of the Laplacian method, this is the result of Sobel X, and this is the result of Sobel Y, and this is the combination of Sobel X and Y. And you can see Kenny edge detection gives us the result which contains lesser noises. So you can see there is a lot of noise present in the other methods. You can see here all the noise is present which is removed using Kenny edge detection, or in the Laplacian method also you can see some noises around, but in the Kenny edge detection method you can see you get the proper edges and more precise edges without any noise. So this is the benefit of using Kenny edge detection. So this is how you can use Kenny edge detection in OpenCV. I hope you enjoyed this video, and I will see you in the next video. Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video we will discuss about image pyramids in OpenCV. So till now, normally when we have used images, we have used the images of constant size, but sometimes we need to work with the images of different resolution. So for example, if I have an image and I want to search the face inside an image, this face can be of different sizes. So using image pyramids, we just create the images of different resolutions, and then we search for the object, for example face, in all of these images. So pyramid or pyramid representation is a type of multi-scale signal representation in which a signal or an image is subject to repeated smoothing and subsampling. So a normal pyramid, when you create a pyramid of images, it will look like this. So let's say this is the original image at the bottom. Then when you downscale an image using a pyramid function, it's going to give you this image which have the half resolution than the original image, and then when you further go up, it's going to give you the 1/4 of the original image, and then so on. So 1/8 or 1/16 of an image. Now there are two types of image pyramids which are available in OpenCV. First is called Gaussian pyramid and second is called Laplacian pyramid. So first we will discuss about the Gaussian pyramid. So Gaussian pyramid is nothing but repeat filtering and subsampling of an image. Now there are two functions available for the Gaussian pyramid, which is called pyr down and pyr up. So let's see them one by one. So I have this sample code which is just reading an image and then showing it using the IAmShow method. Now in order to use this pare down function, you can just define a variable, let's say LR for lower resolution, and then you can use cv2 dot pare down. So there are two functions you can see, pare down and pare up. So first of all we will see pare down, and then we are going to pass our image as an argument here. So I'm going to just pass our image as an argument, and we are already showing the original image, and let's show the image after we have reduced the resolution of this image using the pare down method. So pare down is going to reduce the resolution of an image. So I'm going to just use LR here, and let's say this is the pare down 1 image. Okay, so let's run this code and let's see what happens. So you can see this is the original image, and this is about, you can see 1/4 of this original image, right? So this pare down method is going to reduce the resolution of an image. When you apply the same method on the second image, so let's say this is LR1, and then we create a second variable LR2, and when we pass LR1 as an argument for this method to create the LR2 image, then let's see what happens. So this will be LR1, and let's just say this is going to give us LR2. The resolution of image will reduce further. So let's see what happens. So this was the original image, this was the image which we got from the first pare down method, and then we get this image which is further reduced in resolution. So this is the image after applying the pare down method second time on the LR1 image. Okay, so you can see the resolution of image is reducing, and it's creating a kind of pyramid, and that's why it's called the image pyramid. Now there is a method called pare up also available in OpenCV. So let's see what this pare up method do. So as you can expect, it's going to increase the resolution of the image. So here I'm going to just say HR for higher resolution, and then I'm going to just say cv2 dot pare up. Okay, and it's going to increase the resolution of an image. Now let's say we want to increase the resolution of this image, which is the smallest image which we got using the pare down method, right? So we are going to apply the pare up on the last image which we got using the pare down method, and let's see what happens. So when I'm going to use this HR2 here, and this we got from pare up method, and let's say this is the pare up 1, and I'm going to just run this code, and you are going to see that we have converted this image, which was the smallest image, to a higher resolution, which resulted in this image. But when you see this image carefully, so let me just move this to this side, and this was the original image. So let me just minimize this. So this image we have converted to this image using the pare up method. So ideally this image should look like this, but you have to remember that this pare up image is not going to be equal to this image, because once you decrease the resolution using the pare down method, you lose the information about that image. So when you use pare up to just increase the resolution of this image, then you can see the result looks little bit blurred because some of the information is loosed using the pare down method. So you have to keep this in mind that when you want to increase the resolution after you have reduced the resolution, you're not going to get the same result as you might expect that this image should look like this, but they are not equal images. So this image is just a higher resolution of this image and it has nothing to do with this image. So these are the two methods which are available in Gaussian pyramid. Now if you want to create a pyramid of multiple resolution, instead of just using this pair up or pair down method repeatedly, what you can do here is, I'm going to just remove this and remove this code also. So what I'm going to do is I'm going to copy the image into a new variable. So I'm going to just say layer is equal to img dot copy. There is a method available for copying the image, which is copy, and then I'm going to create the Gaussian pyramid array. Okay, so I'm going to just create a variable called gp for Gaussian pyramid is equal to, then in square bracket I'm going to just pass this image here as the first element of this list. Then what I can do is I can use a for loop instead of just rewriting this pair down method again and again. And you might already know how to use for loop in Python. So for I in range, and here we can provide any range. So let's say we want to create 5 image pyramid. Okay, so 5 times we want to reduce the resolution. So we are going to give 6 here, because range goes the number minus 1. So whatever you give here, minus 1, right? So now what we are going to do is we are going to just use our layer parameter once again, and then we are going to just call cv2 dot pair down method. So pair down, and then we want to just say layer. Okay, and then we want to append to the Gaussian pyramid list. Okay, so we are going to just say gp dot append, and we are going to append the result of this pair down to our list which we have created here. Okay, so this is going to just append this image to our list of images, and then let's just show this image using cv2 dot imshow method. So cv2 dot imshow, and here we can just say str for converting the integer to the string, because the first parameter you give to imshow is a string parameter. That's why I'm converting the integer to the string, and the second parameter is the image. So let's pass this layer here. Okay, so you have the original image which will be shown using this line of code, and then you will see multiple number of images of different resolution using this code. So let's run this code and let's see what happens. So I'm going to run this code, and you can see there are different images resulted using that code which we have written. So this was the first image, which is 0, and then this is the second image, and then this is the third, fourth, fifth, and sixth. So sixth, you can see, have a very small resolution. So this is how you can use pair down method multiple times using a for loop. Now what are Laplacian pyramids? So Laplacian pyramids are formed from the Gaussian pyramids. There is no exclusive function for creating the Laplacian pyramid. So as you have seen that in Gaussian pyramids, there are two methods available, pair up and pair down, but there is no exclusive function for creating the Laplacian pyramid. So how we can create a Laplacian pyramid if there is no function available for creating them? So you can create a Laplacian pyramid, or a level of Laplacian pyramid is formed by the difference between that level in the Gaussian pyramid and the extended version of its upper level in the Gaussian pyramid. So this definition might be confusing to you guys. So let me explain you with the code what I mean by this definition. So what I'm going to do is, first of all, I'm going to take the top level layer of the Gaussian pyramid. So top level layer of the Gaussian pyramid is the last image which is generated using this for loop. So let's say we have 6 images or 5 images using this for loop. So what we are going to do is, because we have appended each and every image to this list, right? So we have all the images inside this list, so we can just get the last image using the indexing. So again, I'm going to use the layer variable, and then I'm going to just say GP for Gaussian pyramid list, and then there is the index 5, because last image will be available at the index 5 of this list. So we get the last image of that Gaussian pyramid, and then let's show this image. So I'm going to just say cv2 dot show, and this is the upper level or the last image. So I'm going to say upper level Gaussian pyramid, and then we are going to pass this layer variable here. So this is going to show just the last image of this list, and let's just comment this code out because we don't want to see all the images. And then I'm going to create a new list for Laplacian pyramid. So I'm going to just say LP for Laplacian pyramid, and then I'm going to create a list using the layer variable itself, as we have done for the Gaussian pyramid list also. So the first element here is the layer variable itself, and now we are going to use the for loop, and then I in range. And this time what we are going to do is, you might already know how to use the range function, and if you don't know, you can see you can give the stop integer here, or you can give multiple parameters here. So you can see there is one more implementation of this range function. So you can give the start parameter and the stop range. So start is the starting point, stop is the stopping point, and also you can give the steps. So this step means in what number you want to reduce. Okay, so let's say we want to start from 5, and then we want to go until 0, and we want to reduce in the step of -1. Okay, so 5 4 3 2 1. So let's print the value of I first of all, if you might be interested in the result of this range function. Then let's just run this code, and let's see what happens. So this is the images which we get, but we are not interested in these images, we are interested in the print function output. So you can see the output of this print function code is 5 4 3 2 1. As I said, the lower limit is not reached. So if you give 0 here, then it's going to go until 1 and not 0. If you give 6 here, then it's going to go until 5, not 6. So let me repeat the definition of Laplacian pyramid once again. So Laplacian pyramid is formed by the difference between that level in the Gaussian pyramid and the extended version of its upper level in the Gaussian pyramid. So let's first create the extended version of that level. So we are going to just create a variable called Gaussian extend or extended, and then we are going to extend the level of that image which are there in the Gaussian pyramid list by using cv2.pair_up method. And here what you need to give is the Gaussian pyramid list, and then we just need to get the index I from this. So this line gives us the extended version of the upper level in Gaussian pyramid. Now let's create the Laplacian pyramid. So Laplacian is equal to cv2 dot subtract, because we want to find out the difference between that level in the Gaussian pyramid and the extended version of its upper level. So I'm going to just say GP for Gaussian pyramid, and then we are going to just say I minus 1 as the first parameter, and the second parameter is the extended version of the Gaussian upper limit. And now we can use the IAmShow method to show all these Laplacian images. So I'm going to just say cv2.IAmShow, and once again I'm going to use str function to convert from a number to string, and then in the next parameter I'm going to just pass the Laplacian parameter here as an image source. So what do you think? Will this code work? So let's see what happens when we are going to run this code. So you can see the Laplacian pyramid looks just like the edge detection. So all the edges are shown here on every image. This is the first level, this is the second level, third level, fourth, fifth level. So these images are called the Laplacian pyramid. Now what is the use of creating those Laplacian pyramids or the Gaussian pyramids? So the Laplacian and Gaussian pyramid helps us to blend the images and the reconstruction of the images. So these are the two benefits of creating those Laplacian and the Gaussian pyramids. So in the next video, we are going to see how we can blend the images, or how can we reconstruct the images using the OpenCV and the image pyramids. So stay tuned, and I will see you in the next video. Hey guys, in this video I'm going to show you how you can create a standalone executable file using your Python scripts. So let's say I have a project and it contains some Python scripts or a Python script, and let's say I want to convert this test.py into an executable file. So on Windows it will be .exe file, or on Linux it will be a binary file which I can execute by double clicking. So for that, for converting your Python scripts into an executable file, we can use a utility called PyInstaller. So you can see there is a website called pyinstaller.org, and you can find more about this PyInstaller utility on this website. And PyInstaller is a Python application which creates standalone executable file under Windows, Linux, or your Mac operating system. So for using PyInstaller, you need to have pip installed on your operating system. So what is pip? First of all, if you don't know what is pip, you can just go to this website py.org, py.org, and pip is a package management system which is used for the management of the Python applications. So for using PyInstaller, you need pip, and how you can install pip on your operating system. You just need to install Python on your operating system. Pip will be automatically installed with the installation of Python, so you don't need any extra step to install this pip on your operating system. So if the Python is installed, the latest version, then pip is going to work. I have already created a video about how to install Python on your Windows operating system, let's say. So I will just put the link in the description so you can see that video and move ahead. So once you have installed Python, you can just open the command prompt, and once the command prompt is open, you can check if pip is installed or not using this command. Just give pip -- version, and if this command gives any useful reply, for example in my case it says pip and the version of pip which is installed on my system and which Python version it's using. So this is the Python version it's using, and this is the pip version which is installed on my system. So once this command works, then what I can do is I can go to the PyInstaller website, and you can see it's a simple command to install PyInstaller. So you just need to give this command pip install PyInstaller in order to install PyInstaller. So let's copy and paste this command, pip install PyInstaller, and then press enter, and it will take a few seconds to install PyInstaller utility using pip. So once this installation command is finished successfully, you can see it's finished successfully on my terminal. What I will do is I will just go to PyInstaller website and see how to use it. So it's a very simple usage of this PyInstaller command. You just need to give the PyInstaller command, and after that the name of your Python script. So let's do that. So what I'm going to do is I'm going to go to this folder where my Python script is there. So I'm going to just restart my command prompt, and once the command prompt is open, I'm going to just copy the path of this Python script, and then I'm going to just say cd and the path and then press enter. Let me just make it a little bit bigger, and let me just move this folder explorer. So in order to convert this test.py script into the executable file, you just need to give this command pyinstaller space the name of your Python script, which is test.py in my case, and then press enter, and it's going to take some time, and you can see some folders and files are created by PyInstaller inside the project folder for you. So once this PyInstaller command is finished, you will see in addition to your Python script, there are a few folders which are created. So the interesting folder for you will be this folder, which is the dist or dist folder. So I'm going to go inside this dist folder, and then I'm going to go inside the test folder. So this name will be the same as your Python script name. So I'm going to go inside this folder, and here you will be able to find an exe file with the same name as your Python script. So because my Python script name was test.py, that's why the executable file name is test.exe file. So let me just double click this file, and you can see when I double click this executable file, it will give me the same output as my Python script is going to give me. So this is how you can convert your Python script into a executable file. So let me also show you the output of the Python script. So let me just clear this console here, and then I'm going to just say Python and then test.py, and you can see the executable file gives me the same output as this command is giving me. Now you might observe one minor issue here, and this issue is you can see there are a lot of dependency files which are created by PyInstaller for just running this test.exe file. So what if I just need to create this test.exe without all these dependencies? So let's go back to my project. So this was the project, and I'm going to delete all these generated files and folders which were created by PyInstaller. And once again, I'm going to give the same command, which is PyInstaller test.py, but I'm going to add one extra flag here, which is --one file flag. So what this flag will do is it's going to just create one exe file without the dependency files. So let me just give this command and let's see what happens when I give this PyInstaller command with one file flag. So now you can see all these folders are recreated, but when I go to the dist folder here, you can see this time only test.exe file is created without any extra dependency, right? So all the dependencies will be bundled with this exe file, and only one file will be created, and this is much better than creating all the dependencies and just transferring all the dependencies to your client or anyone. So let me just double click this also, and you will see it's going to give you the same result. So if you want to create only one exe file without any dependencies, you just need to give this flag, which is --one file, and you will just get only the exe file. Once again, let me just give the cls command to clear the terminal. Now I have one more example for you. So let me show you the second example, and let me go inside this folder, which is tkint project, and let me just run this project. So I'm going to just go back one folder, and then I'm going to cd into the kint_ project, and let me just run this Python script real quick. And this is the output of this Python script. So this is a window which I want to open, and I want to convert this Python script into an executable file. So this Python script uses Kinter for creating this window. So there are some dependencies which you need to import inside your Python script. Now in order to convert this into an executable file, you might already know the answer how to convert it. You just need to give this command PyInstaller space --one file and the name of your script, which is going to create an executable file using this Python script. And once again, when I go inside this dist folder, you can see this main_window.exe file is created. And when I double click on this window, then there is a terminal which is opened first, and then after a few seconds your real application will start. So now the real application, which is this Kinter window, is started now. So you can see a little problem here, which is this terminal window always opens before opening your real application, which is this window. So how can I just remove this terminal, and I just want to open this registration form without this terminal? So there is one more flag which you need to add in order to achieve this. So I'm going to just close these two windows and terminal, and for now let me just remove all these directories. So delete, and let me just clear the terminal. And in addition to your --one file flag, what you need to do is you just need to give one more flag, which is -w. Okay, so PyInstaller --one file space -w, and then your script name, and then I'm going to just press enter, which is once again going to create these directories. So once this command is finished, I'm going to go once again to the dist folder and run my main_windows.exe file, and this time no terminal will open, only your application window will open without opening any console terminal. So you can see only my real application is opening without opening any extra console terminal. So -W is for opening your real application without any console output. Now there is one more thing which I want to show you here is, for example, your project contains some extra dependencies on some extra things which are related to, for example, your Chrome extensions or any other thing. What you can do is you can use a utility called NSIS, which is open source utility. So you can just go to this website, which is nsis.sourceforge.io. I'm going to give you the link in the description, and when you reach to this page, you can see the download button on the right hand side. So I'm going to click this download button, which is going to open this page, and then I'm going to just click on the download link here, and after a few seconds this executable file for NSIS utility will be downloaded on my system. You can see it's about 1.4 megabytes, so it's not a big file, so you can directly install it and then run this executable file. And once you run it, let me just minimize the browser, and also let me just minimize these windows, and this is the installer window. So I'm going to just click next, I agree, and then leave everything as default, next, and this will be the location, click install. And once this NSIS utility is installed, you can just leave this checkbox checked which says run NSIS, which is going to run your NSIS application. So this is the NSIS menu. What you need to do is you just need to click on this link, which is installer based on zip file. So just click on this link, installer based on zip file, and provide the path for your directory. So what you can do here is, once you have created your exe file, so there is this exe file, you can name this folder anything. For example, I will just leave it as a dist folder, and then you just need to convert it into a zip file. So let me convert it to a zip file. So I'm going to just say add to archive, and then I'm going to create a zip file, and then I'm going to just say OK, which is going to create this zip file. And inside this zip file, you already know my exe file is there. So once you have created your zip file, just copy the path of this directory and go to this window which is opened using NSIS, and then just give the path of your zip file. So this is the zip file. I'm going to just give the path of this zip file, and then I'm going to just click on this generate button, which is going to generate, you can see, this dist.exe file. Okay, so once this dist.exe file is created using your zip file, you can test this using this test button. So just click on test, and it's going to open this kind of installation windows. So this dist.exe file you can just give to your clients or your colleagues in order to install this exe file on their operating system. Obviously it should be a Windows operating system. So I'm going to just double click on this exe file, and it will work like a normal installer. Now one thing to note about PyInstaller utility is, if you want to create a Windows exe file, you need to run PyInstaller on your Windows operating system. So if you want to create a Linux binary using your Windows operating system PyInstaller, it will not work. Okay, so if you want to create a executable file, use Windows operating system with PyInstaller. If you want to create a Linux binary, then just run that Python script with PyInstaller using that operating system. So that's it for this video. This is how you can create a standalone executable file using your Python script. I hope you have enjoyed this video, and I will see you in the next video. Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In the last video we have seen what are image pyramids, and I have told you there are two kinds of image pyramids in OpenCV. One is called the Gaussian pyramid and the other is called the Laplacian pyramid. And we have seen in the last video how we can create the Gaussian pyramid and the Laplacian pyramid. Now, in the last video, I have also told you some applications of image pyramids. And one of the application of image pyramids is the image blending. So let me show you one example. So here in this code, I have two images. One is of apple and other is of orange. And I want to blend or merge these two images. So let me just run this code first of all. So you can see there are two images. First is of apple and other is of orange. And I have also printed the shape of these two images. So you can see the shape is similar, 512 by 512, and orange image shape is also 512 by 512. So here what I want to do is I want to blend half of the orange to half of the apple. So let's say I want to just blend right hand side of this orange to the left hand half of this apple. So how can I achieve this? Now you might say that I can just cut these two images into half and then I can stack these two images side by side and I will get the half and half of the two images, and that's how I can just get the result. So let's first of all try this technique. First of all, we are going to just create the half and half of the apple and orange images, and we are going to just stack these images side by side. So let's say I'm going to create the variable called apple underscore orange, and then here there is a method in numpy. So I'm going to just say numpy dot hstack. So there is this method called hstack, and here what I can do is in the form of tuple I can provide the half of my apple image. So apple is the image variable name, and then what I'm going to do is the half of this image, because this image is 512 by 512. So I'm going to just give this kind of expression colon comma and then colon 256, which is the half of the apple image on the left hand side, right? And then I'm going to just do the same with the orange image. So I'm going to just take orange and then colon comma 256 colon. So one thing to observe here is I have taken colon before 256 in the apple image and I have taken colon after 256 in the orange image. And then I'm going to just show this apple orange image, and let's see what result we get when we run our code. So these two are the apple and orange image, and this is the result of adding the two halves of the orange and the apple image. But still you can see this line which is clearly visible, and from this line you can say half of this is orange and half of this is an apple. So in image blending, what we need to do is we need to blend this line also. So the orange and the apple image should be merged or blended in a perfect way. So for blending this half apple and half orange image, what we can do is we can use the image pyramid techniques to blend these two images. Now in order to blend two images using image pyramids technique, we need to follow 5 steps. The first step is to load two images In our case, these images are of apple and orange, which we are already doing. So first step is to load these two images. The second step is to find out the Gaussian pyramid of our apple and orange image. The third step will be, from these Gaussian pyramids, find out the Laplacian pyramids. Okay, so we will find out the Gaussian pyramid in the second step, and then in the third step we are going to find out the Laplacian pyramids. Now in the fourth step, we are going to join the left half of the apple and the right half of the orange in each levels of Laplacian pyramid. And finally, in the fifth step, what we are going to do is we are going to just join these image pyramids and reconstruct the original image. So let's follow these steps one by one and let's see what result we get. So as I said, first step is already done, which is just loading these two images, and the second step would be to find out the Gaussian pyramid. So let me just write this step: generate Gaussian pyramid for apple first of all, and then we are going to find out the Gaussian pyramid of the orange. So first of all, what I'm going to do is I'm going to just copy the apple image. So I'm going to just say apple underscore copy is equal to apple dot copy. So there is a method called copy which you can use to copy this image. So from this copy, what we are going to do is we are going to generate the Gaussian pyramid. So I'm going to once again name my variable as gp let's say underscore apple, and then we are going to just pass our image which we have copied in the form of list. So I'm going to just say apple copy here. So these steps we have already seen in the last video, how to create the Gaussian pyramid and the Laplacian pyramid of an image. So I'm not going to explain this in detail. If you want the detailed explanation, you can see the last video. Next, what I'm going to do is I'm going to create a for loop, and I'm going to just say for I in our range. So I'm going to use the range function, and we are going to use the 6 levels in this example. So I'm going to provide the range up to 6, and then what we are going to do is we are going to just say apple copy, or you might have named this variable as apple layer also, because we are just creating multiple layer of the apple image for the Gaussian pyramid, right? And then we are going to use the cv2.pairDown method to create the Gaussian pyramid. Okay, this we have already seen in the last video. And now as an argument, we are going to pass our apple copy variable here. And in the next step, what we are going to do is we are going to just append to our gp underscore apple variable, which is our Gaussian pyramid for the apple image, and then we are going to just append this apple copy after we have applied pairDown method on the same image. So this is just giving us multiple layer of the apple image, right? The same method we are going to apply for the orange also. So I'm going to just copy this code, and then I'm going to just paste this code once again, and this time this will be for orange, and I'm going to just say this is the orange copy, and we are going to copy from the orange image, and then we are going to just generate the Gaussian pyramid for the orange image, and this will be passed here, and also here, and also here, and also here, and this Gaussian pyramid orange will be passed here. Okay, so we have generated the Gaussian pyramid for the apple and the orange. Now we are going to generate the Laplacian pyramid for apple and orange. So this also we have seen in the last video. So I'm going to just comment generate Laplacian pyramid for apple first of all. And to find out the Laplacian pyramid for the apple, what we are going to do is we are going to once again take our apple copy, and then using our Gaussian pyramid. So let's take Gaussian pyramid for the apple, and we are going to use the fifth element of this list. So what we have learned in the last video, how we can find out the Laplacian pyramid. A level in the Laplacian pyramid is formed by the difference between the level in the Gaussian pyramid and extended version of its upper level in the Gaussian pyramid. So this difference we are going to find out in this step. So I'm going to just say this is LP for the apple, which stands for Laplacian pyramid for the apple, is equal to, in the list we are going to just pass the apple copy, and then we are going to use the for loop. So for I in the range, so we are going to take the range, and in the last video I have shown you how to take the range for the Laplacian pyramid. So we want to go from 5 until 0 in the steps of -1, and then in the next step we are going to create the Gaussian extended variables. Gaussian extended is equal to CV2 dot pair up. This time we are going to use the pair up method, and then we are going to pass our GP apple, which is Gaussian pyramid for apple, and then the index here will be I. In the next step we are going to create the Laplacian variables is equal to CV2 dot subtract. So there is a method in CV2 which is called subtract, and then we are going to take our Gaussian pyramid for the apple, so GP apple, and the index here will be I minus 1, and the second argument for this subtract method will be our Gaussian extended variable. So we are going to just pass this Gaussian extended variable, and in the next step we are going to just append to our Laplacian pyramid for the apple. So LP underscore apple dot append, and we are going to just append this Laplacian variable to the Laplacian pyramid for the apple. Same we will do for the orange image also. So we are going to generate the Laplacian pyramid for the orange here, and this will be the copy of the orange copy here and here also, and then this will be the GP orange, right? This also will be GP orange, this also will be GP orange, and here instead of LP apple we are going to just say LP orange, and then we are going to just pass this variable here also. So now we have finished 3 steps. One is to load both the images, second is to find out or generate the Gaussian pyramid, and the third step is to generate the Laplacian pyramid for both the images. Now the fourth step is to just join the half of these 2 images. So what I'm going to do is, now I'm going to just create one more variable which will be apple underscore orange underscore, let's say, pyramid is equal to, and also we are going to create a variable called n, and we are going to see later how to use this variable, and then we are going to use the for loop, and then we are going to create 2 variables, one for the first image. So I'm going to just say apple and then lap comma orange lap. Okay, so these 2 variables I'm creating just same as this I in this for loop in zip. So there is a method zip which we can use to zip the Laplacian pyramid one, which is for the apple and for the orange also. So I'm going to just say LP for apple comma LP for the orange. And inside this for loop, first of all, we are going to just increment the value of n by 1 each time. So n plus equals 1. And in the next step, we are going to find out the shape of the apple image. So the apple image shape gives us 3 values. First is columns, so I'm going to just say COLS for columns, then rows, and then the third value is the number of channels, and then we are going to just say apple lap dot shape. In the next step, we are going to just create a variable called Laplacian, and we are going to just join the two halves of these two images which we are getting inside the variable apple lap and orange lap. So we are basically doing this step after applying the Gaussian pyramid and the Laplacian pyramid on both the images. So np.hStack method we are going to apply in this step. So I'm going to just write np.hStack, and then as an argument what we are going to do is, we in the form of tuple, first of all we are going to take our apple lap variable, which is this one, and in the square bracket we are going to just write colon comma 0 comma int. So we are going to just typecast the number of columns in the apple shape. So this we got from the shape of the apple index, and then divided by 2. So we are going to just dividing the columns into half, and same we will do for the orange lap. So we are going to just say orange lap in the square bracket colon comma int, and then once again in the parenthesis we are going to just say cols for the number of columns divided by 2, and then colon, as we have done in this step also. And at last we are going to just append this Laplacian variable to this list which we have created. So apple underscore orange underscore pyramid dot append, and then we are going to pass the Laplacian variable here. Now the last and the final step is to reconstruct our image. So let's reconstruct our image. So now what we are going to do is, we are going to once again create a variable called apple orange underscore reconstruct is equal to, this will be the first index of our apple orange pyramid. So I'm going to just say apple orange underscore pyramid, and this will be the 0th index, and once again we are going to use the for loop. So for I in the range, so we are going to go from 1 until 6, and the default step is of 1, so we don't need to give the third argument. And inside the for loop we are going to just take this variable once again, and then we are going to apply the pair up method on this. So cv2 dot pair up, and as an argument we are going to pass the same variable. So we are going to just apply the pair up on this apple orange reconstruct from the 0th index of the pyramid up to the 6th level. And the last step will be to add all the layers. So apple orange reconstructed once again, or reconstruct is equal to cv2 dot add. So this is also one method which is called add, and here we are adding apple orange pyramid and the reconstructed apple orange image. Okay, so this is this variable which we got by just adding the left and right halves of each level, and then we are just reconstructing this image using the pair up method, and thus just adding the pyramid level. So this should be, I think, the index I, right? We cannot just add the list to the image directly. Okay, so this will be at each layer we are just reconstructing and adding it to the image which we got by just addition of this half of the images. Now in the end, let's try to just load this reconstructed apple orange image in the I am show window, and let's hope it works. I haven't checked it yet, so I'm not sure it will work or not. And you can see it's working in the first go, so that's a good thing. So you can see the difference. So this result we got by just stacking this apple and orange image side by side, but this line is clearly visible. But when we applied the Gaussian pyramid and the Laplacian pyramid technique for blending the images, then you can see this line is perfectly blended and this line is not anymore visible. So this is the perfect blending of the orange and the apple image. So this is how you can use the Laplacian and Gaussian pyramids to reconstruct and blend two images together, and result is in front of you, so you can see how it can blend two images so perfectly. So this is how you can blend images using image pyramid technique. I hope you have enjoyed this video, and I'm going to see you in the next video. Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video, we are going to understand what contours are, and we are going to see how to find contours and how to draw contours. So first of all, what are contours? So contours can be explained as the curve joining all the continuous points along the boundary which are having the same color or intensity. Now contours can be a useful tool for shape analysis or object detection or object recognition. Now for better accuracy, we generally use binary image for finding the contours. So first of all, we are going to generate the binary image, and then before finding out the contours, we are going to apply the threshold or canny edge detection to find the contours on the image. So let's start with an example. So here I have a simple code which reads an image and then converts this image into a gray scale image, and then I'm just showing both the images using IamShow method. So let's run this code and let's see what result we get. So this is the original image with these colors, and after the conversion of this image to the grayscale image, this is the result which we are getting. And then we are going to find out the threshold or the canny edge. So in this example, we are going to just apply the threshold. So for applying the threshold on this image, we are going to define first of all two variable ret comma thresh is equal to cv2 dot threshold. So there is a method called threshold which we have already seen how threshold work in detail in the previous videos. So the first argument which this threshold method takes is the image. So we are going to pass our grayscale image as the source. The second argument is the threshold value. So because it's a binary image, let's set the threshold to 127, which is around half of the 255, right? The third argument is the maximum value. So the maximum value here will be 255. The next argument will be the type, and type here will be 0. So this is going to give us the threshold value for this grayscale image, and after finding out the threshold of this image, we are going to find out the contours. So for this, we are going to define two variables. One is contours and the second is the hierarchy, because the method which we are going to use, which is cv2 dot find contours, this is the method. It's going to give us these two values, contours and the hierarchy, and we are going to see what are contours and hierarchy in details after applying this method on this image. So the first argument will be the thresh which we got using this threshold method. The second argument will be the contour mode. So this is called the contour retrieval mode also, and there can be several possibilities here which we can apply. But for simplicity and in the most common case, we use retr underscore tree here, okay, as the mode. The third argument here will be the method which we want to apply, and this is also called the contour approximation method. And here also several possibilities are possible, but for now what we are going to use here is this will be cv2 dot approx none. So now as you are seeing here, this find contour method gives us contours and the hierarchy. So the contour is a Python list of all contours in the image, and each individual contour is a numpy array of x, y coordinates of boundary points of the object, and the hierarchy is the optional output vector which is containing the information about image topology, and this we are going to see in the later videos. So for now we are only concerned about finding out the contours. So for this, as I said, this contains the number of contours, right? So we can print out these number of contours is equal to, and then we are going to just convert this number into the string, and there is a method called length, and then inside this length method we are going to pass our contour variable. So this line is going to print out the number of contours which are found inside the image which we are providing. So let's run this code and let's see what result we get. So we already know that this gives us a grayscale image and the original image, but we are interested in this print message, and the number of contours which are found is 9 inside the source image which we are providing here. Now we already found out the number of contours. Now we need to draw these contours on the image itself. So how can we achieve this? But before this, let's see the individual contour also. So I'm going to just print out the value of the first contour, which will be at index 0. So let's run it once again and let's see what happens. So we are running this code once again, and you can see after printing out the number of contours, it's going to give us the numpy array of the x and y coordinates. So if we plot or join all these x and y coordinates, we are going to get the boundary of the contour. So now we are going to just take these contours and pass it to a method called draw contours, which is going to draw or join all these coordinates of those contours. So to get this, we are going to just say cv2 dot draw contours, and then the first argument here will be our original image, because we want to draw the contours on our original image. So this will be the img and it's the original image, and the second argument will be the contours. So we are going to just pass the contours which we found inside the image. The third argument will be the contours indexes. So if we just give here -1, then it's going to draw all the 9 contours which were found inside the image, these all contours. So first of all, we will give -1 here as an argument, and then we will see how to give other arguments as the numbers here also. The fourth argument here will be, I think, the color. So we are going to just give the color 0, 255, 0, let's say, and the next argument will be the thickness. So we are going to take the thickness 3 here. So using this method, what we have achieved is we have drawn the contours on the original image. So let's run this code once again and let's see what result we get. So you can see this was the grayscale image, and this we have used for finding out the contours. But the interesting image here is this one, and here you can see all the contours are drawn on this image. So all the green lines or green boundaries are all contours. So because we have given -1, it has drawn all the contours on this image, and we can also give the contour index. So let's say we just want to find out the contour 0, which will be the first contour which is found inside the image. We are going to just run this code once again, and the first contour which was found out is this contour, this P contour, right? In a similar way, we can go up to 8, so 0, 1, and let's rerun this code again. You will see that the second contour is this contour. So this whole contour from the boundary of this image is the second contour. And in a similar way, you can go, let's say 2. I'm going to run this code once again. You will see the next contour here. And similarly, you can go up to the index 8, because the total number of contours are 9 and we are starting from the index 0. That's why we can go up to 8. So this value depends on the number of contours. Okay, so because we found out the number of contours are 9, so that's why we can go up to 8. And let's run this code. And the last contour which was found out, and we have drawn this contour here on this blue circle, right? Now if we go beyond this index, let's say we give 9 here, we are going to get the error, right? So you can go up to 8 here, and if you want to just draw all the contours, then you can just give -1 here, and it's going to draw all the contours on the image which you are providing. So this is how you can find out the contours and draw contours on the images using find contour and draw contour methods in OpenCV. I hope you have enjoyed this video, and I will see you in the next video. Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video, I'm going to show you how you can create a very basic and simple motion detection and tracking system using Python and OpenCV. So let me show you what we are going to achieve at the end of this video. So I have this video, which is a sample video, and you can see some people are walking around inside this video. Now what I want to do here is I want to show these rectangles around these moving people or persons. So this is tracking, and when some movement occurs, I also want to show this kind of status. That status is movement because somebody is moving inside the video. So if nobody is moving, this status will be blank, and if somebody is moving, then this status will be movement. So this is what we are going to achieve at the end of this video. So we are going to try to track each and every person, and also we are going to track this person with this rectangle, and also we will show the status as movement when somebody moves inside the video. So let's get started. So to start with, I have this basic code which just reads a video using video capture class, and then if this video is valid, then I'm going to just show this frame by frame inside I'm show window. And I'm sure you might be knowing all this code because I've shown you step by step how to capture the video or how you can read the video frames using video capture method. Okay, so this is just to load this video and show it frame by frame using IamShow method. So let me run this code first of all to start with. So our original video looks like this. So some people are moving, but we want to track the movement of each and every person, and also we want to show a rectangle around them, whoever is moving. So let's get started. So under this video capture code line, what I'm going to do is, first of all, I want to read 2 frames from the cap instance. So I'm going to just copy this code and paste it here. So this will be our frame 1, let's say, and similarly I'm going to just read the second frame. So simply we are just declaring 2 frame one after another, okay, and we don't need this code anymore. So first of all, I'm going to declare a variable diff, and using cv2.abs diff method, so absolute difference, we are going to find out the difference between the first frame and the second frame. So this method abs diff is for finding out the absolute difference between the first frame and the second frame. Now once we have the difference, then we are going to convert this difference into a grayscale mode. So we are going to just say gray is equal to cv2 dot convert color, so cvt color, and the first parameter here will be our difference which we have found between the 2 frames. So I'm going to just pass diff as the first argument, and the second argument will be cv2 dot, we are going to convert this bgr color to the grayscale mode. And why we are finding out the grayscale mode of this diff? Because we are going to find out the contour in the later stages, and in the last video we have learned that it's easier to find out the contours in the grayscale mode as compared to the colored mode or the BGR mode. So once we have this grayscale mode, we are going to just blur our grayscale frame. So we are going to just declare a variable called blur, and then we are going to apply the Gaussian blur on our gray variable. So cv2 dot Gaussian blur, the first parameter here will be gray. So let's give this gray parameter which we have defined here. The second parameter here is the k size or the kernel size. So let's say we want to provide the kernel size 5,5, and the third parameter here will be the sigma x value. So we are going to just pass 0 here as the sigma x value. Now we are going to find out the threshold. So we are going to just say underscore because we don't need this first variable, and then the second variable will be thresh is equal to cv2 dot threshold, and the first parameter which it takes is the source. So we are going to pass our blurred image as the source, and then the second parameter here will be the threshold value. So we are going to just provide 20 here, then the maximum threshold value will be 255, then the type will be cv2 dot thresh binary. So in the next step, what we are going to do is we are going to dilate the thresholded image to fill in all the holes. This will help us to find out the better contours. So there is a method called cv2.dilate. So we are going to just declare a variable called dilated, and then we are going to apply this method. So cv2.dilate, which takes few arguments. The first argument will be our thresholded version of the image. The second argument here will be the kernel. So kernel, let's say for now we are going to provide none here. Okay, so the kernel size will be none, and then third parameter will be the number of iterations. So let's provide the number of iterations, and the number of iterations we are going to provide here will be 3. So If it doesn't work, we can increase or decrease the number of iterations. Now in the next step, what we are going to do is we are going to find out the contour. So as you all know that contour or find contour method is going to give you two results. One is the contours and other is the hierarchy. So we are going to just say contour, and the second result we are going to just say underscore because we are not going to use this second result. And then we are going to just say cv2 dot find contours, and we are going to find the contours on this dilated image. So we are going to say dilated. Now the next argument here will be the mode. So the mode which we are going to use here will be retter underscore tree. So I'm going to just write retr underscore tree, which is most commonly used. And then the next argument here will be the method. So the method here will be cv2 dot chain approx simple. And once we have our contours, we are going to just draw the contours because we already found out the contours. So we are going to just say draw contours, and the first argument here will be frame 1 because we want to apply all the contours on the original frame, right? So we are going to apply all the contours which we have found using all these methods on the frame 1, and then the second argument here will be the contour. So you can just give the contours here, and the third argument here will be the contour ID. I can just say -1, which is going to apply all the contours, and the next argument will be the color. So let's say we want to provide the green color. So I'm going to just say 0, 255, 0, and the next will be the thickness. So let's say we want to provide the thickness of 2 here. So now it's going to draw all the contours which we have found with the difference of frame 1 and frame 2, right? And then we are going to just display this frame 1. So we can just say this is our feed, and the result after applying the contour will be saved in the frame 1, which we will display. Now in the next step, what we are going to do is we are going to assign the value inside frame 2 into frame 1. So we are going to just say frame 1 is equal to frame 2, and then inside our frame 2 we are going to read a new value. So we are going to just say ret comma frame 2 is equal to cap dot read. Okay, so we are reading the new frame in the variable frame 2, and before reading the new frame we are assigning the value inside the frame 2 to the frame 1. In this way we are reading the two frames and finding out the difference between the two frames. So let's run this code and let's see if it works or not. Let's test this. So you can see now there are these contours which are drawn around all the moving persons. Also there are some contours which are drawn around this rope which is also moving, right? So we have successfully determined the contours, and we have already drawn these contours on the frame 1. But this was not the result we are looking for. We want to draw the rectangle around these moving persons, and also we want some noises to be removed. So we don't want to draw the contour on the moving rope, let's say. Okay, so how to remove these noises and how to draw these rectangles, let's see. So now in the next step, what we are going to do is, under or before we are drawing these contours, we don't want to draw the contours now. We want to draw the rectangles, right? So what we are going to do is we are going to iterate over all the contours. So we are going to just say for contour. So from contours we are going to find out contour in contours, right? So this is the list and we are iterating over this list. So inside this for loop, the first step will be to save all the coordinates of the found contours. Okay, so we are going to define the x coordinate, then the y coordinate, and then we are going to just say width comma height. And there is a method called bounding rect which we are going to apply on the contour. So we are going to just say is equal to cv2 dot bounding rect. This is the method which we are going to apply, which is going to give us the x and y coordinate and the width and height, right? And we are going to apply this bounding rect method on the contour which we are getting using this contours list. Now in the next step we are going to find out the area of the contour, and we are going to just say if this area is less than certain value, then we don't want to do anything. We don't want to draw a rectangle or anything. We just want to continue. Otherwise, if this contour area is greater than let's say some kind of a person's area, then we want to draw a rectangle on it. So inside this for loop we are going to just define a if condition. So we can say if cv2 dot contour area, so there is a method called contour area, which is this one, where we can pass our contour. So we are going to pass our contour, and if the area of this contour, let's say, is less than 700, then we are going to just say continue. So this code essentially mean that if the area of the contour is less than 700, then we are going to do nothing. We don't want to draw any rectangle. Otherwise, if the area is greater than 700, then we want to draw the rectangle. So we are going to just say cv2 dot rectangle. We have already learned how to draw a rectangle on an image using the rectangle method. The first argument here will be the source, which will be frame 1. The second argument will be the point 1. So we are going to just say point 1 will be x comma y. The third argument will be point 2. So we are going to just say x plus w comma y plus h. The next argument will be the color. So let's say the color will be the same, 0 comma 255 comma 0. The next argument will be the thickness. Let's say we want to give the thickness 2, as we have done with the draw contour. We have provided the thickness of 2 here, right? Now in the next step we are going to just print some text on the image if some movement is observed. So we can just say cv2 dot put text. This also we have seen in the previous videos how to put text on an image. So this time the source will be our frame 1. The second will be the text. So we will just say status, let's say, and if there is some movement, we are going to just say colon in the curly brackets. We are going to just use the format method. So this is just formatting the result using the string, and we are going to just say movement. The next argument here will be the origin. So where we want to put this text. Let's say we want to put this text on 10 comma 20 coordinate, and then the next argument will be the font face. So we are going to just say font face will be cv2 dot font Hershey simplex, let's say. So we are going to use this font, and the next argument will be the font scale. So let me just do this on the next line. So font scale will be, let's say, 1. The next will be the color of the font. So let's say the color will be 0, 0, 255, and then the last argument will be the thickness. So let's say the thickness will be 3, and this code is going to put the rectangle around your moving persons if the area of that contour is greater than 700. Okay, so let's run this code and let's see if it works or not. So I'm going to just run this code, and you can see that status is movement because all the persons here are moving, and you can see these rectangles which are drawn around the moving persons, and this noise which we were seeing in the previous result is also gone around the movement of this rope. Okay, so sometimes this rectangle is drawn on the movement of the rope also. So in this case you can also increase the expected area. Let's say we just want to find out the contours which are greater than 900, and we can now you can see these rectangles are drawn around these moving persons with the area which have the contour area more than 900. So you can remove these kind of noises from the frame using this area. So this was a very basic example how you can detect the motion and track your moving object inside your video using Python and OpenCV. I hope you have enjoyed this video, and I will see you in the next video. Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video, we are going to see how we can detect simple geometrical shapes using OpenCV. So to start with, I have this simple code which reads an image and then show it into IamShow window. So let's run this simple code first of all, and let's see what it does. So you can see I have this image which I'm loading into OpenCV window using IamShow method, and here we have some shapes. So we have a pentagon, circle, rectangle, square, triangle, and this star shape, right? And let's say we want to detect using OpenCV which shape it is based upon the geometrical shape, and we want to write the name on top of this shape. So how we can achieve this, let's see using OpenCV. So as you can see, the first step is to read an image, and then in the second line I'm just converting this image into a grayscale mode image. So using this code I'm just converting this image into a grayscale mode, and in the next step we are going to find out the threshold. So I'm going to just say underscore comma thresh is equal to cv2 dot threshold. So cv2 dot threshold, and we are going to pass our image which is a grayscale image which we have converted as a source, and then the next two values are the threshold values and the maximum value of the threshold. So for now I am giving the threshold value to 40 because I know this will work, but if you want to be more flexible you can always use the track bar to find out which threshold will work with your image. The second value is the maximum value of the threshold, and the next value will be the type. So the type here will be cv2 dot thresh binary. So we are going to just say cv2 dot thresh binary. Now in the next step we are going to find out the contours. So contours we have already seen in the last videos how to find out the contours and what are contours. So for that I'm going to define two variables. One is contours variable, other is the underscore variable because we don't need the second result. And then I'm going to just say cv2 dot find contours the first argument here will be the thresholded image, and then the second argument here will be the mode, and third will be the method. So let's give these two values. So cv2 dot retr tree, and the method will be cv2 dot chain approx none. Okay, so let's give this method. So this is the simple procedure to find out the contours inside an image. Now in the next step, I'm going to iterate over all the contours. So I'm going to just say for contour in contours. So we are going to iterate over all the contours, and then we are going to first of all use a method called cv2.approx polydp. So I'm going to just declare a variable. First of all, I'm going to just say approx is equal to cv2 dot this method which I have mentioned, which is called approx polydp. So this method approximates a polygonal curves with a specific precision, and the first argument which it takes is the curve. So our curve here will be the contour which we have found on the shape. The second argument here will be epsilon. So epsilon is the parameter specifying the approximation accuracy. So here what we are going to do is we are going to define epsilon is equal to 0.01, and then we are going to multiply this number by cv2 dot arc length. So there is this method called arc length, and what does this arc length method do? It calculates a contours parameter or a curve length. So here in this arc length parameter, we are going to pass once again our contour variable, and the second argument here will be if it's closed or the open contour. So in our case, we know that all the shapes which we want to detect are closed, so we are going to just pass through here. And the next argument in the approx polydp method will be once again if it's a closed shape or the open shape. So once again we are going to pass through here because all the shapes which we have are closed shapes. Now once we have this approximation, we are just going to draw all the contours first of all. So we are going to just say cv2 dot draw contours on which image? On our original image. So we are going to draw these contours on the original image, and then we are going to pass the second argument, and this will be our approximation. So we can in the square bracket, this is one other notation of just giving the number of contours as an argument to the draw contours method. So in the square brackets you can just pass the approx. The next parameter here will be the contour index. So because we are iterating over all the contours, that's why the index will always be 0, because there will be only one contour which we are working at a time. So this index will be 0. The next argument here will be the color. So you can give any color here. I am going to give 0, 0, 0, let's say, and then the next will be the thickness. So thickness I'm going to give here is 5. Now the next step is to print out the shape. So which shape it is, we want to print on the shape, which shape it is in simple English, let's say. So for that we need to find out the coordinates on which we want to print this text on the shape. So we need to find out the x and y coordinates. So we can find this x and y coordinates using this approx variable, and we can just say approx dot revvel. So this is a method called ravel, and then the first index here will be the x coordinate, and in a same way we are going to just say approx dot ravel, and on this method the second argument or the second index at index 1 will be the y coordinate. So on these x and y coordinates we are going to print our text. Now in the next step what we are going to do is, so because this approx poly dp is going to approximate the number of polygonal curves, so based upon the number of polygonal curves we can just approximate which shape it can be. So if this approx length, so let's just find out the length of this approx, and if the length of this approx variable is equal to 3, then we are going to say that it's a triangle, because triangle can be made with 3 points. So this length of approx variable, if it's equal to 3, then we are going to say that it's a triangle, because if the number of curves here are 3, then most probably it's going to be a triangle. So if we know that this is a triangle, then we can easily just print or put text on that image. So we are going to just say put text, and the first variable here will be the image. So we are going to put text on the image. The second variable will be the text, and we know that this will be a triangle, so we are going to just say triangle here. And then the next argument here will be the coordinates on which you want to print this text. So we already found out the coordinates at which we want to put this text. The next argument here will be the font, so we are going to just say cv2 dot font Hershey complex, and the next argument here will be the font scale. So let's say font scale will be 0.5, and the next argument here will be the color. So you can give any color. Let's say we just want to print this text in the black color itself, so we are going to just say 0, 0, 0. Then using this logic we can also say that if the length of this approx is equal to 4, then it can either be a square or a rectangle. So here if the approx length is 4, then it can be a square or a rectangle, but we don't know if it's a square or a rectangle. So for now we can just write that it's a rectangle, and we are going to decide if it's a rectangle or a square in the next step, but let's define the other if else conditions also. So this was elif. Similarly, if number of approx points are 5, then we are going to say that it's a pentagon. So we are going to print out the pentagon text on the x and y coordinates, and if the number of points are 10, then we are going to just say that it's a star shape. So we are going to just say star, because in the star the number of points are 10, and then we are going to say that in any other condition, so we are going to just say else, and we are going to just remove this condition from here, else in any other condition it's going to be a circle. Okay, so if approx length is 3, it's a triangle. If approx length is 4, it's a rectangle or a square. If 5, pentagon. If it's 10, it's a star. If it's nothing out of all these options, then it's a circle. You can also find out for example octagon or hexagon. Here if it's 6, it's a hexagon. If it's 8, it's a octagon, and so on, right? Now let's once again come to this step, and in this step we just know that if the number of points are 4, then it's a rectangle or a square. But how can we find if it's a rectangle or a square? So let's decide that now. So what we are going to do for that is we are going to just say x comma y, and then we are going to just say w comma h for width and height. And there is a method called cv2.bounding rect, which is going to give us the x and y coordinates and the width and height of the rectangle, right? So we are going to apply that method. So cv2.bounding rect on our approximate variable or approx variable, which is going to give us the x and y coordinate and width and height. Now based upon the width and height, we can find out the aspect ratio. So we are going to just say aspect ratio is equal to float. First of all, we need to typecast the width into a float. So we are going to just say float w divided by height, and this will be the aspect ratio of the rectangle. Now if this aspect ratio, let's print out the aspect ratio also, so we know what aspect ratio we are getting using the rectangle or the square. And we are going to just say if this aspect ratio is between 0.95 and 1.05, then it's going to be a square, right? Because the width and height are almost same. Okay, so we just give some room for some noises. That's why we are providing here. Ideally it should be a 1, aspect ratio should be 1 in order to have a square, but let's say we are just approximating, so we can just say if it's 0.95, if it's greater than 0.95, and if it's less than, so aspect ratio is less than or equal to 1.05, then it's a square. Okay, in ideal situation you might want to give here 1, but in images it can be a little bit different, so we are just giving this limit. So if the aspect ratio falls in this limit, then it's going to be a square, otherwise it's going to be a rectangle, right? And I'm going to just say that if this is the case, then it's going to be square, otherwise. So in the else condition, so let's give this else condition here, else it's going to be a rectangle. So let's print rectangle in the put text. Okay, so this is the code which we have written. And now finally what we are going to do, we are going to just show the shapes image, including all the contours and the text which we have put on these shapes. So let's run this code and let's see if it works or not. So you can see now it's going to work like this. So all the contours are drawn across these shapes, and you can see the text on top of these shapes. So circle, rectangle, pentagon, star, triangle, and squares. What you can also do here is you can just change this text position using the x and y coordinates. So let's say I just want to change this y position to just little bit top of the shape. So I just added -5 offset here in the y-axis, and now you can see it goes little bit up, this text, right? So now it's much visible, this text. And you can see rectangle and square text is not going up because we have declared the local x and y here also. So we can just say x1 and y1 here, and then run this code once again, and you can see this rectangle and square text is also moved little bit up. So I think the offset of 5 is okay to show these text on top of these shapes. So this is how you can detect simple geometric shapes using OpenCV. So I hope you have enjoyed this video, and I will see you in the next video. Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video, we will discuss about histograms in OpenCV. So what is a histogram? So you can consider histogram as a graph or a plot which gives you an overall idea about the intensity distribution of an image. So let me give you some examples, and then I will be able to explain you better how histogram works and why they are useful. So to start with, I have this example which is a very normal example. Here I'm creating 200 by 200 pixel image using NumPy zeros, which essentially mean that we are going to get a 200 by 200 pixel image of black pixels. So let me just start this example, and you can see this is the final result. So all the pixels here in this image are black, and the size is 200 by 200. Now let's say we want to calculate or find out the histogram of this image. So there are several ways of finding out histogram of an image. So let's see them one by one. So first of all, we are going to find out the histogram using the matplotlib because the plot using matplotlib you can draw easily. So let's use that first of all. So for that, what I'm going to do is I'm going to use PLT because I have already imported this matplotlib library as PLT. So PLT dot hist, there is a function called plt.hist which calculates the histogram of an image. And because it's just a grayscale image, or it's just a black image, so it's easier to find out the histogram. So what you can do here is the first argument here will be your image or your source. So I'm going to just say image dot ravel. Okay, so there is a method called ravel. The second argument here will be maximum number of pixel values. So I'm going to just say 256. The third argument here will be the range. So the range will vary from 0 to 256. Okay, so this is all you need to find out the histogram using the matplotlib, and you just need to show this plot in a matplotlib window. So you can just say plt.show. So that's it. So let's run this code and let's see what happens. So you see this plot using matplotlib and also our original image. So as we have created the image of 200 by 200 pixel of black pixels, so all the intensity of this graph you can see is 0. So you can see here 200 multiplied by 200 is equal to 40,000. So these are the number of pixels. So on the y-axis you will see total number of pixels, and here the intensity. So intensity starts from 0 to 256. So this graph is showing how many number of pixels inside an image which have this pixel values. So in our example, all the pixels inside this image have the pixel value 0. That's why this graph is like this. So all the 40,000 pixels inside the image have the pixel value 0. So you will get this type of histograms. So once again, the histogram is a graph or a plot which gives you the overall idea about the intensity distribution of an image. Now, histogram is just another way of understanding the image. By looking at the histogram of an image, you can get the intuition about the contrast, brightness, intensity, distribution, etc. Now let's improve this example which we have. So I'm going to just close this window, and let's say I want to add some white pixel also inside this image. So what I'm going to say is I'm going to just cv2 dot rectangle. So I'm going to just add the rectangle inside this image, and the source here will be the img variable. Then where I want to introduce this rectangle. So I want to introduce this rectangle at this point, which will be, let's say, which starts from 0 comma 100, and the second point here will be, let's say, 200 comma 200. Okay, so this will be 200, and the next value here will be the color. So let's say we want to add the white pixels. So this will be 255, which will be the maximum value, and then the next argument will be the thickness. So I'm going to just say -1, which will fill this rectangle inside this image. So when I run now this code, you will see this graph and this image. So you can see half of this image contains black pixels and half of this image contains the white pixels, and we already know that the size of this image is 200 by 200. That's why here in the graph you will see 20,000 pixels are black, which means that 20,000 pixels have the pixel value 0, and 20,000 pixels have the pixel value 255. That's why you see this here. So you can see, you can easily find out the pixel intensity of an image easily using histograms. Now next we are going to add some more pixels into this image, and this time what we are going to do is we are going to add the rectangle inside the same image. So let's say it goes from 0 comma 50 to 100 comma 100, and the color here we are going to provide the pixel value of 127, let's say. Okay, so which is the half of 0 and 255 approximately. So I'm going to run this example once again, and now you will see this kind of image. So you can see half of the pixels here are white. That means 20,000 pixels have the pixel value of 255. So you can see here. Now around 15,000 pixels here in the half of this image have the pixel value of 0. That's why you can see this line here, and we have added the rectangle of pixel value 127 also. So around, you can see around 5,000 pixels here have the pixel value of 127. So this is how the histogram is going to work. So let's use now the original image, so some kind of image instead of this black or white image. So now what I'm going to do is I'm going to just once again declare a variable, and then I'm going to just say cv2 dot imread, and we are going to read some file. So let's say I have this lena.jpg image, so I'm going to just read that. I hope the extension is correct, jpg, and we are going to read this image in the grayscale mode. So I'm going to just say 0 here, And now I'm going to run this example once again, and you can see this Lena image is loaded in the grayscale mode, and here is the histogram of this image. So these are all the pixel intensities inside this image. So you can see from this graph that most number of pixels contained inside this image have the pixel value around 150. Now you can also find out the pixel intensity of different colors. So till now we have been just using the grayscale mode or black or white pixels, but you can also use the same histogram for the BGR values also. So let's see how we can do that. So what we are going to do is, let me just remove this code, or I'm going to just leave it commented, and here I'm going to just say B comma G comma R, and there is a method we have already seen which is called CV dot split, which is going to split your image into BGR values. So we are going to just give the source, which is our image, and then if you want to show these BGR values, you can just show in the I'm show window. So BGR, and here also BG and R. And when you want to show the histogram of BGR values, then also you can use matplotlib.hist method. You just need to change this source from image to BGR. So B, G and R. Okay, so now what we are going to do is we are going to run our code, and let's see what happens. So it's giving me this error because I'm reading this image in the grayscale mode. So I'm going to remove this extra parameter from IAMRead, because we want to read this image in the color form, and then only we will be able to get the BGR channels, right? In the grayscale mode there are no BGR channels. So I'm going to run this script once again, and let's see what happens. So you can see this histogram of blue channels and green channels and the red channels, and these are the images which are loaded in these different channels. So this is the image which is loaded in the blue channel, and this is the green, and this is the red channel, and you can see the histogram of each channel differently using matplotlib. So let me just close all these windows. Now there is a method in CV2 also, which is called calc_hist, which is going to give you the histogram of an image. So for that, what you can do is, I'm going to just comment all this code, because I just want to show how you can use the CV2 calc_hist method. Okay, so what you can do is you can use a method. So let's say hist and then cv dot calc_hist, and this method takes few arguments. So the first argument here will be the image. So it's the source which you give, but the only special thing is you just give this image in the square brackets. Okay, the second argument here is the channels. So it is the index of channels for which we calculate the histogram. So here in our case, because we are going to read the image in grayscale mode, we can just give the channel 0 here. So for one channel you can give 0 here, for different channel you can give 0, 1, 2 value. The next argument here is the image mask. So to find histogram of full image, it is given as none because our image is loaded in the grayscale mode, so we can give here none. The next value is the hist size. So this hist size is the representation of bin counts, and this is also given in the square bracket, so we are going to just say 256 here. The next argument is the range. So range will vary from 0 to 256, so minimum and the maximum range of the x-axis, you can say, so 256. And then we can just show this hist or histogram inside the plt, so plt.plot method, so dot plot, and then we can just give this histogram value here. Okay, so let's run this code and let's see what happens. So you can see you get the histogram of this image using the OpenCV calc hist method. And what are the uses of the histogram? So a histogram can tell you whether or not your image has been properly exposed. So when you take a digital image, it's very useful. It can also tell you whether the lighting conditions were flat or harsh when you took that image. And using the histogram, you can also make the adjustments which will work best for your digital images. So this the usefulness of the histograms we will see in the later videos. This was just the basics about the histograms in OpenCV. So I hope you have enjoyed this video, and I will see you in the next video. Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video, we will discuss about template matching in OpenCV. So first of all, what is template matching? So template matching is a method of searching and finding the location of a template image inside a larger image. In OpenCV, there is a method called match template for achieving this purpose. So let's get started and let's see an example about it. So I have this simple code which just loads this image, and let's see what this image looks like. So this is the image, and this is the messy image, and what I want to do is I want to match the face template which I have, which looks like this, which is the smaller template which is also available inside this image. So this will act like a template for us, and we will try to find this template inside this larger image. So let's get started and let's see how we can search this template inside this larger image. So first of all, what we need to do is, obviously we need to load this image and also load our template. So before loading our template image, I'm going to just convert my original image, which is the larger image, into the grayscale image. So I have declared this variable gray underscore image, and then I'm going to just say cv2.cvt color, which is going to convert my image img, and let's convert this image into cv2.color underscore bgr to gray. Now let's load our face image, which is called messy underscore face dot jpg. So I'm going to just change this name, messy underscore face dot jpg, and this will be our face image, or you can also say this is a template. And I'm going to also load this image as a grayscale image. So I'm going to just pass the second argument in the read method as 0, which is going to load this messy image as a grayscale image. Now in the next line we will simply use this method which is called match template, and we are going to save it into some variables. So we can just say res is equal to cv2 dot match template, which is this method which takes few argument. First is our image, so I'm going to pass our grayscale image here. The second argument here will be the template which we are trying to search inside this image. So this will be our template. The third is the method. So the method can be several method. There are several methods available for the template matching. So I want to show you these method for the template matching. So you can see type of template matching operations, and there is separate formula involved in order to match that template inside that image. So for now we are going to use this method which is tm underscore c cof underscore normed dot tm underscore c cof normed, which is this method. Now let's try to print this result, and let's see what is the content inside this result. So I'm going to just print the content inside this result which we got. So I'm going to run this code and this image is loaded, but for now we are interested in this array matrix which you are seeing here. So you can see when you observe these values carefully, you will see all are relatively smaller values. So you can see 0.2, 0.2, almost every value is around until 0.3. So the maximum value I can see here is 0.3. So let me just show this image once again and the template also. So what this result contains is these all values, and there will be one value which contains the number, for example 0.8 or the brightest point. Okay, so if here this matrix contains a value which have the value 1, it is the brightest point, and it will be there inside this image after applying this match template method, which will be around this point, at this point at which this template matches. So top left corner of this template. So at the point at which this left top corner of this image will match inside this large image, there will be a brightest point there, and that brightest point will be reflected inside this image in the form of this decimal number, and all the other values will be slightly darker values. Okay, so that's how this matrix, from this matrix we will come to know the top left corner of the template inside this larger image. So now how can we filter out that value which is the brightest point inside this matrix? So all the points you can see looks like under 0.3, but there are some points here. You can see 3 dots, and there are thousands and thousands of values will be available here. All the values are not printed. Okay, so what we are going to do is we are going to try to find out the brightest point. So this we can find out with the numpy method. There is a method called where, using which we can find out or filter out those values which are greater than certain number. So I'm going to first of all declare a variable called threshold is equal to, I'm going to declare the value of threshold initially as 0.8, which will be relatively brighter point inside the matrix which we are getting using this result variable, right? And then there is a method called var, numpy var. So I'm going to declare once again loc variable and then np dot var method, and here we are going to pass our result which we got, and we are going to filter out using this expression. So this will be a boolean expression. So I'm going to just say give me all those values which are greater than or equal to the threshold inside this result matrix. Okay, so this var method is going to just evaluate this expression. Each and every value will be evaluated, and if this value inside the matrix is greater than 0.8, which is our threshold, then it's going to give those values to us. So let's print out those values after the filtering out of most of the values, and let's just print this loc variable also. So I'm going to run this code once again, and you can see here this is the matrix which we got. So you can see this is the array which we got. So still we can increase this threshold in order to find out only one point. So there are several points available here. So let's say I'm going to increase this value to 0.9, and let's run this code again, and you will see only 2 points, 85 and 220. So this is what we were expecting. So we wanted to find out this point, which will be the brightest point inside this result matrix. So once we got the brightest point, which will be around here, which will be the top left corner, as I said, of this template, and it will be located somewhere here in the original image, then we can draw the rectangle around this original image, same as the size of this template. So this will be the easier task, because we already know the width and height of this template. We already know how to get the width and height of this template, and same size rectangle we just want to draw on this original image. So let's see how we can do this. So there is already a method, so I'm going to just declare two variables, width and height, and you already know the method. So template.shape is going to give you the shape of your image, right? So I'm going to just say template.shape, and then inside the square brackets we are going to just give 2 colons and -1. This means that we want to get the column and the rows value in the reverse order, so width and height. That's why I have given this -1 index here. Now in the next step, what we are going to do is we are going to just draw all the rectangles where the template is matched. So by seeing this template image and the original image, we know that there is only one messy face inside this image. But let's say there are several number of matched templates inside our original image. For that we need to iterate over the result which we got after applying the filter on the result. So for that we are going to just iterate over that result. In our case, as we know that there is only 1 point, so we don't even need to iterate over it. But if there are multiple number of matched templates, then this for loop will be handy. So for pt in your loc variable, so we are going to just say zip, which is going to iterate over this loc variable. So asterisk loc, and then we are going to find out the width and height here also. So we are just reversing the x-axis and y-axis, right? So we are going to just say colon colon -1 here, and then once again inside this for loop, so cv2 dot rectangle method, and the first argument here will be our original image because we want to draw the rectangle on the original image. The second argument will be the first point of the rectangle. So the first point will be this one pt, which we are getting using the LOC variable. So as you all know that the first point here will be the top left corner of the rectangle, and the second point here will be the bottom right corner. So how can we get the bottom right corner? We will get the bottom right corner using this pt variable, and then on the 0th index we are going to just add the width, comma, on the first index, so pt square bracket first, we are going to add the height. Okay, so essentially we have just found out the width and height of our template, and we are getting the second point using this addition on the first point, width and height. So it's going to give us this bottom right corner of this template or this point. So this is how we are getting our 2 points to draw the rectangle. Now the third and fourth variable will be simple, which are the color. So you can just say 0 comma 0 comma 255, which will be the green color, and the width, let's say 2 here. So we want to give the width 2 here. So let's run this code and let's see what happens. So I'm going to run this code, and you can see this red rectangle is drawn on the face of the messy, and you can here also see this rectangle will match our template image. So whatever image is inside this rectangle will be exactly same as our template. And once again you can see the result. Let me explain this code once again. So if this point, this threshold will be 0.08, let's say. In the case of 0.09 threshold, we are only getting two values, this 85 and 220, right? That's why we are seeing the clear rectangle here. When we are giving the threshold 0.8 here, let's see what happens. So I'm going to run this code once again. You can see there will be this rectangle, but it will be much thicker. Why it's much thicker? Because we are getting several number of values, 1 2 3 4 5 6 7 8 9. So we are getting the 9 points on the x-axis and the y-axis. So this for loop will iterate 9 times, and this rectangle will be drawn 9 times on the image, and that's why this rectangle is much thicker. Let's just change this value to 0.9 once again, and you will see this rectangle is the single rectangle. That's why it's much thinner, right? Now when you give this value, let's say we give the value 0.3, so most of the point, as you can see here, have the value 0.3, and when we run this code you will see so many rectangles here. So that's why this thresholding is essential for us to find out the brightest point or the value which have the maximum value, right? So that's why we were filtering out these points and finding out the values more than 0.9 threshold. And about the methods, so let's try different methods. So let's try to give different methods here. These two methods behave a little bit differently. So we can start with this tmcorr normed, and we can apply it here, and it's going to give us this kind of result. You can see we are getting several points here after filtering. So let's try to increase this value to 0.95, and let's rerun this code, and let's see what happens. So now you are getting 4 values. You can also filter that out. Let's say 0.99. Now let's see what happens. So now you are getting only 2 values. Okay, so you need to try to change this value to the maximum point. So try to change this value, and you will get this kind of rectangle, only one rectangle. So every method is going to give you different result, and that's why you need to try all the result. Not all the result will give you the perfect rectangle or template matching, so you need to try different methods on your images. So this is how you can do template matching in OpenCV. I hope you've enjoyed this video, and I will see you in the next video.